The Earth is very flat.
What's up, everybody? It is Friday, April 16th, 2021. This is Brandon, host of Brandon's Show. Hope everybody's doing good out there on this Friday. Tonight we've got Friday night fights for you, so you never know what's going to happen, but it will be limited moderation, and we'll see who pops in. See, we got a few people in chat. We've got Ian Adams, Tony V, YouTube, Balding Elf, Nick, Anthony Burrows, Bill G, Page 42, Squirrel Sniper, and Matrix Media. What's up, guys? How's it going tonight? Good. Bill G says sound is good. Thank you, Bill. Appreciate that. And if you want to support the show, you can do it through Streamlabs. Here's the link. It's always on the screen anyway, but here it is. And it's pinned to the top of the chat. If you want to join the show, come on in Discord. The link is in the description to the video. And you can come in and listen, or you can join in, your choice. You can also play with the chat trolls, who are abundant and very motivated, very dedicated to what they do. So come on in, and you can have hours of endless fun. Yeah. But anyway, let's see. There's a little bit of news in the space world. We'll talk about that, and we'll see where it goes from there.
He indicated he was doing one tonight.
I was talking to him earlier in the crypto room. No, I'm pretty sure there's a show here.
What's up, guys?
What up?
Yeah, there's a show. What are you talking about?
Yeah, his Illuminati meeting was last night, Bob. Come on.
Yeah.
Get it together.
Well, listen, I don't know what days you're gonna give in and take the NASA payment, okay?
Well, did you see that this we made a decision regarding the SpaceX contract?
No.
Yeah.
What's this now?
We had to take care of that, and it just hit the news. Of course, I knew.
Oh, okay. All right.
The Illuminati. Elon Musk and SpaceX have evidently done a very good job so far at the CGI work that they've done. I guess they're very happy with that over at NASA. They have won a contract to develop spacecraft to land astronauts on the moon.
Woo!
Woohoo!
Yay!
Yay!
The company beat out Blue Origin and Dynetics, a defense contractor.
This is all totally legit. Nothing to see
everything.
here. Move along.
It all checks out, bro. It's verifiable.
Oh, yeah.
I mean, this is MC Hammer too legit to quit shit.
Definitely,
you guys...
this world is definitely worth taking everything super serious.
Let me ask you something. Were you guys aware that some 10,000 grand pianos worth of space dust lands on Earth each year?
No, I didn't know that. I've always wondered how many.
Yes.
Yeah.
According to a new paper published in Earth and Planetary Science Letters, the finding emerged from 6 French National Scientific Research Center expeditions in Antarctica. Imagine that. Which spanned 20 years at the extremely isolated Concordia Research Station. Concordia made a great venue for spotting extraterrestrial dust because of the minimal amounts of Earth dust there, and despite being in Antarctica, a low rate of snow accumulation. You don't see this dust because it's minuscule, about 1/50th the size of a grain of sand at most. But annually, the researchers reported, 5,200 tons of the stuff falls from the heavens from a variety of cosmic sources. So, here's all this dust that supposedly lands on Earth, okay? But you guys can't see it because you're not in Antarctica and it's way too small.
Well,
Just
Bob,
on this one.
Bob, let me stop you right there. I knew this was legit when you gave the units and grand piano measurements.
Obviously, of course.
I mean, clearly,
It's the gold standard in scientific measurements.
Yeah.
Right?
If your measurement units aren't in grand piano units, then I don't know what you're even doing here.
What's the formula again? How many grand pianos per square mile of curvature is it?
Oh, that's
grand piano
that's awesome.
Squared.
I'm glad we know that now, Bob. You always bring the best knowledge.
I mean, we know what's happening. You said we know what's happening because
the researchers
happening 'cause
also
we can't
conducted
see
a
it, right?
chemical analysis to determine the origin of the space dust. They found that the primary source, 80% of the matter, could be attributed to comets. But the researchers also surmised that there's probably about 15,000 tons of dust that orbits near us before entering Earth's atmosphere. The researchers wrote that some of that dust may not come down to roost. So they were able to take the dust and scientifically analyze it to determine it wasn't from Earth.
Wouldn't that dust cause drag in space, or is it going with the Earth?
Listen, I don't think you understand how aerodynamic a piano is, Jeremy. You just don't understand.
Huh. So not only can they tell how much dust falls on Earth, but they know where it comes from, huh?
Listen to this.
Yeah.
Listen to this. Under the microscope, the particles look like forbidden bits of interplanetary cotton
Oh
candy.
my God.
Forbidden bits of cotton candy?
What?
Wow, that's...
Forbidden bits of interplanetary cotton candy.
the most scientific of terms, of course.
I can just see the writer like pacing back and forth in his own apartment. How am I going to describe what this dust looks like? Hours on end, and then he goes, I know. Forbidden bits of cosmic cotton candy. What the hell? Where did they come up with this crap?
I
It's
don't know. They got to get some new
imagination.
guys on this, though. I keep telling NASA G a day, and I'll fix all their problems. So
Pretty
holler
bad.
at me.
Pretty bad. Well, do you guys want to know what they're calling the lunar lander this time around?
Hopefully, what are they calling it?
Human landing system.
Human landing system.
Human landing system. Yep.
Hopefully, they make it look better. I mean, maybe they can get some kids in their teens to design it this time instead of some elementary school students to design it.
Yeah, and shell out a few bucks for material too. Don't just use scraps that were lying around the warehouse this time.
Right?
Seriously.
Right in
Don't
the
just
bathroom
grab
for
your
shower
5-year-old
curtains and shit.
kindergarten project and slap
Go
it
nuts
on
in
there.
Lowe's. Couple $1,000 in Lowe's will get you a long way. Home Depot, whatever you got. I mean, something. Don't use what was in your grandma's kitchen.
Yeah, Space Fakery has come a long ways from those days. Unfortunately, so has video capability and definition. So they're kind of fighting against themselves, but they've been doing a pretty good job with the stuff they've been putting out. I mean, you can tell it's fake, obviously, but still pretty good. Anyway,
Isn't it
that's
nice?
That's the big news.
That we have this bipartisan agreement that we should continue to shovel money at NASA for space exploration. How great is it that both sides of the aisle can come together to throw money into a pit and light it on fire, right?
Well, how would we ever get the fantastic advances that we've gotten from this space program, such as
right.
I was going to say Tang, but they didn't come up with that, or Velcro.
They
No,
did. Post-it notes. They didn't do post-it notes.
no, not post-it notes.
Post-it notes.
What else didn't they invent?
They grew lettuce a bunch of times. I know that, so that's key.
Space lettuce. Where else would we have gotten space lettuce from?
There's no way we would have figured that out right here on Earth. I mean, thank God.
Excuse you. Hey, listen, in space, it's pronounced lettuce. Thank you very much. Okay.
Lettuce, huh? Yeah, so, whatever. Elon Musk. He is what he is. Obviously plays a big role in the whole thing. Oh, I don't think SpaceX is a independent organization by any stretch of the imagination. I think that's.
Oh, aren't they subsidized crazy?
Oh yeah. Yep, for sure.
I know Tesla is. I don't know if SpaceX. SpaceX is.
Yeah, let's see where SpaceX gets most of its funding. Well, I think it's all government contracts, right?
Why wouldn't they?
Yeah, because how do you actually make money? You can't. There's no money in just Well, I mean, I guess if you're putting satellites up for companies, there's money in it, but
Yeah, that's true. Yeah. Yeah, I was just looking for where they get their funding from. $2 billion a year in revenue. Huh. I don't know.
Yeah, but they're
What do you
like
get?
they're not actually putting satellites up for companies. That's the thing. And even if they were, there's only so many companies that would require satellites for their business model.
Yeah. So what do you think about their Elon Musk internet?
What do you mean? What do I think of it? What are you talking about?
How do you think it works?
I think it works like the rest of the internet. I don't think it's special.
Mm,
come on,
so
there's a
worse
satellite
than,
link
worse like
system.
broadband?
Are you talking about some specific part of it or what?
Do you know what you're talking about?
Did they actually put something up there for their satellite internet,
Up
or is
where?
it all ground based?
Up where?
Up above your head?
Oh, above my head? I'm sure they have that capability to put stuff above my head. They do that all the time.
Cool.
I can walk outside and see buildings above my head. I can see trees above my head. We don't
Birds.
need SpaceX for that.
You're a very observant person.
I think you're really bad at asking questions or something. Like, what are you talking about?
You're talking about what's it called? That program that they have,
The Starlink.
Starlink, where they're gonna eventually put up like 40-some thousand. Well,
They
whatever
put
they
enough
are.
where they can actually provide internet, and you can purchase it now.
Yeah, right.
I was
It's
just wondering
poor
if
internet.
that stuff was compared to broadband. Yes.
Is that the
Most
same
of
one
the
that
stuff is.
they're having to spend like $1,500 to produce each unit, but they're only charging people $500? Because that just screams good business model and not suspicious at all. Definitely couldn't be that there's somebody with a grand plan that really wants people to have this particular access to the internet.
You're
That's
the
not
shit,
suspicious.
Bob. You're the shit, Bob.
It's okay. You don't have to worry about it because it's fake anyway. So
Have you tried that? Are you one of the beta testers, or have you tried out their
no,
Starlink internet?
I thought about it out of curiosity, but no, I've seen other people that have tried it.
Yeah. From what I read, it's not too bad. It was like 500 megabits. Yeah, not as good as broadband, but
Well, it's somewhere in between 100 and 200 plus, and download speed. It does cut out a few times apparently, but that's a major improvement from compared
Probably
to
from all the
using-
space dust. It's probably having trouble getting through all the space dust.
Yeah, those pianos they'll run hectic on the connection.
Yeah, it's mayhem up there.
Yeah, I would love for one of you flat earthers to find the Satelloons, track it down and expose the Satelloons.
but we've seen the Satelloons fall before.
Why
They
would
don't
we need to
deny
track
the
it down if they'll just
Sure
show
you
us
have.
floating
They
in
are
the
they're
air?
real. We know Satelloons are a real thing.
They don't. Yeah, it's not like they're denying.
That's as
Satelloons.
stupid as telling us to go find submarines to prove that they exist. We don't need to. We can just watch them go down in the water. It's not like they disappear from existence when they go under the surface.
Yeah.
You've seen those launches, haven't you? Of the Satelloons?
I've seen the launches of the stuff with the helium balloons that some people will call Satelloons, but I'm referring to the so-called satellite internet and satellite TV Satelloons. I'd love somebody to find them and find them before they fall. They should be pretty easy to find since they're stationary.
Yeah, these things are only a couple hundred miles up. Also, it's not like that's a solid debunk of Earth. It's like these things.
So
They're not thousands of miles away.
So they're about 200 to 300 miles up, huh?
Yeah.
Okay, so how come you never see anybody pull out a telescope and look at them?
Have you ever
pretty
seen
far,
those
isn't it?
invisible? Have you ever seen those invisible shields That I mean, you can make one of these
Oh
at. You can make one of
no,
these
I
at
don't.
home.
That's called a Star Trek sci-fi, buddy.
All
No,
right,
you could
Brandon,
just
bring
like
up a link of the invisible shields. They work off the Rayleigh criteria. It's known science. I know you're a science denier, but let's not get crazy.
You would want it to be
I know,
cloaked, though. I mean,
I
think
know
about it.
exactly.
You would
I know
want it.
exactly what you're talking about, but that's not
So
going to
why'd you
hide
say it was
a
Star
balloon.
Trek shit? If you know what I'm talking about, why'd you say it was Star Trek shit?
That's a fair question.
Because I'll tell you why. Because in order for you to work flawlessly, that would be Star Trek sci-fi stuff. Those so-called shields that displace light, they only work in certain conditions. We're talking about stuff that's up there, and you know, it's
Which certain
you're not gonna.
conditions do they only work in?
yeah,
Well,
you
I
got
mean, when you have
You don't even
patterns,
know.
when you
You
have
don't even
when
know
you
what you're
have
talking
patterns,
about, dude.
yeah, I know what you're talking about exactly. When you have something with patterns, if the patterns are not symmetrical or something, you can tell really easy that there's one of those so-called shields in front of them.
Yeah.
It only works with either simple patterns or with the no patterns. You know,
Well, I mean, I know you know
solid
all the
colors.
technology that the government has, right?
Okay, so yeah,
Well,
You know
instead
all
of-
the technology that the government has.
wait here. How
I know
about
there's
this
a lot
one?
of people over in Gems that think they know everything that happens in every building ever. But are you one of those
okay,
people?
okay. With your logic, you know, most people know that
What
after 10
logic?
years, listen, there was a whole logic
Name a
about the
syllogism.
with the whole thing about the military having technology we don't have. Most people know that after 10 years, the general public gets a whole lot of technology, right? For the most part.
No. Why?
Yeah.
Why? How do you know that?
For the most part, you know,
How do you
it
know
takes
that?
about that's the claim.
Who's claim?
Yeah.
Not
Anyway,
mine.
okay,
Did you
so
Did you just come here to
okay,
make shit
all
up
right,
all
fair
day?
enough, fair enough. I cannot. That's a really bad analogy. Well, let me put it this way. So they've had this thing developed for what 50, 60 years now that they had satellites up there. They had these invisibility cloaks or invisibility shields. Really, you think they've had them that long?
Yeah, this is
I
getting
don't
too
know
crazy.
what technology they do or don't have. Neither do you. You think you do.
Then
but
why are you
don't.
saying that? But then why are you asking me about invisibility shields if you don't know what they have? You know, go ahead.
I'm just saying, could they have some technology you don't know about? Is that a feasible scenario or no?
If they can use the technology to hide if they can use that technology to hide a balloon, which is the size of a freaking I don't know what, a big old water tank, why the heck they don't use the same technology to hide airplanes and aircraft?
Yeah,
They would have never done
listen,
that.
Jeremy.
That's
listen,
recently been
they
in the
got
news.
Jeremy. They have devices that can see light years into space and spot invisible black holes that no one else can detect in any way, shape, or form. But they certainly don't have a cloth that would somehow reflect light in a way that makes the balloon less
Dude,
visible.
you need to stop
That's
watching
ridiculous.
Star Trek, man. You need to stop watching sci-fi, man.
You're
Yeah, you could go to the
That's science fiction. You
acting
you
like
claim
this
that
is
the
an
ballers watch too much science fiction. Listen to what you're saying. Invisibility cloak. What is this? Harry Potter?
You could go to the Wikipedia page, type in balloon satellite.
Harry
it breaks
Potter
them all.
isn't science fiction.
I'm already playing it right on the screen, and it's from NASA.
Okay, there we go. Go.
See.
They got all who invented them, what
Okay,
they're
so how
used
they-
for,
How
all
are
the
they hiding
data.
that balloon?
Hmm?
How are they hiding that balloon? Like,
Why do they
how are
need to
hiding
hide
that
it in the
balloon?
first place? I don't understand. You're looking at something you think hundreds of miles away. What makes you think you're going to see it?
It's reflective.
Here's my proposition.
Look at it.
Listen,
it's
here's my
reflective, dude.
proposition. Figure out, guys. Listen. Figure out where your satellite dish is pointing at, and then get a telescope or P900 and zoom in where it's looking at, and see if you can find something.
Can you find something? Supposedly you tell us that there is a satellite up there. Can you see it with a telescope?
Yeah, I can see something, but not a balloon.
What do you see?
What do you see? A speck of light. So what do you think we would see if we pointed our telescope up there? Do you think we'd see something different than you?
Well, no, you see the same thing, but you won't see a balloon.
How do you know?
It's a speck of light, you said. How the fuck do you know what it is?
Well, it's not a balloon. How about that?
Oh well, it's
your
a
How do you
speck of
know?
light, but it's not a balloon.
It's your burden of proof. You prove that it's a balloon.
I don't need to prove it's a balloon. I didn't say it was a balloon. But you're being
What is it then?
ridiculous.
What is it then?
Is it
Like
then?
show a balloon launch.
Oh God.
What
The show's
are
fucking ruined
satellites? Is that what your question is? What are satellites?
Yes.
Some kind of
Why show a
electronics
balloon launch if you're
equipment
saying-
being kept up in the sky via some kind of technology. There you go.
Some kind of
Yeah,
technology.
there you go.
Yep.
Like what?
Like orbital mechanics. Does that work for
Yeah,
you?
like
Yeah.
over-
No,
No,
falling
no
falling
orbits.
continuously around the Earth. No, it doesn't work.
Well, actually, it does.
No, it doesn't.
It does.
It's
What is
nonsense.
it then?
It's
Then
absolutely
what is it then?
nonsense.
Not
So
nonsense.
what is
Total
this
nonsense.
technology?
a balloon. It would have to be
Well,
a
what
balloon
is it
or a
technology?
drone.
Could be a
Because you
balloon,
don't
could be a
understand.
drone, could be some
It literally
technology we're not
meets
aware
the
of. I don't
definition
fucking know.
Nonsense. You cannot sense it happening. So it's literally nonsense.
So it could be any technology, but you don't know what it is yet. It cannot
I
be.
just named two or
what-
three
what I'm saying is-
technologies. I don't know
Well,
all the
the main
technologies
element-
they have. I imagine that would be pretty sensitive information. How you keep
Sensitive.
something up
Whether it's being
indefinitely in the
shot
sky,
Big
because you could keep
question,
a bomb or a missile indefinitely up in the sky, or a fucking laser or whatever.
That's against
Brandon,
the law.
can I-
They
We
tried
can-
it,
we're
but
not-
no.
Can I ask you a
We're not going to
question,
go anywhere with this, but I'll say this.
Well, yeah, because you want me
quickly
to know
refuse-
all of the government secrets, and if
Speaking
I
of
don't,
sensitive,
if I can't
somebody
tell
jumped
you
in here real
exactly
fast
what
when we
the
started
government
talking
is
about
doing,
those launches and showing them.
Brandon,
I mean, you
can I
don't
ask
know
you a
what's up
relevant
there.
question?
You just said it's a speck of light.
Well, the thing is, you say that it's going too
So when
fast
you
for
look at
regular
our
ways
shot
of
after the-
propulsion. But at the same time, you're
I
saying
know I
that
gotta
gravity
really
is
get
strong
Mike,
enough to
but-
slingshot it over the Earth at thousands of miles per hour with no propulsion. Isn't that kind of contradictory where you're saying the propulsion that we have on file is not powerful enough to propel it over the Earth at
I
this
didn't say
speed,
nothing.
but gravity can slingshot this, satellite over the Earth at any speed you need? I mean, isn't that kind of,
An argument from incredulity. I love
Contradictory?
it, Lemon Bird. I love
it's
Lemon Bird.
contradictory.
You have anything besides incredulity,
Gra-
too?
It could be
Gravity
we
alone
have
is
seen
not
it fall out of the
what's keeping
sky
it
with
in
a balloon
orbit,
attached.
knucklehead.
That's not too incredulous if we've seen it fall out
Actually,
of
it
the
is,
sky
but
with a balloon
speed,
attached.
too.
That's not that.
No, it's an
incredulous.
argument from your argument is retarded that it's possible.
Yeah, like an argument from incredulity.
Right.
Got it.
No. An
Okay.
argument that you're
Hey,
acting
Master
retarded
Joe.
by claiming that it's possible.
An argument
Can
from
you
incredulity. I got it. Thank you.
demonstrate an orbit?
I mean, I guess it could
in
happen,
any
but we have,
fashion?
satellites falling out of the sky attached to balloons, so it's probably a satellite.
Those are not satellites, moron.
That's a distinction without a difference. We've seen something similar fall out of the sky attached to a balloon.
Yeah, they're research balloons
Really?
and weather
So you're
balloons.
saying that there has to be something slingshot by globe gravity hovering over the Earth.
I'm not saying
find
I'm
that
not
hard to
saying
believe.
that. What I'm saying is find how the heck those satellites work. How
We
does
have satellites.
geosynchronous satellite? Yeah. Okay.
Why do we need to? We don't need to. What are we going to prove? What do you want us to prove?
That the
Why
Earth
do
is
we
flat.
need to prove how satellites work? I don't understand.
I mean, I've seen a balloon hover in the corner of my room for weeks. There's your satelloon right there, hovering in the corner of
Oh,
the Earth.
in your room without any winds and all that. Got it. So we go from your room to the Earth. Got
Oh,
it.
is there
That's really good
winds
one.
It's in a still
250
place with
miles
no
up,
wind.
Dumbo?
A still place with no wind up high before the wind blows it
Yeah,
out of the sky.
you
and you have
need-
the
you
satelloon
need
crash.
very-
How about that?
You would need very little propulsion to keep a balloon in place once you get to a certain point in the sky.
No doubt.
There's not a lot of winds once you get over
My
like the
thi-
jet streams and shit.
My thing is that if it's not orbital mechanics, then what is it? And nobody has been able to prove that it's not orbital mechanics, and they're not.
We
what they
don't
say
have
they
to
are.
prove your claim. Why
So
would
you're
we
looking
have
for
to
other
prove your
possibilities.
claim? Why don't you prove
You
your
don't have
claim?
to, buddy. I'm just asking. I'm just saying. I've yet to see
Okay, so-
anybody.
Can you
say
just
anything
prove?
convincing? Listen, I've yet to see or heard anybody say anything convincing other than showing footage of people putting research balloons and letting them go. Oh, that's it right there. That's the only proof that I've seen so far. Nobody has
All
shown me
right.
say, hey, this is where these things are located.
Yeah.
I can show you because of this math right here, and I can point this, and I have no. It's all
Yeah,
a video
we heard.
of somebody releasing satellites. I mean, balloons, not satellites.
Math and pointing. That's definitely
Yeah.
good evidence.
So if I
Yeah,
show you
so,
some
yeah,
math
trigonometry-
I
and
haven't seen anyone.
you'll believe me.
The other possibilities are ionic wind. You can float objects based off of ionic electromagnetic wind. It's probably up there floating on a huge draft of electromagnetic ionic wind or something else.
Or something else. Yeah, anything besides orbital mechanics. Got it.
Yeah, I got something for Carlos.
Orbital mechanics would say that you can slingshot an object around another object based off of low gravity. That's extremely mystical.
No, it's not. It's very simple math.
So you're saying no force, just this gravity force is enough to slingshot it over the Earth at the speeds necessary?
Yep.
I thought gravity wasn't even a force.
Actually, no, you have to get it to the speeds necessary, and then gravity takes over, but good enough.
So it can just fall toward the Earth at 17,000 miles per hour or whatever to keep it in sync with the Earth? I find that hard to believe.
Of course, it's an argument from incredulity, I understand.
Yeah, Paid has a good point there. The math for this orbital mechanics stuff is actually very easy. There's very few variables in it. The issue is if you ever get them to actually want to do the math, then point in the general direction of wherever these objects are, like Starman, they can't do it. I had a bet on one of the last things that happened before I got banned from Nathan Oakley's server. I was talking to a globalist. And I said, certainly, Starman would be an experiment if you put something in orbit around the sun and could track it and use Kepler's laws to tell me where it is right now and just point in its general direction. Look up at the sky and say, it's that way. I would be like, that's pretty solid evidence. And he couldn't do it. He couldn't even figure out what direction it would be. He just kind of like broadly said somewhere up in the sky. I'm like, so with all your math and all your orbital mechanics, you couldn't tell me which direction from like 180 degrees.
Cool story, bro.
Yeah, could you do it? Anybody. If someone could, if you can't do it either, then why claim you can?
I just said cool story, bro. I don't.
Yeah, look up Kepler's laws. They're not that complicated. They're actually very easy. The math is very simple. It's like junior high level algebra.
Yeah, but do we get a practical demonstration?
So take the facts and figures, figure out what day they launched, plug in the distances inside your own model, pull out the compass, boom. Show me which direction it is.
Well, I'll tell you what's also simple is a trigonometry and triangulation. And like I said, you can.
What's your point?
My point is, why not use that to prove the location of these satellites?
Use trigonometry to prove the location of something in the sky? How the hell are we going to do that?
We're saying something's in the sky.
With trigonometry and math, it works.
Yeah, we're saying something's in the sky, sure, but it's not being slingshot over the Earth by low gravity.
That seems to be the thing going on tonight.
But the thing is, it's not essential to the argument of the Earth's shape. It's incidental. Something's up there over a flat plane.
What's ridiculous about using trigonometry to figure out where something above in the sky is?
Yeah, try it.
The only thing that's essential is whether or not this globe-making, gravity-making force is sufficient to pull the satellite over the Earth and make it a ball for the globe Earth argument. That's the only thing that's essential. Otherwise, there could be something up there by another mechanism. That's it.
Yeah, let's see you use trigonometry to tell us where something is in the sky. I'd like to see that.
Well, I went ahead and live streamed.
Oh, Bob, you're cutting out, Bob.
His Starlink isn't working.
The car 47,000 kilometers away. There you go.
You're cutting out, Bob.
Did I not move car-sized satellites for you 47,000 kilometers away the other night with the telescope, Brandon?
What is your point?
How do you think I found them?
Yeah, that's the thing too. How do you tell distance through a telescope?
You had a computer program that made your telescope point to where the stars were?
The satellites were, yes.
And how did that figure that out, Brandon?
It was programmed for it? I don't know.
In what? Using what? How do you program stuff?
Why are you asking me stupid questions?
Because
what's your point?
Because it's not a stupid
question. I asked you. You said using math. It uses math.
So what? It uses math. Do you think
I deny
that fucking math works?
There you go.
Yes.
Do you think I deny numbers? Hey, you can't use numbers for anything. You can't use math to figure anything out.
That's correct. You
That
deny
is
math
so
and you
fucking
deny.
stupid.
You say
Nice
you say that
steal,
whenever
It's
man.
not essential.
you say that whenever you say that trigonometry doesn't work.
I have
Brandon, I know I
never
got it.
Sorry
once
to
said
trigger you there,
trigonometry
Brandon,
doesn't
but,
work.
You know,
Yes, you do all the
What
time.
you
What are
guys
you
been?
talking about?
You guys been getting together in the
but,
back?
you
Let's
know,
get.
it works.
Let's
All right,
say
I'll tell you what,
that he
Brandon.
says trigonometry doesn't work.
Okay, Brandon, I will be quiet until the next time you say trigonometry doesn't work. I'm sorry.
I've never said trigonometry doesn't work.
You just said, how do you figure out something in this? How do you figure out the distance of something in the sky? That's basically you're basically using trigonometry to do that.
I didn't say that. No, I didn't say that.
But that's how
Okay,
you.
well, here-
That's how you would figure out how high it is.
Let's
No,
go back
no.
to what we were
I would
talking
like.
about,
I
bro.
would like to see you use trigonometry to tell me where something is in the sky. That's what I said.
Yeah,
Talk
like
to me.
Polaris.
I did
We
that.
talked about Polaris
I
the other
did
day.
that
Yeah.
when I live streamed satellites.
Can I?
No, you didn't.
What did I do then?
You showed us your telescope, a view through your telescope, and a program that slew to the star that you told it to go to. That's what you showed us.
And how does that work?
I was glued to the satellites. Yes.
Whatever.
By knowing where they were. That's
So
how does-
what?
How does it know where it is, Brandon?
It was programmed with the locations. I don't know. What is this? What is your point? What does
Using
this
math
prove?
and trigonometry.
It knows the orbit of the satellites, and it knows my location. And between the two, it can figure out exactly.
Do you think that if they had something up in the sky that they wouldn't know where it is? They wouldn't know how to track it as it went around?
Yeah,
They wouldn't know how to program something to say, okay, at this point in time, the satellite will be over this location, and if you point
You think
this
it's got big
direction, that's where you'll see the satellite. I mean, no one believes
way
that they
it
doesn't
does
be able to
that
do
is
that.
by knowing
What do you
They
think?
do
There's
it
like a
by
huge
knowing
database.
orbit.
I know there's a huge database, of course.
So there's a huge database of every satellite's position every second of the day for the next how many?
There's
No,
a,
I'm
it's
sure
there's a
there is, yeah.
database of the satellites.
No, they use math. They use math. They use trigonometry. They know the orbit of the satellite. They know where you are. They
Are
use
you
math and
saying that
trigonometry.
they do the math by hand every time they want to figure out where
No,
it's supposed to be? Is that really what
can.
you're claiming right now?
You're
No,
a
I'm saying-
We know the orbit. We know the time.
We have machines to do that for
So
us.
you know the
So
pattern
they
it
already
goes.
had
Where
it
it would
figured
be.
out, just like Brandon said. It's already been programmed and it's in a list somewhere, so they don't
But then-
have to do that. You
This is
just
really
No, but then you can
indicated
use
they did
math to
exactly what he
verify.
said. Thank
You
you.
No,
can
they
use-
don't
you
look
can
it up in a
use your own
database.
math.
They figure it out with a computer using
Yes,
math
and
and
you can use your-
trigonometry.
And then you can use,
The computer
then you can use
is
your
the
own math
database,
to
retard.
verify if that's
It's
correct.
not a database. It's math. You think they got a database
Guys,
of everything that
guys.
sits there by second?
The computer has a database of the orbital parameters.
Oh,
And then you add the time in,
huh.
and it tells you where the satellite is.
I'll be darned.
And it
So
tells-
the
but-
database
hold on.
tells you
Then-
the pattern of the satellite as it moves
Then
over
you
the
could
Earth,
use your own. Then you
Correct.
can use your own math to
and
verify
then
if that's
it uses
correct.
some logarithm or calculation to know which way to
Math
point.
and trigonometry. Yes, math and
No,
trigonometry.
okay, show it to me. Do it with some. Bring up your screen and write it out and show us how you would do it. Show us a little diagram of how you would do it.
You want me to do what the computer does for you because you don't think the computer does.
No, I
right?
want you to
Right.
say that you say that it can. That's how it works. I want you to show me how it works.
Look, Brandon, let me bring you back to basics now. This kind of stuff
Oh, I
can
don't
go
need
over
to
your
be
head.
back
No
to
pun-
basics. No,
no
thanks,
pun intended.
Carlos. No, that's okay.
no,
it's
no,
unnecessary.
Not that way. No,
Uh,
sorry.
no, I'm already past basics. I don't need it. Thank you.
Yeah, no, Carlos. How about we stick
No,
with
I
what he
think you're
claimed he
still
could
on
do?
Can I
basics.
explain
He's
how?
done.
No, I
Can I
think you
explain
guys
how
don't
trigonometry
even know
will
what you're
prove?
talking about.
All right. Well, I can't even.
Are you gonna try to?
Well, I'm trying not to say something too.
Do you think that I need you to tell me how trigonometry works? Is that what you think?
And that's why I'm hesitating because I don't want to sound condescending. I know that's not my point here. That's why I'm calculating what I'm going to say because I don't want to come across like that. But I said that you can use trigonometry to figure out how far up and how high those things are, right?
Okay.
And my thing is like, okay, if you guys claim that it's not what we say it is, they're not that far away, then use trigonometry to show then how far above our heads those things are. And it's as simple as, for example, you want to know how tall a tree is? Well, you look at it and you try to look at it at a 45-degree angle until the 45-degree angle hits the top of the tree, and then you walk from that point towards the foot of the tree, and the distance you walked is the height of the tree. Trigonometry. So
you're talking
you can do
about
the same thing
physical
with
measurements. So you walk, you get the physical measurements, and then you know how tall it is. You got physical measurement.
Well,
trigonometry,
that's a concept.
Describe to me. Describe to me how you're doing it on Earth. Let's say there's a building that's 1,000 feet tall and it's 10 miles away. How are you going to do it on Earth in reality?
This is what you do. You measure the angle from when you're standing to the top of the from 0 degrees to the top of the building, and then you measure that angle, and then you move closer. You move closer to the building, and then you measure. You measure how much you walked, what distance you walked towards the building, and then you measure the angle again to the top of the building.
Hold on. Oh, really? So you can do that in reality for a building that's 1,000 feet tall and 10 miles away and get the right answer? Can you do that?
You can do that for anything.
Really?
You can do that for most things.
Well, can you describe to me, are those the steps that you would use? Is that how you would do it? Would I get the right answer if I went outside and did that right now? Would I get the right answer if I went outside?
You'd have to take into account the curve of the Earth.
Oh, you have to add something else to it, so it doesn't work.
Well, yeah, because it's not a flat surface.
I got you.
Right.
Step one, assume you're on a ball.
Bob.
Got it.
Hang on, Bob. To be fair, even if you don't calculate for the curvature, if you try to do the same thing with a satellite, you're still gonna get a distance way higher than what you're claiming, and still So that's what I'm saying. Just try it out, do the math, and figure out how far those things are, and work, and then work it from there.
Why would I do that?
Because I've yet to see anybody show the proof that it's not a satellite. It's not 22 kilometers, 22,000 kilometers, or
but I don't care how far satellites are away. I don't care.
Fair enough.
So what? Why couldn't something be 22,000 miles away? Well, why would that be impossible? Explain that to me.
For you, isn't that very convenient for you?
No. Why couldn't something be 22,000 miles above us? Or 22,000 miles away from me and up in the sky? It doesn't necessarily have to be at an altitude of 22,000 miles. Why couldn't something be that tall or high?
Who said they couldn't?
Exactly. That's my point. So what point are you guys trying to make? Who cares? Okay, let's say I go out and figure out how high up a satellite is. So what? Okay. Tell me how high a satellite is up. You say 22,000 miles? Okay, cool. It's 22,000 miles. So what?
The ones I showed you were 47,000.
Do these people don't know?
Sure, 27,000 miles.
Don't know.
Here's the thing, Brandon. If I tell you the elevation or of the height of that satellite, and then you claim the Earth is flat, then calculate, what angle would it be if according to your location in a flat Earth, and then come back with me.
You can't. Because you're mixing two things together. You're trying to apply trigonometry to site-based angles. It doesn't work.
It doesn't.
It doesn't work.
But let's take a step back. You don't use trigonometry on Earth. You just told me that you would have an error for a building that's 1,000 feet tall and 10 miles away. You told me you would have an error, and then you would add Earth curvature to it. So you don't use this methodology.
There's no error. Not an error.
There is. There is a difference. You don't use trigonometry to get the heights of buildings, do you?
Yes.
No, you don't.
Why are you telling me no when I just said yes?
You don't, because you've already described how you do it. You've already said you have to take the Earth curvature into account. That's another addition. So you're not using trigonometry. You're using trigonometry, and then you're adding your Earth curve value.
No.
That's a different calculation, is it?
No, it's not.
It is.
All right, well, you can
draw it on a piece of paper for me. Is it still a triangle, Bob?
Yes, it can be.
Really? That's interesting.
Of course it can. Yeah, I mean, think about the.
Is it a right angle
Make them
triangle,
do a
Bob?
diagram.
That's a triangle.
Is it a right angle
Get out your
triangle,
whiteboard,
Bob?
It's a
Get
right
out
angle
your whiteboard,
triangle.
Bob.
Oh,
Yeah, what about it? It's a right angle triangle. What's your point?
go ahead, draw it out for me.
You can watch the video when it comes out. I'll have it all out on paper right then.
I'd love to know how you're making site-based straight lines too, because that's weird if you're not. So there's no refraction.
Easily. Is refraction not accountable?
Doesn't even matter if there's refraction, Jeremy. They don't use
How much
trigonometry.
refraction is there? How much refraction is there on a 90-degree observation, Jeremy? Zero.
I thought you were talking about building height.
I was actually speaking of the transit of Venus. But yes, we can use building height, and depending on how large the angle is to the top of the building, that will determine how much refraction we need to do.
The transit of Venus to what?
The transit of Venus.
Across the moon or the sun?
Venus is? The sun.
The moon, the sun.
How are you going to get a transit of Venus across the moon? That's a great
point.
How
Good
will
point.
you get a transit of Venus on the moon?
That's a good
I
point.
will say-
So you're looking at this 90
You
degrees
won't
when
get
you're
a
doing it?
transit of Venus on the moon, will you?
No,
I will
shit.
say a lot of. I will
So
say a lot of
you're gonna-
refraction
Hold on
though.
a second,
You
Carlos.
think that you're going to get a transit of Venus on the moon?
I'm
I
there,
fucking
bro.
I misspoke. Shut up, Bob. So you're
Jeremy.
looking 90 degrees when you're doing this?
You can, yeah.
You still have
Let's
refraction.
see it.
Jeremy, you still have refraction. It's going through hot and cold air. It's going through.
How much of an angle? How much of an effect does refraction have at 90 degrees?
That's the point. How do we know? I mean,
Zero.
it's going through different
So
medium.
you're just viewing Venus from 90 degrees and getting what out of this?
You can view it at 90 degrees,
And
and
then
part
what?
of that's one of the observations in the transit of Venus.
You think it's at
What
90
does that
degrees?
give you? That doesn't get you anything. What does that give you?
You need a second point. You need a second
Is that
point.
going to be? Is that second point going to be 90 degrees, Bob?
It's going to be a matter of arc seconds off of 90 degrees. Yes.
All right.
So until you can tell me how much refraction would be involved in a matter of, say,
Enough to not make a straight line.
6 arc seconds, well, you have to tell me how much it is.
Enough to not make a straight line.
How much?
I would say. I would say it's the opposite, Jeremy. I would say it's the opposite. Until they demonstrate that there's not enough refraction that it won't matter, then you can go ahead and keep going with your maths. Otherwise, your point is no.
Otherwise, we're just gonna pull some shit out of our ass and say, "Oh, it's refraction."
Well, no.
Well, there is refraction. That's a fact of life. I'm sorry you don't like it when it doesn't fit your narrative.
You show us wrong.
You need to figure out so that you need to figure out so that your maths are correct. That's on you to do it, not me.
So there's refraction at 90 degrees?
Yeah, there is the light coming through cold and hot air.
No, he said not.
Hold on.
Refraction at 90 degrees.
It is.
This
How
is
much
new.
refraction is there at 90 degrees? I really want to know.
That's for you to figure out, or you just
I have
gonna
figured it out.
dismiss it.
You can't figure out zero.
You cannot figure out. But tell me this.
Zero.
Let me ask you this: is that light coming through hot and cold air?
Doesn't matter. It's at 90 degrees. It will not refract.
What? That's what you think.
Silent Zero's making shit up as he goes along.
You can
affect
declare
refraction.
it as much as you want. Hey, you can declare it as much as you want. You haven't proved that it's not. There's no refraction.
You don't know what if you had any idea what you were talking about right now, Silent, you would be embarrassed.
Yeah, you really should be. I would probably stop talking.
Yeah.
Can you see my screen?
Silent Zero brought up a great point.
Can you see my screen?
Actually, he didn't, but go ahead and tell us what.
Can you see my screen? Yes, no? Can you hear me?
We hear you.
I hear you, Brandon. I don't know. I guess you're asking them, but they're not watching.
Anybody? Bob, can you see my screen?
Yeah, I've got your screen. You got a white. I can see it.
Cool.
You got a white planet and green man and a red building. It looks like.
Here's you on the top of the Earth.
Yeah.
All right.
Yeah.
Now, tell me what you're going to do to figure out how tall this building is.
Well, you run a line of sight to the top of it.
Okay, so you got your line of sight to the top.
Great.
All right. So you got this sight right here. Okay.
Very good.
Now what?
Yeah.
And you're judging what from that line of sight? When you say you got a line of sight, what are you doing with this line of sight? You're just looking at the top of the building, or are you doing something else?
You're measuring the angle to the horizon.
All right.
So measure the angle to the horizon.
Let me add a horizon here.
No, you've got a horizon.
No,
just draw a tangent line from your.
Shut up.
Yes, you do. Draw a tangent line from your eye to the sphere.
Here's your horizon.
Don't tell me to shut up.
Well, then don't try to talk over me and fucking boss me around.
No, that's not how you would do it.
There you go.
That's not the horizon.
You're only
Well, then
no,
how would the horizon work?
Exactly as I started to tell you before.
So this right here, you think this is where the horizon would be?
Run it from your eye down to the and run it from your eye tangent to the ball.
Okay, so you want it like this?
Yes, very good.
Yes.
From your eye. There you go. That's it. Good job.
Okay.
Okay.
Definitely not going to be any refraction with this.
When you're looking out into the distance, do you look down, Bob?
What's your question, Brandon?
Yes, you look down. Very good.
Oh, you look down?
Yeah, you look down. You ever been on a mountain and look down? Yeah, that's how it works.
Would you even be able to see this on your model?
Yeah, why not?
Oh, okay. All right, so now what?
Silent Zero, I appreciate
Measure the angle.
Day.
That's it? So I just take this angle and go, okay, I know this building's this tall.
Do you know the distance? Do you know the distance from your eye to the bottom of the building?
Yep, it's 10 miles.
Oh, okay, so now you put 10 miles on the bottom and you put the angle by the angle next to your eye and solve. And all you have to do is take the sine of the angle, and there you go.
So you've got the angle here, you've got the distance, and that's all you're going to do.
Yep, that's all you need.
Did you take your?
Didn't you tell me earlier about adding Earth curvature, Bob?
What about the refraction at the horizon?
So how come you're not mentioning that part of it? Why are you adding Earth
curvature? Because
curvature?
the way you have it written, the way you have it drawn is there's no Earth curve to take into account because you've got. Yeah, it's pretty simple to do. Do you agree down there by where it says 10, just to the left of it at the base of the building? That's a right triangle?
So if I draw him down here, now you're going to do something different?
No, you got to curve the line.
No,
now you're going to put the thing right here, and he's looking out here.
No. First of all, you're below the surface of the Earth. Go up above the surface.
You know, you're
of the
being
Earth.
awfully particular about how I'm drawing this diagram, and you're being pretty pedantic about these questions I'm asking you.
Brandon,
first you had to add the Earth curvature to it, but my man was 700 feet tall, even though this is just a diagram. We both know it's just a diagram.
You got to curve that bottom
what are you going to
line.
do now, Bob? You've got 10 miles to the building, and you've got your angle. Now what are you going to do?
So it's very easy to see what part of that building you can see, correct? You can just see the top half of it, correct?
It's a diagram, Bob.
Yeah, but you can see the top half of the building, right? You can't see the bottom half of the building because it's below the curve of the horizon, correct?
Never mind, Bob.
I know. Math is tough.
It has nothing to do with math. It's just you're ridiculous. I'm chasing my own tail.
Brandon, just a quick question on that diagram. I know there were the two straight lines from the observer to the top and the bottom, and they're portrayed as straight lines, but in ball world, they'd both be subject to refraction.
Big time at the horizon.
To the point, so they wouldn't be straight lines, they'd be curved. Therefore, you would have no ability to triangulate because your lines aren't straight.
Exactly.
Well, yeah, that also.
Well, Brandon, if you ever want to try and go up against me in math, just let me know.
Yeah, Bob.
Because I can
That's
show
what I
you
dream
this
about is
We'll go
beating
up
you at
against
math.
you in
That's what
reality.
that's how we'll prove that who's the better man is. We'll have a math competition. That sounds really dumb. But okay, I'll let you know.
Well, just let just let me know when you're ready. When you feel up to it.
Oh yeah.
Who's gonna do the test? Who's gonna put down the test? Two plus two.
I mean, that line at the horizon could be crooked as fuck with the refraction. So could the line at the top of the building could be super crooked. You have no idea. They
How
can't
much will
prove
it curve?
What's up?
How much do you think it'll curve?
Enough to not make a straight line.
And how much would that be?
Enough to not make it a straight line, which is what you need, straight lines.
How much would that be, Jeremy?
Do you need straight lines?
How much would it be, Jeremy? How much error would there be?
Do you need straight lines?
How much error would there be?
Error is too much. How much
again?
Error
They're switching the burden on proof again.
How
No,
much
you
error?
use mathematics.
I'm sorry, you're making.
Oh
a triangle.
well,
Do you need straight
exactly.
lines?
If you don't take into account all that stuff, then your
We've already
maths are
proved-
wrong.
So wait a minute, Simon. We already proved you don't understand refraction, so you should just be quiet for this
No,
discussion.
no, you're a stupid person. That's what you are.
I'm a stupid person. I understand
Yes, you
refraction.
are.
You don't.
Let's say it curves.
I do
by 2
understand
arc
refraction.
minutes. How much
Then
of
what's
an
the
error
refraction at
will that
90
be?
degrees then?
You just dismiss it because it doesn't fit your narrative.
What's
That's
the
why
refraction at 90 degrees,
How
sir?
much? Yeah.
I don't know.
How much
Exactly.
error will
Shut
2
up.
minutes? Will 2 arc
Neither do
minutes?
you. Neither do you.
Yes, you
But
do.
you're doing.
Yes.
Neither
Yes, I
do you. But you're doing maths.
Yes, I
No.
do.
How much is it? How much is it?
You look it up. You Google it. You find out.
It's
How about
actually
you tell
about
me?
2 arc
Since
minutes.
you said you know
about
it.
2 arc minutes. It's about 2 arc minutes. So tell me how much of an error that will induce.
How do you know?
Enough,
How do you know?
Bob, it's going to be
if-
enough to not. Bob, it's
How
gonna
much
be
is enough? Give me a
Bob,
number.
It's going to be enough. It's going to be.
Give me a
enough to
number
not
that
make,
you can
Can you let
justify.
me finish my sentence, please? It's going to be enough to make it so you don't have a straight line, which is what you need for this.
Not really. How much?
Oh, you
of an
don't.
error
So you
will
don't
that
need straight
induce?
lines. You
How
don't need
much
straight
of an
lines when
error
you're
will
making
look,
a triangle.
Yeah, you can either tell me how much error it will induce and then show me how that error will be significant, or else I'm going to ignore the rest of your blithering.
It's going to be significant enough to make your line not be straight, which is what you need,
Prove
straight
it.
lines.
Prove it.
Are you saying refraction doesn't happen?
I'm saying you have to
we see
prove
straight,
how
if
much
we
of an
see-
error there's going to be.
If we see in straight lines and the black swan kills you.
No, he doesn't. You would have to prove that your way works.
I can't. All I have to do is sit down and give you the correct number, and then you can measure it and tell me how much I'm
So
off.
the fact that you guys don't understand the errors means you can just say anything you want about unicorns, and then we have to prove there are no unicorns, right?
No, the fact that we're human beings means we can say whatever we want. That's just something that human beings
So
can do.
you can come up and say, what about unicorns? And then you're gonna make Bob prove there are no unicorns. So what about fairies?
Yeah,
And then you make Bob prove there are no
absolutely
fairies.
can do that if I want
Yeah, that's
to.
what you're doing now. Basically, that's what
And
you're
Bob
doing now.
doesn't play that game.
What are you
And
gonna do
Bob
about
doesn't
it?
play that game.
The bottom line is you're not going to make a straight line because there's going to be refraction.
Bottom line is you have to show me there's enough of an error to make a difference.
No,
Hey,
you have to prove
any-
there's
how much
not.
error
No,
there is.
this is
Any
no. That's
refraction.
he's right, Jeremy. He's made a thesis. He's shown his conclusions. Now it's up to
Wrong.
you to prove that he's correct or incorrect.
Even when he pretends
Wrong.
he
If
has
you're
a straight
if you're doing
line.
maths,
No, that's
Yeah,
called. It's called. Hey, listen, guys. This is called
no.
the checking. This is what happens in science.
No, that's called making
No.
something up and then saying someone else
Making
has
something
to
up.
prove it's
Then
wrong.
like I said, he's come up with a scientific theory. Now he's proven this with math. Now it's up to you to show that he's wrong.
So he hasn't
You just can't
proven
say,
it.
"Oh, it's wrong. It's wrong." You
Didn't
actually have to
prove
prove it.
You
So
don't
he
Right.
came
prove
up
a
with
In
something
his
scientific
he didn't
math,
prove
did
theory
he
it.
with
show how
math.
much
Yes, you
cold
did,
air
Jeremy.
and
You don't
Yes,
prove
you
a
did.
warm air
scientific
was
theory
when
with
the light
math.
was traveling through those things?
Tell me again how we prove a scientific theory with math. You're talking about natural science, right? Or
Yeah,
no?
math
Is
is
this
the
some-
language of science. Math is the language of physics.
All you
And
have
that-
to do, all you have to do is use math to make a prediction, and then you measure.
I knew he
nature
was going to
against
say
that prediction.
prediction. I knew they were going to talk about
That's
predictions.
science.
Yeah, predictions. Voila.
That's
Yep.
science.
If
That's
you
how it
if
works.
you can come
Yep,
up with a
and then
That's not
you
prediction,
science. I'm sorry, Bob.
whatever
Test
you
the
said,
prediction.
whatever you named the variables, and then came up with your prediction, those variables are now accurate.
Okay,
right?
listen, guys.
Verify your prediction.
The prediction has to be novel. So now use your formula to make a novel prediction for it to be a real prediction and show us that it's accurate. If it's not novel, then it's not a prediction. It's just watching a pattern.
Yeah, something that is not reverse engineer. That's what he's saying in few words.
So make a novel prediction with your math, please.
Well, I'm not going to play.
Well, you can't.
No, because you're doing stupid things again, Bob. That's okay.
Yeah, I know. I don't know.
He can't. He can't make a novel prediction with his math because that's not how it works.
Hey, your amazing technology is failing right now. You got to drop and just rejoin, I guess.
If you can't make a novel prediction, it's not a prediction. You're just describing.
I don't really care what you think.
I don't really care what you think, you people that I'm on the show.
Bob, you're
that
lagging.
I'm talking
Good
to
novel, something,
and whining
and measure,
to and whining
measure
about.
reality.
I don't care what you think.
I'm not whining at all.
Good.
I'm just simply saying I can make a prediction
buddy.
and compare that against reality.
So what? So what if you can make a prediction? I can make a prediction too.
But a prediction of what? Of something that happened before?
Prediction against reality.
Yeah, I can do that too.
A prediction.
Yeah.
A prediction that had happened before? That's not a prediction, Bob.
So you say. So what?
Wait. Does this mean that you don't understand what the prefix pre means? It sounds
really
like
doubt
you're trying
you
to make
do.
a prediction after the thing takes place. That's no longer pre, buddy.
Bob, man, I don't know why you guys are.
I'm sorry.
It's funny how stupid these people are, man.
What do they call that? A post-diction?
Use your flat Earth model and tell us when the next lunar eclipse is going to happen.
The Saros cycle.
Hey, buddy. NASA didn't came up with that those cycles, okay? That's way before us. You should go learn a little bit from where it's coming from.
What is the Saros? What is the Saros cycle?
Here, let's bring it up. Bob doesn't know what it is. Here, let me look it up and I'll bring it up and I'll read him the definition of it. Since Bob wants to know what the Saros cycle is, and he doesn't have Google and he needs us to tell him what everything is. So hold on just a minute. Saros. The Saros is a period of exactly 223 synodic months, approximately 6,584 days or 18 years and 8 hours that can be used to predict eclipses of the sun and moon. One Saros period after an eclipse, the sun, earth, and moon return to approximately the same relative geometry, a near straight line, and a nearly identical eclipse will occur in what is referred to as an eclipse cycle. Is that good?
Yep. And how do they come up with it?
Can it tell you exactly where and what time?
What's it based on?
By observing the pattern way before our times, buddy.
Let's see. Let's try to find out.
Saros cycle based on
observations.
You actually understand
Observations?
what you're talking about. No, it's not.
It is.
So tell me. Let's see if you understand what you're even talking about, Brendan.
Bob. You see.
Let
me tell. Hold on.
Stop
Bob,
talking over me.
Don't get triggered, Bob. Don't get triggered. You observe a pattern on the sky, and you can put whatever numbers you want on that pattern. It's reverse engineer. Yes, you can. No. If the pattern never moves and it repeats the same thing over and over, you can put whatever numbers you want on that pattern since it's not going to move.
No, it doesn't.
Okay? It's really simple. Reverse engineer. Don't be a stupid.
Brandon, do you want to know what the Saros cycle is?
The earliest discovered historical record of what is known as the Saros cycle is by Chaldean, non-Babylonian astronomers in the last several centuries BC. It was later known to Hipparchus, Pliny, and Ptolemy.
Right. Thank you.
What is the Saros cycle built on? What is it dependent upon?
Observation, moron.
No, it's dependent upon the orbit of the moon around the Earth.
I explained to you. We observed something in the sky.
Oh.
We observed something on the sky.
All right.
And you're reverse engineering and build a story.
Yeah, Bob.
And
he's right, Bob. He's right, Bob. They looked at the things in the sky and they looked at the repeating pattern and they figured out how it repeats and where the things would be based on when it was. And that's how they came up with the Saros cycle. That's how they did it. Prove me wrong.
from? It comes from the three different orbital.
No, that's just some shit you guys made
Now,
up. This was
on the
developed
Saros
way
cycle, you
before the heliocentric model, Bob. So
Brandon, you
how
can
did
keep
you
talking
develop
over
the
me all you
Saros
want.
cycle based on the heliocentric
How are
model
you
when
doing
the
this?
Saros cycle
You're more than welcome
predates the
to talk over me,
heliocentric
Brandon.
model by
Yeah, but
2,000
no,
years,
it
Bob?
doesn't.
Explain that to me.
It doesn't.
Easily.
It
Explain
doesn't
that
tell
to
us
me,
where
Bob.
and when.
Easily.
It doesn't tell us. The Saros cycle doesn't tell you where and when it's going to happen.
The
That's
Saros
correct.
cycle,
About
the
20 points
Saros
for B-ball.
cycle is a repeating pattern of eclipse types. And it has a repeating pattern on the Earth every, 18 years? Well, here's the problem, Brandon. Here's the problem, Brandon. That cycle repeats every 18 years, 120 degrees and 300 kilometers north of where it was originally.
So
Bob,
that didn't happens at then, Bob.
By the
Thank
time it
you.
comes around again,
Wow,
it's
they
900
couldn't figure out that
kilometers
it's
north
offset from
of
time
the
to
original.
time. Hey, this Saros cycle, it moves
offset
this
every
far. The
time.
next Saros cycle, it
They
moves this
offset every
far.
time.
And that is because it's
offset every
based
time.
on
Brandon,
the
could I
orbital
just
periods
have a
of the
second
moon.
on that?
Yeah, go ahead,
I'm
Adam.
not going to sit down and try and shout over you, Brandon. It's
Well,
based
then
on the
shut up
orbital
every
periods
once in
of
a
the
while.
moon.
Stop saying ridiculous things.
Okay.
Sorry, I'm telling you how it worked.
Yeah,
You want
he's
to
right,
know,
Brandon.
that's fine.
Yeah.
Oh,
It
Coach,
is.
you don't need to white knight.
I mean, Brad explained this last night in Jeff's server. It's not like you guys stated it.
This is your cognitive dissonance comment. That's why you show up, Kosho.
Hold
No,
on,
I'm telling you, it's breaking you.
Kosho. They
You say
developed the
otherwise.
Saros cycle based on the heliocentric model 2,000 years before the heliocentric model was developed.
It's based 100% on the positions of the orbits of these objects.
No,
right?
that's how you
These objects
define
do,
it.
other
It's
than
based on
orbit, is
what
they
you
rotate.
see in the sky and the patterns.
rotate.
That's what
And
it's
the problem
based
with
on.
rotations is
It's
they're
based
not
on
gonna end
what
up in
you
the same
see
position
in
every
the sky.
time.
Kosho, is it based on what they saw in the sky?
It's based on the orbital patterns of the moon.
Oh my
and
God,
the
I give up.
rotation speed of
Adam,
the
go
Earth.
ahead.
Hey guys,
These people, Brandon, don't bother, man. These people, they're cuckoo.
I can out Saros you any day of the week, and it's not difficult to do. And I can
You
prove it.
can look it up. You can look up the description of the Saros cycle, and it will tell you it doesn't show up in the same position for this reason.
Could I chip in for just a second? Could I chip in for just a second for terrestrial refraction? It's just a quick question there between all the panelists, and then I would like to hear Adam say his thing. But could we just go down the list and just ask people what they think of terrestrial refraction, if it's a real thing or not? Is that okay? Take like 1 minute.
Yes,
go for it.
Okay. B-ball, do you believe in terrestrial refraction?
Yes.
Right. Oh, concentric circles. Do you believe in it?
No. 7/6R. No.
Right. Okay. So let me go back. B-ball, are you a globe earther or a flat earther?
Globe earther.
Concentric, are you a flat earther or a globe earther?
Flat earther.
Okay. Right. Okay. So Crit, are you a flat earther, globe earther, and do you believe in terrestrial refraction? Right. Okay. Dr. Bob.
Yes, terrestrial refraction does exist, and obviously I'm a glober.
Okay. JC 711. Kosho.
Say again.
Same again.
Yeah. Terrestrial refraction, of course, is a real thing.
Okay. Physicists. Yeah. Rakia. Okay, Rob on the level.
Yes. What would you like to know?
Do you believe in terrestrial refraction?
7/6R. Where did you get the R from?
Okay, and are you a flat earther or a globe earther?
I'm a realist.
Okay, SE.
Yes, sir.
Are you a 7/6R refractionist? And if so, are you a flat earther or a globe earther?
This is what I believe. The Earth, their model is covered with 70% water. Water is flat. So I believe at least 70% of what we call Earth is flat and level.
Direct question, man.
Okay.
That's my answer. Take it or leave it.
Silent Zero, what's your answer on that?
I'm a flat earther. Yes, I believe in refraction.
Okay, interesting. Right, Adam Meakin.
Oh, right. Right, okay. I believe that the Earth you could describe as terrestrial. I believe there's a thing called refraction. Do I believe that light refracts at a rate of 7/6 of a presupposed R value? No.
And are you a flat earther or a globe earther?
They're flat, mate.
Cool. Right. Bob Dole.
The Earth is only what can be experienced through one or more of our five senses, and I would be in the flat Earth category, not the ball Earth category.
And do you believe in terrestrial refraction? 7/6R?
I would not make the claim that I believe in it, but I'm willing to accept it for discussional purposes.
Okay. And lastly, Tom Walbran.
I'm a glober, and I do believe in it.
Thank you very much. That's all I wanted tonight, guys. And I appreciate every one of you taking part in that questionnaire. So I believe it's Adam's chance now to jump back in.
Whoa, wait a minute.
Wait
a minute.
Oh, come on, guys. What are you going to do?
What's your answer?
Come on, Ranty.
What's your answer?
What's my answer?
Yeah.
My answer as a flat earther, absolutely, I do not believe at all whatsoever in 7/6R over refraction. Mick West's bollocks that he invented in 2017 based upon a faulty set of experimentational well, it wasn't even experimental, it was just thought processes from, what was he called now? I can't remember now. But in any event, it's just 4 years old, guys. It's just 4 years old. You globers are believing in something that some guy called Mick West put out there, 7/6R refraction from 4 years ago, and you've hijacked it because it's like an OP kind of like, it's definitely OP. It's an OP kind of we can disprove every P900 and every P1000 observation now because we have this 7/6R refraction. And if it doesn't work, we'll just increase it to 8/6R. And then if that doesn't work, we'll just increase it to 9/6R, right? And essentially, that's what happened. Because if you go back pre-2017, you know, the P900 was out and flat earthers were crushing the globe earthers with all these observations that defied the globe mathematics. And you guys needed something to come out with. You guys needed something to hang on to. And some guy made this mathematical equation up, and you guys jumped all over it and you all accepted it without any proof whatsoever. There's never been any proof of looming whatsoever. So my answer is I am a flat earther and I do not believe in 7/6R. There you go.
Well, the thing is, they assume that light travels they assume that light travels in a straight line, which is one key assumption that's okay. But they assume that they're not seeing stuff over the flat plane because it's blocked by a hump of Earth curvature. And so they try to basically finagle the math to make the line of light twist over a globe, as opposed to factoring in key things like diffraction through the eye, optical, limitations like atmospheric extinction and stuff like that. They just assume that the line would curve over the globe as opposed to being over a flat plane and not being seen due to dirty air, diffraction limits, stuff like that. So they have a couple key assumptions that they really need to, possibly modify.
Well, thank you for all that salad, Lemon.
So the reason why we're not seeing objects isn't because there's the hump of Earth curvature in the way. It's because of the diffraction limit of the eye. In the chat, I put another thing that explains why objects that are really big, like the sun, moon, and stars, would appear to set early over a flat plane, no hump of Earth curvature in the way, while maintaining their size. Let me put it in the chat one more time.
Can you try to turn it? Shit, I'm not sure I can turn it on here.
Well, thanks, but we understand very well how the sun sets. Appreciate it, though. as well as how refraction plays into it.
Dr. Bob, does terrestrial refraction? Hold on, Dr. Bob. Does terrestrial refraction play a part in how the sun sets?
Yes.
Bollocks. It just shows how little you know about your model, mate. Because it isn't terrestrial refraction, my friend. It's not terrestrial refraction. Oops,
it's refraction. I don't really care what
it's not terrestrial refraction, is it, Bob?
It's refraction.
It's not terrestrial. I asked you a specific question. Is it terrestrial refraction? And you said yes.
I don't really care what you think about it. It's refraction. And I explained that refraction does play a part.
Why do we even let Bob hear?
We let everyone hear.
He doesn't care. Yeah, I guess so. Yeah,
no, I really
don't. You let me hear.
Almost everyone here.
Yeah, I really don't care about your definitions and terrestrial or astronomical or whatever you want to use.
It's not our definitions.
Why are you here then, Bob? Why are you here, Bob?
Definitions have
plays
meaning,
into account. Refraction takes a part of the sunset. Yes, it does play a part.
That's the problem I have with it. You've developed an unfalsifiable model where you can bend anything over anything in any direction you want, so no observation can be shown to you that would falsify your optical model of the Earth. So
that's not true at all.
It is true.
I think it's accomplishment.
I'll tell you what, Brandon. Here's a way you can falsify the globe Earth. I want you to give me an observation from 50 feet in elevation and show me cars on Lakeshore Drive in Chicago, 60 miles away. If you can show me the cars on Lakeshore Drive, then I definitely will take your claim seriously.
I know you're not dumb enough to think you can see a car from 60 miles through the densest part of the atmosphere.
Sure you can.
If you had a telescope,
You're not
you
that
should
dumb.
be able to.
Oh my god.
Yeah, sure you can. With a telescope, you betcha. And you can especially see their headlights.
How small will that dot be?
Headlights, you definitely see. And with a car, you could actually calculate the angular size of the car.
How about I show you a laser, Bob? How about I show you a laser?
Got to be shore to shore, 50 miles. No less.
50 miles.
50 miles. Yep. I will not look at anything less than 50 miles. You have to show me a laser, shore to shore.
How long
50 miles.
I take it we've only done 49 miles before?
No, you generally do about 15.
Oh, okay.
But show it to me from 50 miles.
Like 20 something, I think.
Show me from 50 miles and you've got a point.
Oh, okay. I don't know why that would make a difference. That you're on your model, it shouldn't be possible at 10 miles, let alone 50.
Well, then let me explain to you why it'll make a difference. I explain to you why it'll make a difference. Because generally what you do is extraordinarily low angle observations from just a couple of feet off the surface of the water. And then you get out to about 10 miles where you can sit down and you get all sorts of refraction involved. At 50 miles, there's absolutely no way refraction would cause that to come up over the horizon. So show me one shore to shore for 50 miles, because then unquestionably refraction's not making that happen. It can only happen because the Earth itself is flat. So go ahead and show me one, because you can see lights from 50 miles away very easily. Show me a headlight from a car.
You've put the goalpost way out there. Once again, unfalsifiable, because it's just not reasonable. 50 miles is so far.
Please say yes or no.
To see through the thickest part of the atmosphere.
Before he says that, he might want to check with Rumpus before he says that, because Rumpus says we could see our own ass in the telescope. So,
or we could just take a picture of the Earth from far away.
I also don't rely on Rumpus to tell me how to think. I can actually do that myself. So I've designed a test that will give us a yes or a no answer. Show me a car headlight on
that wouldn't give us a yes or no answer, Bob. That wouldn't give us a
yes
or no answer.
You would just say infinite over our refraction.
That would surely demonstrate that there's no curvature.
No, you guys would just say infinite over our refraction.
That would demonstrate a flat Earth. Go right ahead and do it.
And
you would just say infinite.
If we didn't see it at 50 miles, it wouldn't mean the Earth is curved. It would just mean we didn't see it at 50 miles.
50 miles. If you could see it at 50 miles from shore to shore, it would be strong evidence the Earth was flat. So go ahead and show that to me, Brandon. 50 miles.
Okay, so 50-mile observation you think would falsify it. What altitude?
Shore to shore.
Uh-huh.
Shore to shore.
What altitude?
That means lake level to lake level.
Lake level to lake level. So how high
Yeah,
off the ground?
I'll give you 10 feet. 10 feet off the lake level. The 10 feet off the lake level will be
10
satisfactory at 50 miles.
You want us to get an observation through the thickest part of the atmosphere, 50 miles across water.
You can see the moon at the horizon. So you can
That's
see
because
right
the
that
moon is up in the sky above the
We're not
atmosphere.
looking through the thickest part of that.
We're setting.
You're not looking through the thickest
Not
part.
yet. Yes, you are. When you're looking at the exact
And it's a
same
lot
as setting.
brighter. It's a lot brighter and higher.
Hang on. Get as bright light as you want then.
It's
All right, keep
still
dancing,
brighter
Brandon.
and higher.
Nope, it's not high. It's lower.
Light
It's
is
setting.
It's on the horizon,
Brandon,
Brandon.
I put it in the chat. I rotated it. Basically, it's at a
You can't
higher
say it's
angle.
higher, Brandon. That's disingenuous at best.
So higher and brighter
higher,
doesn't make any
so,
difference. So wait, let me
It's
just
higher.
explore this for 1 second. So something at ground level, just as bright, should be easily as seen as something, say, 100 miles up. That's just as bright. Is that right?
It's not 100 miles up though. It's at the horizon, the same. When it's setting.
But the illustration is that it's higher up, therefore it'd be at a wider angle and more visible.
Nope.
Oh, be quiet, Lemon Bird.
On
Just a
the
minute.
horizon.
The
It's
thing
on
is,
the
you're
horizon.
not following the illustration. He's trying to illustrate that it's
All
at a
right.
higher
Now,
angle
Brandon,
relative to
it's
the
on
level of the
horizon.
eyes.
I have nothing further to say on it. So unless you can present that observation, we don't have anything else to talk about with it.
Well,
not higher
way to
level
set the
relative to the eye. It's at
goalpost
the
way out
horizon.
there. Okay. Here's an impossible task. Do I have to do it standing on one arm or with
Well,
my eyes
that's your normal-
closed or
that's what-
juggling with my
Well, that's
feet?
what you guys
You can
do
do it
all
any
the
way you
time.
want. You can do it any way you want.
Okay.
If you're not standing on a grand piano, it don't count. I'll tell you right
Well,
now.
that's what you guys do all the time. Only this one's actually easily done.
Hey guys, can I just interrupt it just a second and say that I think someone's got the TV on in the background and it's really causing a problem. So if anyone's got the mic open.
Yeah, just go ahead and do that observation, Brandon. I'd really like to see that, and I'll be the first to admit that that is strong evidence for a flat Earth.
Who's
So just
watching
go ahead and
TV?
present that.
Yeah, Bob Dole.
Bob.
So just go ahead and present that evidence, and I'll acknowledge that that's strong evidence the Earth is flat.
Okay, you really didn't provide much dispute to my claim that your model is unfalsifiable. To be honest with you,
Our model's absolutely falsifiable.
Yeah, okay. 50 miles ground level, 10 feet off the ground through the thickest part of the atmosphere. Got it. Over water.
With all that atmospheric turbidity and shit.
Yet you can see light. You can see lit objects through that same layer. So your objection is dismissed.
You can see what objects?
You can see lit objects through that layer.
Oh.
So your objection is dismissed.
I'm okay with the globe not being falsifiable because that also takes away their argument that it's somehow based in science.
Yeah, no doubt.
The globe is most definitely falsifiable and always has been. And anybody that wants to try and falsify it, you're welcome to try it.
You don't even
So
have a
far, nobody's
hypothesis.
been successful.
Yeah, there's no hypothesis. There's no experimentation. There's
The
nothing.
hypothesis is the Earth is a globe. That's the hypothesis. The hypothesis is that lines of latitude stay the same from north to south, and that lines of longitude widen to the equator and then narrow again as they get closer to the poles. And that is also testable. And guess what? We've tested it. They are.
See how you gave it a philosophical hypothesis, not a scientific one.
That's no philosophical hypothesis. You don't even know the difference.
Yeah, you pose no cause and effect relationship there.
You should have heard the hypothesis.
The Earth is spherical.
You should have heard
Okay.
the hypothesis this crackpot tried to give me earlier in Gems. It was fucking ridiculous.
Yeah, you gave a philosophical proposition based off reasoning, not a scientific one based off cause and effect.
They don't
Well,
do
I don't
science.
think you know what. I don't
So
think
at
you
the
have
beginning of
first
time,
clue what
somebody
a
said,
hypothesis
"Oh, here's a planet. This is what it is."
Here, do you want me to help you out and walk you through it?
Yeah, certainly.
The hypothesis is that the Earth is a sphere.
That's
The
not a
prediction
hypothesis.
based on that, the prediction based on that hypothesis is that lines of
Not a
longitude
hypothesis.
will be narrow at the poles and widen to the equator and then narrow as you go to the opposite pole. That is
Can have
now
your
a testable. That is a testable prediction. So
Can I have
then
your
we
dependent
test
variable, please? Dependent variable, please.
the distance between two lines of longitude.
Yeah, here's live science.
Show me a
Can
line
we
of
get your
longitude.
real quick?
No,
Independent
show me a
variable.
line of
Independent
longitude.
variable is the latitude.
Put it in my hand.
Yeah,
Give me
here's
it.
live.
Give it to
Here,
me.
hey, Bob.
So,
Dr.
I'm pretty well
Dr.
done with you guys. I'm home now, so it's been fun chatting with you.
All right, go
Okay,
lick your
just-
wounds,
now,
Bob.
now you're going to cut and run when we want the actual information. Good job, Bob.
And I'm here now.
Yeah, right here on live. I'll link it here in a second. Here, Live Science says a hypothesis is written in the form of if-then statement, according to the University of California. So
Cause
right
and
away,
effect, baby.
yeah, what he was proposing, he's pretending he was doing science, but offering philosophy.
Classic pseudoscience.
Hey, you know what?
Well, the thing is,
Oh, go ahead, Lemon.
Another hypothesis would be if we shoot a laser traveling straight and true over the globe, it would either hit a hump of Earth curvature or hit the target if it were flat. I would make the hypothesis prediction that it will hit the target that is low to the ground with no hump of Earth curvature in the way. That would be my hypothesis.
Yeah, it's same thing too. As soon as if they want to say their model isn't scientific and it's unfalsifiable, then there's finally an argument that you can go at them with. Like there's some sort of claim they're making. Because right now they don't ever do that. They just kind of say settled science, no debate. Like, so you're presenting settled science for the first time in the history of science, and you're saying no debate with that.
I don't think you ever really looked at that history of science, because it's been a long, long time, and long before any of us were born, or even gleam in somebody's eyes.
What's been a long time, Tom?
What's that?
What's been a long time? Sorry, I missed it.
Deciding a lot of stuff, thinking about, having what's that over there? What's this fire? It happened a lot of stuff happened so long ago that there was not anybody going, hey, that you got to prove that. What do you mean you got to prove it? It's just what I believe, and then they put their paper out. Sometimes people spent their whole life trying to get that idea out. And some people were put in jail, and that's been a long time with all this stuff. And either we can't take it serious, or we take it serious, and take our time at trying to find out what it is instead of just destroying everything, because that's going to be really, really bad.
Yeah, that's a good point. I get you.
The shape of the Earth, because it appears that we've had questionable optical principles used to back up the globe. I put a drawing in the chat, basically showing how higher objects would tend to maintain their size and set early behind a horizon in the foreground. Let me see.
I got it up on screen, again. Lemon. Yeah, if you could explain what it means, that'd be awesome. Thanks for turning it sideways too.
Oh, no problem. I have an eye over there to the left, that little oval thing. Human eye 6 feet above the ground. That little dash coming straight out from the eye as much as possible is eye level, and right below it is ground level, 6 feet below the eye level. I have progressively taller objects being seen visually, from 6 feet to 12 feet to 24 feet to 48 feet. And notice how each of those higher objects need a new vanishing point that's further out than the 6 foot vanishing point in the foreground. I have 6 feet above eye level, ramping down to a vanishing point, and the ground below, 6 feet below the eye level, ramping up to that same vanishing point. And I have something there saying horizon forms here at vanishing point VP for 6 feet zone. Anything that's taller will have to set behind that zone because it needs a higher vanishing point that's not available to the eye at its current elevation. And so you have the 12-foot thing ramping down to its vanishing point, the 24-foot thing ramping down to its vanishing point, and the 48 thing ramping down to its vanishing point. And notice how behind that screen of horizon, it's going to maintain its size and appear to set early, like the sun, moon, and stars, and be clipped off from the bottom and set bottom first. No hump of Earth curvature necessary to explain why it's maintaining its size and disappearing. At the bottom, I have the main caption. A horizon forms in the foreground for objects 6 feet high, up and down from the eye level. Taller objects need a further vanishing point and set early behind the horizon. They maintain size from being in a higher visual plane and appear to set bottom up.
Interesting. This is an interesting visualization, yeah.
This is the only way the globals can debunk it is to say that math doesn't work.
No, I have one question. Just real quick, one question. Would it not work in the opposite direction as well if the eyeball was on the top there, looking back down?
you'd have a wider angle and be able to fit more objects that can vanish down to a vanishing point at the horizon nicely and evenly without setting early. So you would tend to have nice even disappearance where an object would disappear down to a speck, as opposed to vanishing early and setting bottom up.
So this is something you can show?
Foreground.
This is something you can.
Life is Short showed it several times in his videos, showing that if you get close to a wall, close to a ceiling, close to the floor, it appears to set early over a flat surface.
Yeah, we've seen that. Yeah. The claim is always there when somebody shows that, like an object that's close to the ground disappearing behind a horizon, that the floor is uneven, which the Earth is uneven too. So I don't know what the point of bringing that up is, but
I'll put the 3-hour video from Life is Short in the chat for you. It's a pretty good primer on this subject.
Yeah, Life is Short did a lot of thinking on this stuff. Even if you don't agree with everything he says, it'll make you think for sure. If you guys haven't checked out Life is Short's videos, I'm not going to say that they're dry at times, but you have to be really interested in optics and this subject in order to watch them all.
Yeah,
Great
you
stuff,
actually
though.
want to know something.
Was that the guy that did the 3-hour presentation on? Because that was fucking excellent about angular.
Yeah.
Yeah.
You can put a link in the thing for us.
It's in the chat. Angular resolution in our world from Life is Short.
Thank you.
No problem.
Yeah, when the first time I saw this, I was like, oh my gosh, this is what I've been looking for, because it came out. A lot of these ideas were just being discussed in Nathan's in Flat Earth Debate. No one had really put it together like this. They were just starting to explore a lot of these ideas and observations, and Life is Short put them together in a really time-consuming, I'm sure, manner, but very detailed.
He goes over the Rayleigh criteria, the diffraction limit, and all that. That's why I would say the main thing forming the horizon is the diffraction limit relative to your height above the limiting flat surface, be it the wall, the ceiling, or the floor.
Yeah, good stuff, Lemon.
Thank you, good sir.
Yeah, so I wanted to trace back to what we were talking about with the Saros cycle. And the claim is that it doesn't predict the location. I'm looking for some confirmation that it does. And the only thing that I see here is that it shifts 120, what is it, 120 degrees or something like that every year. So it's a repeating pattern. It's just that the location of the umbra, penumbra, the actual eclipses shifts, and it sounds like it's a predictable manner. Is that correct? Anybody?
Basically, it reoccurs with that familiar pattern of I think they said 18 years, 10 months, and some change or something like that. But with more accurate clocks, we were able to map it with greater, reliability. And also, it's highly map dependent. So it depends on whether or not you think it's a globe and or, something like a flat plane. So some of this may be based off of the sort of map that we're superimposing these patterns on too. But in general, it's just basically mapping out the pattern and having more accurate clocks, to map it out with more precision, basically, flat or round.
Right. The mathematical model. Yeah, I get what you're saying.
I think if you go down a little bit more on that page, you'll see a little spinning globe. There you go.
Yeah, no, I'm sure it's been mapped out on a globe, obviously. Yeah. The Saros
will give you the location.
Right. But you could do the same thing, I think, with a flat representation of Earth too. You could map it out. Not that we have a good map of a flat map. But anyway, so yeah, let me see what this says. The Saros is not an integer number of days, but contains the fraction of 1/3 of a day. Thus, each successive eclipse in a Saros series occurs about 8 hours later in the day. Okay, so they know that pattern repeats 8 hours later. In the case of an eclipse of the sun, this means that the region of visibility will shift westward by about 120 degrees. So if you know the location of one, you'll know in the next cycle that the next one is going to be 120 degrees westward. What's so difficult about that? That's a pattern.
Well, there's 360 degrees in a circle, so 120, I think, is a third of 360. 8 hours is also a third of 24 hours.
Right.
So it looks like a bit of a degree shift there around either the globe and or the flat plane, I guess.
Yeah, even our model is obviously based on circular patterns. At least that's
So I
what
guess
we
the
think.
question is whether you're going to superimpose, what pattern are you going to superimpose it onto? A globe pattern and or a flat pizza.
Right.
Yep.
Well, who's yawning? Go ahead, start some shit.
Bring it.
Oh shit! Sorry, I was your. Fuck me. Sorry.
Oh yeah.
I didn't even know I was off mute then. Fucking hell! What the hell? Right, I'm going back on mute. Sorry.
I thought you were making a statement.
I'll tell you right now, this puny little fuck Sean G.
It is really late for him.
That's true. Yeah, we could cut him some slack.
This motherfucker Sean G, little G, keeps acting like I'm ducking him and hiding from him and I'm scared to one-on-one him, but he knows where I am every hour
Come
of the
on,
day. I'm in one
Sean
of
G,
these
come on in right now.
Every hour of the day, I'm in one of the Discord rooms that he knows about. Jose's here or Gems, come see me, bro. I ain't making a time slot for you. You really ain't that important. I've been battling the top Globers for the past year and a half in Gems. Come fuck with me.
Time slot's open right now. Sean, if you're out there, please join. Jeremy is available and the time slot is open.
This guy's acting like he can't find me.
Yeah, what's up with that?
Weirdos.
Hey, B-Ball, why would you need to know the heliocentric model or Kosho in order for this Saros cycle to have any to be able to use this Saros cycle?
Didn't Ptolemy use? My bad. Go ahead.
I was just going to say you don't because they didn't have it when it was invented.
Huh.
Yeah, like Jeremy was saying, Ptolemy and his students were predicting. Yeah.
Did Adam ever get his question out? I don't know. I kind of took his spot, and I was just wondering whether or not he actually got a chance to. That was like 25 minutes ago, and I'm really sorry.
I don't think so. Adam, are you still there? Are you mad at us?
Ranty, what was the point in all that?
If I was Adam, I would be fuming because he was.
Ranty,
I didn't mean to take his spot like that.
Ranty, what was the point in all that terrestrial refraction? I mean, how can you even be a flat earther even terrestrial refraction?
Well, I just wanted to know if you were a globe, did you believe in terrestrial refraction? And if you were a flat earther, did you believe or not believe in terrestrial refraction? It was a very simple question. So,
yeah, no doubt.
I think I went down the list, and it was pretty conclusive that most globe earthers, or if not all, every one of you, said yes, terrestrial refraction 7/6R, and I think all exclusive of one who just wanted, for the arguments of sake, of flat earthers said no, we don't believe in 7/6R refraction. So
where did you get the R from?
Well, the thing is, the R would come from the globe Earth. But the thing is, refraction occurs. It's the theory of refraction that would be in question, whether it's refracting over a ball or a flat surface, and how would we express that mathematically for mathematical predictions, models, or whatever.
And I would agree with that. Fermat's principle would say that light, deviates from straight, but it doesn't say that it's going to curve around a ball.
Yeah, so, I mean, I would agree with refraction, but not the 7/6R part. That's just fairy tale shit. Yeah.
Well, let's look at refraction when it actually happens, right? So you see the straw in the cup of water. That's a great deal of refraction, but very little change in angle, actually. Think about when you see like a helicopter take off from a distance and you can see the refraction under the engine. Well, that's a great deal of combustion that's causing heat right? And it's going to be thicker than the atmosphere because not all the hydrocarbons burn up, right? So it's going to be like a lot of refraction, but you barely see anything. So they say that the temperature, right, is what's causing this refraction. What if there's like pockets of hot and cold? Like when I ride a motorcycle down a highway, there's pockets of hot and cold. Wouldn't the refraction cause the light to do like a parabolic curve? Not always bending down as they claim.
That's the problem that I have with refraction. It assumes a straight line that's like a string that goes from medium to medium, like a ping pong ball string or something. But the thing is that may not be quite adequate or accurate. I think I think the light is everywhere. And I think each medium has the information to present an image to you. But depending on how hot or cold it is, how thick or thin it is, it'll present that image to you differently. But the light is everywhere. The information to present the image to your eyes is potentially everywhere.
In order for them to say refraction is happening like they claim, you would need to make a straight line, see where it is, and take measurements and shit of the optical corridor. They don't do that. They just base it around their globe model and say, well, we know this is how it's happening because we know Earth's a globe.
Yep.
Well, I reject that notion of light because we have the diffraction limit, which would essentially make two lines of light merge, converge, and disappear and not be resolvable as a 2D image. So that string theory of light does not hold with the diffraction limit potentially over a flat plane. So I would go with the medium having the ability to present a picture to you or swallow up the image and not present anything.
So, Ranty, you got something?
So here we go. So let's go back to 2017, right? Okay, let's go back to 2016, right? Let's go back a little bit further and say, okay, so when these guys, the flat earthers, came out with the P900 and they started seeing really long distances, far further than they should on the globe, and they were really destroying the globe earthers, right? You know, and they had nothing, right? And then in 2017, you know, just 4 years ago, some dude called Mick West came up with this 7/6R refraction, and the globe earthers jumped all over that with no evidence whatsoever. There was no evidence at all. There's no proof at all for 7/6R. There's no proof of looming, and I have specifically gone out of my way to try and discover looming for the globe Earth for a year. I tried to do that, I couldn't find it, and there's been no demonstration of that. So, but yet the globe earthers still hang on to this belief that there's 7/6R refraction, and it can be infinite over 6R refraction.
Where'd you get the R from?
Yeah. But let's just forget that. The point is that we are looking at a cheat sheet for the globe that can basically destroy any observation that a flat earther puts out, any observation, because they can just say, oh, it's this because Mick West says so, right? But what happens if Mick West was wrong? What happens if there isn't 7/6R? What happens if refraction doesn't lift things up beyond the curvature of the Earth? You know?
And it's actually making them sink. And it's actually making them sink, appear to make things disappear bottom up. Exactly, Ranty.
No, so my question is, you know, go back pre-2017. What's Mick West got? Why is Mick West the one guy that you are holding up with this? Because let's go back. You guys are quoting 7/6R refraction, terrestrial refraction, but it all stems back from a guy called Mick West in 2017, who nobody really knows, right?
He was
There's no
on Joe
evidence
Rogan.
of this. No evidence of this. There's no evidence of anything that he put out there. No evidence of what you're saying. There's no proof of that. For 4 years, we've been trying to disprove that or prove it, and nobody's been able to do it, but you still preach it. So tell us, guys, why are you still preaching it? Why are you still pushing it when there's no evidence for it? Go.
That's all I got.
I think that was a question for Globers.
Like Brandon said, they turn their model into an unfalsifiable thing.
I just have one question. Is there anything, just any one thing, that the flat Earth believes that is not have any proof on, and they keep going about the whole thing as a year?
So nobody came back. with all the fucking globers in the chat right now, nobody came back with a single thing. Just some dude turned up and asked another question. Nobody responded to that. Fine, thank you. Right, I'm leaving for tonight.
The thing you can't be throwing stones when you live in a glass house.
Bye, Ranty.
Well, Tom, what would you say that we go on about that we don't have any proof for? Out of curiosity.
Gravity.
Oh no, not just gravity. Let's say the dome, the glass wall, the giant ice wall that nobody can pass over. The Antarctic doesn't exist. Come on, man. It's there. Lots of people been there.
Talking about the coast of Antarctica.
Nobody says Antarctica doesn't exist.
Oh, you can't go there.
The coast of Antarctica, that's mostly an ice shelf.
Yeah, have you heard of the Antarctic Treaty? Do you think it's just like a made-up thing on a napkin?
Yeah, it's not a made-up thing, but you can go there. Anybody can go there.
Have you read it? Have you read it? Let me ask you a question. Let me ask you a question. Can I go there with heavy fuel? Past the 60th parallel. Can I go there with heavy fuel?
You mean like just to dump it out there?
No. Can I go past the 60th parallel eating a hamburger on the deck of the ship with heavy fuel underneath?
Yeah, I don't really know what heavy fuel is, but I would say yes.
No, it's in the treaty. You can't.
What point are you trying to make?
So what is heavy fuel?
I'm trying to make the point that you haven't read the treaty.
Well, I'm asking
you, Hank?
Fuel.
Yeah, I have. You can't carry heavy fuel.
Can you show us where it says that?
I'm driving. I'm sure you would ask that one.
The point what a coincidence.
Yeah,
You're always driving when you have to present that.
Yeah, Ed, you don't know what words mean.
It's a coincidence that you're always sitting on your ass too. What do you do for a living, Ed?
Can you go to any military base?
No.
Or do you have to have a pass?
Can you go to Area
get on?
51?
Gotta
You
have
go
a
to Area
pass.
51? What makes you think you'd be able to go to Antarctica?
That's just the
Well,
you need permission. Nothing wrong with that. Get permission, you
And
can
the
go.
deep underground. And the deep underground military bases are not available to the public in general. You got to have special clearance for that.
How do you know? Have you been there?
No, just reports.
Oh,
and
okay.
total
So you
accounts,
made it
that
up.
sort of thing. No.
There's a lot of places you can't go on Earth. You just need permission.
On a flat plane.
No eating on the mic, please, Vivo.
So
Antarctica looks like a big wall of ice, by the way. So
doesn't it? Yeah, I know
It's
they've
an
got this
Antarctic ice wall.
continent with a huge ice shelf that butts up to the ocean on its shore, and then it's also supposedly the highest altitude continent in the planet, mountain ranges and stuff. Just a big old fucking giant mound of ice, no matter which direction you come at, right?
Yeah, that
Brandon,
boats have sailed
can we get
around.
one of
Yeah.
the Globers? Brandon, can we get one of the Globers to answer Randy? I wouldn't let any Glober talk till they answer Randy's question.
Yeah, but people, how come you didn't answer Randy's question?
They tried to deflect. They wanted. They would say, "Oh, flat earthers deny Antarctica," and then just try to turn it into a shit show. Great job keeping them on. Hold their feet to the fire.
Yeah.
Right.
Hold their feet to the. They can't answer it. They want to deflect.
Wait. What can't we answer, Crit?
Randy's question.
Which was
Question about what? Terrestrial for refraction? Yes, it's a thing. You can look it up.
No, I was more in depth than that. I forgot exactly.
Shut up, Jeremy.
Yeah, all right. If he does that again, fucking kick him, because that's all he does is come in here and tell me to shut up.
Who was
he did
that?
that before the show. It sounded like Gary Tismo. It might not have been though. I don't
That's
know.
all they got, bro. They just want you to shut up because they can't argue against you.
He did it right before the show started. He came in, said that, and I don't know who the fuck it was.
Oh, they bounce in and leave. They just join for a second and then screech. That was a funny thing too the other day when on Gems and Veach is saying no one's making animal sounds right when people are making animal sounds. Like they're talking over him making animal sounds. He's like, no one's doing it. I'm like, you can't hear people making animal sounds over you talking. No one's making animal sounds. And he would say it
You
with a straight
are.
face. Straight face to the right. No, I hear no animal sounds.
Oh, really?
What was Ranty's question? Does anybody remember exactly how it was phrased? Brandon, do you remember?
Yo, Jeremy, your mic is really low.
Yeah, it had
I'll
to
be
do
right
with
back.
long range observations.
Yeah, that's not a question though.
No one
That's
remembers the
rich.
exact
You guys are
question.
complaining that nobody answered this question and you don't even remember what it is. Dumbasses.
You did. How come you didn't answer it, Ed?
I didn't listen.
Oh, of course not. That's convenient.
No, I remember how exactly he worded
it's
it. Just, he
convenient how
talked
you
about
don't
for years
remember
there
the
was
question.
What's your question?
Yeah, he said in 2017. I don't remember the exact wording he used. He said in 2017 you had all these long range photography. No one could debunk it. It was it. This is flat Earth.
Debunk what?
A long range photography.
What's wrong with long range photography?
It debunks a curved Earth.
No, it
Then you got the
doesn't. Which
Mick
one?
West. They said Mick West came out with a curve calculator, and then they started talking about all this refraction.
You mean refraction that's always existed? Oh, okay.
And specifically the 7.6R standard refraction, defining
That
it.
can be changed. That can be changed to infinity over R whenever
Isn't
needed.
that just a
with
formula?
no rhyme or reason.
Yeah, it's a formula that's based on the heliocentric model that makes it completely unfalsifiable with optical observations.
Well, it's based on
Of course it does. You can actually demonstrate the refractive effects of any given medium in the atmosphere, and so yes, of course you can falsify it. So that's just a completely false claim.
Oh, we can falsify. Tell me an observation that would falsify the globe for you, a visual one.
A visual one?
Yeah, that's what we're talking about. We're talking about visual.
Sure, no problem.
As opposed to a tangible observation.
Yeah. In any event, the one that you could do is go about 300 miles above the surface of the Earth and take a picture.
And that'll falsify the globe for you?
Yep.
Go how far?
So Bob wants us to look through the thickest atmosphere, 50 feet over water, and you want us to go to space.
I didn't say anything about space. I said go 300 miles above the Earth and take a picture.
Okay, 300 miles. We won't say space then.
You got any more ridiculous shit? Come on, Globers. Let's hear all your ridiculous shit.
Hey, Jeremy, isn't that funny how Ranty left and now they all joined to argue the point?
Yeah, here, Hank just posted the heavy fuel oil ban in the Antarctic treaty system.
Somebody run a tape back and figure out what Randy's question
guys
was. I
scared of
smoked way
Ranty?
too much.
Scared of the globe hero? Are you kidding me?
I don't know. You're awfully quiet.
I thought that the one thing that we can't take the Antarctic, it blows the whole thing. It's like, you can't take heavy fuel, which I still haven't figured out what the hell it is, besides a song from some band.
No, but you're not allowed to just do anything you want on Antarctica.
You're right. You're not just allowed to do whatever you want. And they also don't want you going down there and then having them come look for you because they don't want to waste time doing it. So you have to if you go out there, you go out there on your own peril.
You think that they let us? Okay, all right.
Restaurants.
I got $10 million. I've got a couple of cold weather vehicles, track vehicles, and we're gonna go down there and we are going to try to go from one side to the other straight along a longitude line. Is that
And
okay?
you send papers that they don't have to come and get you.
Nope, I'll sign it off. I'll sign off. I'll sign it off so that they don't have to rescue me. They can just let me die if something happens.
I cited my source in the general chat up the top.
You think they'll let me do it, Tom?
What was that?
You think they'll let me do it, Tom?
I think they will let you do it. Other people do it. I say if
you went through the proper channels,
If you have no reason, if you're not going to break any of their little rules, I don't think they wouldn't care. But they don't want to come get you.
Well, I would definitely have to carry heavy oil and
You have to carry
fuel.
everything you need. You have to take it because there's no McDonald's, there's no gas stations, there's no places for you to stay at night.
This is brilliant. You're a fucking genius.
They still got
There's
Amazon
no
deliveries.
7-Elevens or Super 8 motels or nothing.
There's
Sure,
nothing.
You can still get Amazon deliveries though.
There's no Amazon. There's no.
You guys gotta remember that in order for you guys to believe the Earth is flat, you have to like literally deny a lot of things. You have to deny that satellites exist. You have to deny that geodetic surveyors don't do what they say they do. You have to deny all
reality.
Both your examples were incorrect.
All we have to do is deny stories without proof.
So you don't deny pictures from
I
space.
can't deny anything you can't prove. What do I got to deny?
Exactly.
Pictures from space.
There's nothing to deny.
No,
when
he
you're
said
not
he
proving
doesn't deny
anything.
surveying.
So are the pictures from space fake?
Yeah.
Okay, so that's a denial.
No.
That's a belief.
No.
Do geodetic
proved
survey?
it. You can't verify it.
You haven't
Robert
proven or
Simmons says
verified
that
it.
they're fake.
Can you
Okay,
prove they're
so
real?
listen right now.
Prove they're
Apparently
real.
you guys don't know about Robert Simmons. I don't know where you guys been, but he works for NASA. Because when I post this YouTube video, if you look at the links and down below, right, it's going to show you a NASA website. Click on that link, and it's going to take you to NASA and says that Robert Simmons works for NASA, and he photoshopped the globe.
Okay,
because it has to be. Why does it? Hold on. I'm asking a question. Hold on, bro. Why does it have to be photoshopped?
That's a good question.
Yeah. Why do you say that?
Oh, okay, so that one picture was photoshopped.
No, not that
There's
one
many other
picture.
pictures
Not
of
that
them.
one picture. No.
All of them.
Oh, so all of them are.
You know that
So they can
already,
hide the
B-Ball.
7/6R.
You already know that.
That they assume.
You already know that, B-Ball. What are you talking about?
You have to deny pictures from space.
We're not
Again.
denying it.
And
Why
then
are
you
they
have to deny
Photoshopped? You're
what's going
denying they're
on in your
Photoshopped.
life.
Why does it have to be photoshopped? Answer the question, please.
Because it's a picture of it's many different pictures put together.
Oh, hold on. Who the fuck is doing it? Oh, it's Banter.
Hey,
Sorry.
wait. You're gonna tell us
It's
why
okay.
they have to Photoshop a real picture of things, B-Ball. Go.
It's a picture. It's many pictures stitched together. Does that mean the pictures are fake?
It means they can
It's
make
not
whatever
no.
they want.
Brandon, hold on, guys. They're acting like they did. They just took a whole bunch of pictures and put them together. That's not what happened.
Yeah, that's what he said, dumbass. Don't
yeah,
you
but
listen?
that's not what happened though.
Evidence.
Don't get triggered, Ed. Don't get
Please.
triggered, Ed. Don't get triggered.
Evidence, please.
Did you
that's
miss
what
the
happened,
part
why
where
did
he
they have
said
to-
when they had to make the strips together?
You have
Did you
to
miss
say
that
that
part?
that's fake too.
Did you guys
Why
miss
did he
the
have to
part?
add fake clouds? Not
Yes.
Like he took a panoramic shot and just
Himawari
put it
doesn't
together.
have fake clouds.
So now we're
Himawari doesn't have fake clouds.
How do you know?
There's videos of ladies and
Because I can match them up.
So what?
I can match them up.
Yeah, that's because they run the weather data that they get from.
No.
Yes, they
Guys,
do.
no.
Yes, that's
I told
very
you about
easy.
this
Are you
yesterday.
telling me they don't have the technology to figure out what the cloud
No.
patterns are?
So do they have
I told
technology
B-Ball
to
this
see beyond
yesterday. It's a
the
nonsense
clouds and
argument.
So they don't
beyond
have
the
radar, B-Ball. They don't have supercomputers.
Yeah,
Yes,
I told
they
you
do.
this
Oh, they
yesterday,
do.
B-Ball.
Okay, so they do have that capability
What does
then.
that have to do with clouds and reality?
Why don't they
man?
snap a picture for the love of God from a geostationary
Yeah, they
satellite?
did.
Or one
They
further
have
out.
many.
Yeah,
They took
Why
many
do you have
Photoshop
to
was
make
developed in
strips?
1987.
Are they
Photoshop
nuggets? Those strips? Are they chicken
1987.
strips?
Yeah.
And what year did they launch the Hubble?
Yeah.
Well, all of
Hubble and
Apollo was
Photoshop-
long before
Hubble and
1987.
Photoshop-
Hold up. They have
Hubble and
literally hundreds
Photoshop
of
share the same anniversary date.
Special effects
They're
go
literally
farther back than Photoshop. Just because Photoshop
Oh,
came
yeah.
out in '87.
Yeah, you could.
Is
They had
Himawari
hyper realistic painters.
According to
They had
Alamo,
hyper-realistic
the American
painters,
Brothers,
that can
Wait,
paint a picture that you won't even be able to.
Is Himawari 8 photoshopped?
They have hyper-realistic painters that you would never even know if it was a painting or a picture.
So that's
You
a
couldn't
claim
spot it
that
out.
you need to prove.
Himawari uses the Blue Marble data set, right? They paste on
Does
the paste a
So
bunch
they
of shit
they
together.
repaint the clouds so they repaint the clouds on there every day.
Oh, not for Himawari.
Repaint.
That I told you this about the
Optical
Himawari
lenses.
yesterday, and Brandon just explained it to you again. Why are you still asking?
Is it so? So you have so your claim is that
My
Himawari 8
response
is
yesterday
fake.
or Brandon's response just now? Are you deaf?
Do you want to hear
So
our
is-
claim?
B-ball, are you deaf?
So how come I can match up the clouds between Himawari 8
Brandon
and the
just
ISS
told
when,
you, and I
when
told
it
you
comes
yesterday.
over Hawaii?
Yesterday, Brandon told you 5 minutes ago. Are you deaf?
Hey, let me take this real fast.
Go ahead,
Himawari
Hank.
shows pink clouds, all kinds of like weird, like orange colors and like neon colors. Is that what you experience in reality? Yes, it
No,
does.
it
I've
doesn't
seen the
actually.
images.
No,
Yes,
no,
it
it doesn't.
does.
And when I zoom in,
The
I don't
old
see pink
images from
clouds.
Himawari showed all kinds of bizarre colors that
When's the
aren't
last time
real in
you?
the sky.
When's the last time you even looked at it? Because I look
It's
at
been
it
a
every
while.
day.
It's been a while, but I used to call the Globers out on this shit when they would bring it up because the
I pretty
colors
much
were
take.
just phenomenal. Looked like an acid trip.
I pretty much take screenshots of it every single day.
So is it possible to use radar from the ground and
right now.
Sorry guys, give me just a second. Is it okay? Is it possible to take radar imaging from the ground and flip it to a map to make it look like it's upside down and take it from
Well,
space?
you'd
Is
have
that
to.
possible? Once every 10 minutes, right?
So,
Is that
so it's a
possible?
satellite. So it's wait. Say that again. I'm sorry, I didn't hear what you said.
Third time we were explaining it to him. Go ahead, Hank. This will be the third time D-Ball heard this explanation, but go ahead.
Well, your explanation is false, but I'm going to listen to
false.
it anyway.
It's not. Brandon just told you five. What did Brandon tell you when you asked this question 5
So
minutes
I have
ago?
to. So I have to believe what Brandon said.
That's the. You
can believe whatever you want.
Percentage, Brandon.
Yeah. If you think that's in space, you do you. Just don't. I'm not
Well,
fooled by it.
the point is that I'm able to get a screenshot from Himawari of Hawaii, close up, and then wait for the ISS to come over my location, take another screenshot, and I see the same exact clouds. So you're telling me that the clouds in both images are CGI?
B-Ball, did you not?
Tell him again.
I mean, Jeremy seriously is right. We have told you how this is possible.
I told him yesterday. You told him 5 minutes
How is it
ago.
so when I go outside and see the same exact clouds in the sky,
He's stuck on repeat. Are you broke?
Yeah, B-Ball. You see the same pattern that you see on MOR because they're using real weather data, radar data. They're pasting it on.
Yeah, no, it's because it's a real camera taking a real picture.
That's what you say. Prove it.
Right. And so you say there's no evidence. We're obviously presenting evidence. You're trying to falsify that evidence, or
No, we can't falsify it or verify it.
Yeah.
We have
Of course
no
you
way.
can verify it.
No, we
Okay,
can't.
let me know when you're ready
Are
to
they
go.
gonna let us
me know
in
when
the
you're ready to
fucking
go.
office? Are
Let
they
me know
gonna
when
let
you're
us
ready to go to
in their
Himawari.
office? Are they gonna let us in and start moving their systems and stuff to see what they're doing? No, right? So
What
we
do you
cannot.
mean let them in and move your systems. You can watch. You can see satellites.
Yeah, let
yourself
us
with
in the fucking. No. I want to see what is going on in their fucking computers. I don't care what
Do you
they're
even
showing
know? Do you know anything
you
about
on the
computers?
fucking phone. Yeah, I know a little bit of computers, buddy.
What are you going to be looking
Not
for?
much. What do you care?
I want to know who the fuck Sean G thinks he even is. Who does he think he is calling me out like that? I hope you're better than B-Ball, Sean. You monologuing ass motherfucker. Oh, what's up? I'm good.
Yeah, well, here's the deal, you guys. If you want to deny evidence, cool beans, you need to provide verification
Nice
that
framing,
the evidence
RC.
can actually be. Excuse me, that you can actually provide evidence that the verification that we're saying you can use is actually falsifiable and/or has already been falsified. You haven't done
Bullshit.
that. You're just whining about it.
Total bullshit.
Pure nonsense.
So, I'm not saying that this is how any of it happened, but I've been watching the volcano stuff in Iceland, and watching people with doing live shots off their phones. They have a couple of live cameras built, sit there and going all the time, and they've got satellite pictures of the exact same stuff happening at the exact same time. You can sit there and watch that guy's, and that is the same picture on every aspect of it. Somebody's live, just some random YouTube guy, and you're seeing the same pictures that you're seeing off a satellite.
They're still asking the same
Prove it,
question.
guys.
Brandon, they're still
game
asking
over.
the same question.
They
It's like
still
these
don't
guys are
get it.
broke.
From the
Every single one of them.
volcano?
No,
It's like you're broke.
You can actually see up to date every 10 minutes satellite images from the Earth that you can verify.
Yo, you broke them. You broke them, Brandon.
Humanity is doomed.
Brandon, you got them all broken,
you guys
Brandon.
are just
You
really
got them all
hell-bent
broken.
on denying evidence
Yo, what
that
the fuck?
kills your fantasy. With no evidence. You're dismissing the
You
evidence
already said
without
that.
any evidence.
You
That's
already
called
said that.
incredulity.
They're stuck on stupid right now.
Yeah,
Bro,
Jeremy,
these people
you have
think water
incredulity.
curves. What do you
Jeremy
expect?
has incredulity,
come on.
and so he thinks that is evidence.
That's what you. Hey, Jeremy, is there cognitive dissonance right now working?
Something. I think there's
100%.
Right, looking at evidence is cognitive dissonance. Is that what cognitive dissonance is right now?
No, it's not verifiable.
Watching video on the fucking computer is not evidence of anything, buddy. I don't know what you're talking about.
Evidence of the fact.
What? No, like I said, if they let you in the computer and you start seeing the code of that program, what they're using, and all of the programs they're using into that code, then we can talk.
I got a prediction. Ready? If Himawari shows us the same clouds that we can observe in the sky, then they have the technology to use weather radar and cloud imaging from the ground or balloons and portray it onto the Himawari image. There you go. There's my prediction. Oh, we see the same cloud patterns as Himawari
from volcanoes.
Now, how would you do that every 10 minutes? Hey, Jeremy, how would you do that every 10 minutes?
I don't know. Maybe some computer nerd can program it, or
you're trying to falsify something.
Maybe a computer nerd can program it, or there's a guy behind a computer doing it, or something.
Where?
Yeah.
Weather radar?
Who? Where?
Is it not possible?
Is it not possible? Any evidence of it? Do you have any evidence of it?
Is it not possible? You can't verify your thing. You can't verify mine. We're on the same page here.
It's possible unicorns are real. I want evidence. Is there evidence of a man?
Your thing's not. Thing's not verifiable. Neither is mine.
You don't have any evidence. So you're spiraling.
You have no evidence.
You don't have any evidence of it.
You have no evidence.
No, I have satellite images every 10 minutes.
You have no. The satellite images don't prove anything. We can't verify it.
NOAA.org.
It's some shit on a screen. I can verify Freddy Krueger and Jason.
Yeah. So every 10 minutes they correspond with
interrupt just for a second. Let me.
I have a picture of a giant gorilla.
Okay, so
it's real.
What you got? What you got,
Give me
SC?
a second, bro.
I got a picture of a big gorilla. I'll post it.
Go ahead, Hank.
Okay. Yeah, real quick. So the last team I see was on 24/7. He was asked for proof of the direct measurement of curvature of the Earth. He's a picture of the Google Earth data, right? So the maps of the world and everything. And it's like, that's not a direct measurement, right? So for him, like anything that's like going with his theory, anything is evidence of curvature of the Earth.
Yeah, Google Earth is the flat Earth elevation profiles referencing a flat plane. It is.
But it's still curved, though.
Go on Google Earth right now and check it.
But it's still curved, though.
Make a line any two. Oh, it's referencing a flat plane.
Yeah, it's gonna be curved. Yeah.
It's flat. Why is it flat?
Hey, let me say something to Ed real quick to show him why it curved. He wouldn't even know. Look, just doing this simple trig, like from 8,000 miles away. If the sun, just say like take for instance the sun or whatever setting, just say 8,000 miles away, something 3,000 miles wide would fit in the field goal post. Would be the same angle as a let me see what I compared it with. Okay, is a field goal from, no, it'd be half of the size. No, yeah, it'd be about the same size as a field goal from the 50-yard line. 3,000 miles would fit in that field goal from 8,000 miles away. So how would you know if something is circling if 3,000 miles away and your view fits in a 50-yard field goal? I mean, you wouldn't know if something's circling or not.
I don't even think you know what they're saying anymore, Brian.
One other thing is Bob was talking about seeing something 50 miles away, and I think he changed it to a laser. But for any of the people who try to say seeing something from 50 miles away, okay, doing the triangulation on that 50 miles away, you could squash 15 miles, okay, into that same 50-yard field goal. It would fit inside both goalposts, 15 miles. So just about 17 degrees of your sight out of the, just say 120 degrees forward in front of you, that approximately, just in a little tiny bit of that would be 15 miles.
Yeah.
You'd have 15 miles of stuff squashed in that one little area. So they're talking about making out objects.
That's not even debatable. That's not even debatable because Soundly showed it with his hotel on the horizon image. You could see the middle floors as they got closer to the horizon were getting smushed essentially.
Yeah, but that's besides the atmosphere. The atmosphere is the main factor there. But as far as the about seeing something circling overhead and all that, you would never know if something's circling perspective over that distance just because of without the perspective, just the way the math compresses shit plus perspective. But what I wanted to say one more thing, as far as like the magnifying, they won't recognize magnification, and I think we need to show some more examples of that because it's kind of obvious. And they would say, something's magnifying, that it's just magnifying it from the bottom. That's what they say. Rob Skiba's his video shows is that it's they act like it's a trick. He's just magnifying something from the top. But
Skiba's video.
But if you magnify something, you're magnifying from every direction. The top has got to go up, the bottom's got to go down, and the side's got to go out. So naturally, if it's on the ground, magnification would make shit disappear bottom up, man.
Let me tell you something about Skiba's video. That was a turning point for me in flat Earth. I was flip-flopping with it. I'm like, I don't know, sunsets are pretty hard. And then I saw Skiba's video, and I was like, there you go. It's possible.
Ranty's video, or they're showing that video of they're trying to say Ranty's video proved Earth curve with the wind towers, and I mean Ranty wasn't claiming that, of course, but they were trying to claim that because over the distance you're getting bottom up compression, but you could see the magnification in the distance. The freaking wind turbines that were like miles further away were bigger than the ones that were closer. I mean, it's obvious there's magnification over distance. I don't know if it's something that's quantifiable, but should be.
Yeah. Oh, Bob, he didn't want to say again that he has added curvature into his calculation, did he?
Brandon, he doesn't even have straight lines, bro.
I know.
I don't know if he was he denying refraction at the end or something? I felt like he was like saying refraction isn't a thing at the end.
Yeah, one more thing he said. He said that orbits, it's talking about the Saros cycle. They did it by with orbits. When were orbits even invented? Were orbits invented in 300 BC? I mean, what?
No, that
orbits?
Brandon read it off. All that Ptolemy shit, that's flat Earth shit.
Yeah, I know it is, man. But he's just blurting shit out, man.
They're broke. I really think some of these Glovers are broke. I mean, did you just hear what happened in here with the Himawari thing? They're seriously broke.
The Himawari, it says on their site. It says on their site
computer-generated images.
Yeah, overlaid on the 2012 or 2000 NASA Blue Marble. It says on their site that it's images and satellite and weather data overlaid on the NASA Blue Marble. I mean,
they literally say that?
Yeah, dude, look I got a video.
I didn't even know that.
Mirrored from Paul and the Plane.
That's even worse.
I've been playing that on screen, that video. Yeah.
Oh, that's even worse for them. I didn't even know that they actually admitted to that.
Yeah.
They don't lie.
Fuck? Are you guys stupid? Not you guys, the other guys.
I can be stupid.
They've seen that video.
No. What kind of question is that, Jeremy?
I know, it's rhetorical.
That's the thing. That's the thing about globalists. They won't even admit that they can be dumb sometimes. I've been dumb many times in my life, and I've been like, "Damn, that was dumb." But globalists pretend like they're a Jesus-like figure,
It's
and
not
they've
what
got it all
globalist
figured
means,
out.
though.
Yeah, they figured that.
See, now
I
you
did
get
ask
triggered.
I will admit that I'm wrong.
I did ask Bob if he saw the
But
Venus transit.
it seems like flat earthers never admit that they were wrong.
You're a
Yeah,
good
I
clown.
always admit I'm wrong, especially when I'm wrong. I sometimes even admit I was wrong when I was right.
You're
You're
wrong
always
about the shape
Ed,
of the earth.
Ed is a fucking clown. That's what he is. He's
Quiet, Zero.
The Glover's clown. You don't bring nothing to the conversation.
Yeah, go
buddy.
shout.
Never answer questions. Nothing.
Go sit in your truck and shout to people on the road. Okay.
Hold on. And what have you brought?
That's what I'm doing, you lazy bastard.
What have you brought?
Looks like I'm having some bandwidth issues or something. I'm going to restart OBS and Discord. I'll be back in. Shouldn't cut out for more than 15 seconds. All right. Looks like we're back up and running, and we should. here Discord in 1 second here.
That's proof that two things are looking at the same thing, right?
Or it's proof of what I said. Or it's proof of what I said, B-Ball. You can't prove it either way.
What? Well, how
So
would
why
you
is
falsify
Russia?
it?
Why is Russia?
They knew this from coming to Texas 2 days before it came.
How would you falsify it, Jeremy?
How would you falsify it? I can't get to the Himawari 8. Can you?
Well, I'd falsify it by saying, wait, I'll be like, okay, let me look at this picture and look at the clouds outside. They don't look the same.
You're really broke, bro.
Maybe something's wrong.
You're broke.
How is that broke?
Use your fucking head. You keep saying the same shit over again, even though I've told you that doesn't prove anything because
so if I go outside and I see a cloud formation, if I walk outside right now and I see a cloud formation, then I look at the Himawari and I see the same cloud formation. What does that tell me?
You don't understand clouds.
That is proof. That tells you.
Really?
Hold on.
Hold on. Understand clouds?
Hold on.
Clouds have different sizes and shapes. The angle you look at them at.
That B-ball. That tells you that that's
exactly
proof.
The same.
They can't be.
Is my mic low?
And then when I look at the ISS, I see the same cloud also.
Why B-ball? Why are you not letting me respond, bro?
Go ahead.
You asked me a question. Yeah, you know what it tells me? That they have the technology to take weather data, put it over a blue marble image, and fool you. That's what that tells me.
And that's a claim that you need to prove.
You can't prove your claim that it's actually up there.
I'm not claiming anything. I'm just observing what's going on.
Yeah, so
Hold
am
on.
I.
If you put all the images of Earth next to each other, they do not look the same.
Yeah, they're
Take a look at what I posted.
Yeah, we know that.
You guys take a look at the image that I just posted, right? Tell me which one out of those two pictures is exactly the same. The first one, the light. I posted 2 photographs or images. The first one shows the sun coming in at 90 degrees perfectly. The next one shows that it coming in all kinds of different converging. So those two things don't match up, right? So is the eclipse like a different day than the Eratosthenes experiment? And the next one shows the maps, and the maps certainly don't line up. So what are you talking about when they look the same? Are you talking about the images of the globe, where you got the United States like the size of an hemisphere?
Let me just read this.
Because you don't understand.
Hold on.
You don't understand.
Let me read this meme here. Science says that sun rays reach Earth parallel, except on the eclipse, they converge in a cone and make small path of totality.
So which is true? What are the light rays actually doing?
So first of all, the sun's coming parallel because the sun is really far away.
And that's a drawing.
Right. So how do you explain the umbra and penumbra?
We've explained it to you beforehand. I went through about half an hour with you explaining it intricately. Why are you now
Rumpus.
forgetting the explanation?
Let me ask Rumpus a question, y'all, real quick before I gotta go. Hey, Rumpus.
Why would you want to ask Rumpus a question? Why?
Because, man, I want to see if does he think that Cavendish proves mass attracts mass? I just want to see if he thinks that.
Of course it does.
The Cavendish. Okay, well, then I want to do. Okay, you say so. We're talking about being critical. On your own model. So we're talking about being critical in science. So you say Cavendish, of course it proves mass attracts mass. So I want to expand on the Cavendish, and I come up with the Brian dish experiment, right? So we want to find some other things out about mass. So I got a hypothesis that that mass melts with heat, with high heat. So high heat melts mass. So what I did is I took some lead balls, and I applied a bunch of heat to them with my torch. So my independent variable is the heat through the torch. My dependent variable is the mass melting. You know, so I put that to an experiment and I put it through a torch. So I wanted to expand on it. So I tried it with gold. And so hold on, I'm almost done. I'm almost done.
You're saying lead. Okay, it's fine. It's fine.
I'm almost done. Yeah. So I tried the lead. I tried the lead balls, and the heat melted the lead. So mass melts heat. I mean, heat melts mass. So hold on. I tried it with gold. Hold on. I tried it with gold. And I'm almost done. I tried it with gold, and the heat melted, and the heat melted the gold. So I come up with the conclusion, that heat melts mass. So
but it's not.
Not only that,
have you? You've only tried a small selection of masses.
Yeah,
So you
not
haven't
only
proved
that,
at all. You've shown that
not
lead
only that.
melts.
Hold on, Robert.
I melted
Not
the
only
lead
that,
balls
I'm
and I melted
actually-
the gold balls.
Hold on,
Yeah,
Brian.
That's not
Brian,
all
hold
sorts
on.
of mass, is it? That's only
Guys,
two types
I'm
of
Like
mass.
last time, Rumpus, the flat earther is obfuscating for you, so I can't address the question directly towards you.
Right, so I don't know what, Brian, you've shown that lead melts and gold melts. Okay, fine. That's great.
So that's what Cavendish has showed, that lead attracts and gold attracts. That's it. If you try to melt wood, it wouldn't melt. It would burn. If I tried to melt water or if I tried to melt air, okay, the only thing Cavendish proves, if you're saying that all I proved was that heat melts gold and heat melts lead, then yeah, that's all Cavendish proves is that lead grounded, grounded to a copper pipe attracts lead, or gold attracts gold if you did it with gold, which I haven't really seen that. But am I that stupid?
Just
Hold
too
on,
good
Brian.
argument.
What is
Brian, let
stupid
me
about?
tell
I
you
mean,
my-
it's
let
pretty
me tell you-
comparable, ain't it?
Well,
Brian,
no,
let me
Brian,
tell
the
you
thing
my
is, we
experiment. Hold on, Robert.
know all the sorts of things that cause forces. We know about electrostatic
I'm
forces. We know magnetic forces, the gravitational forces. We're pretty familiar with all the sorts of forces that could be causing
we're
this.
pretty familiar with heat too.
Hold on, nearly finished. And we know that those other forces don't exist because they've been eliminated.
Yeah,
So
we know
therefore,
you can't melt mass with other things. We're pretty familiar with heat. We know about what heat does and how to get it and all that, and all the different kinds of ways to get heat. And so we've proven, yeah, mass melts heat. I mean, heat melts mass.
No,
I proved it with lead balls, dude, that heat melts mass.
Yeah, but Brian, the thing is, there's a limited number of forces, and we know what. Well, we've got there are four fundamental forces that we're aware of, and so we've eliminated the possibility of other forces being responsible for this attraction. So we're just
there's
left
only
with the gravitational one.
Well, there's 5 ways for us to make heat, so we one up on you on that one. But yeah, we have proven by melting the lead balls that heat melts mass by melting the lead balls.
Brian, hold on. Brian, let me get in a second.
Go ahead, Jeremy.
We know, Brian, that lots of masses don't melt. So your theory or hypothesis is wrong.
All right,
But we can eliminate the other forces that you think could be responsible for this effect. Now, it could be green pixies. There's no doubt about it. It could be invisible green pixies. We haven't eliminated those. But what we have eliminated is all the forces that we're familiar with, and we're left with the same gravitational force that we know is responsible for keeping the moon in orbit, and that drags you down. And it matches all the equations that we use and can work out for planets, etc. And it all matches with the Cavendish experiment. So it all hangs together consistently, and that's why we believe in it. Go ahead, Jeremy.
All right. I'm currently in the middle of an experiment myself, Cavendish style experiment, and I'm proving that mass repels mass. All I got to do is go to the store and get a little balloon.
Oh, that's stupid, Jeremy. You've been explaining buoyancy.
Mass repels mass. I'm showing it. I'm going to demonstrate
Stop it. No, you're not. All you do is proving buoyancy.
Repels mass.
You do understand that buoyancy can only exist in terms when there's gravity.
We want to learn more about mass, bro. We're going to do all these tests to lead balls.
Rumpus just made a claim. Let him prove his claim. Hold on. Rumpus just made a claim. He said the buoyancy can only happen when there's gravity. Okay, so take away the gravity and
you
prove
never
yourself
prove
right.
your claims. Please,
Hold
down.
on. He just made a claim. Bro, why are you going to talk over me?
Time and
I'm
you
here
prove
like 5
anything.
seconds.
Never.
I'm here like 5 minutes a week.
Yeah, you're good, Hank. Go ahead.
5 minutes
Go
a
ahead,
week.
Hank. Shut the
And
fuck up. Go ahead, Hank.
I cited my source earlier about the heavy fuel. Did you look at that? Why don't you go look at that shit?
Yeah, that's one paragraph.
Why don't you go look?
You didn't talk about your claim. You didn't prove shit. Try again, Hank.
Yeah, it's up there.
This
I
time,
posted it.
please,
You
the
can't bring heavy
source
fuel.
of the Antarctic treaty you talked about.
I don't know why why are you obfuscating
You
for Rumpus?
talked about the
Why are you
Antarctic
obfuscating?
treaty. You
Why
didn't
are
prove
you
anything
obfuscating?
about it.
Why are you
triggered.
obfuscating for Rumpus? He just made a claim that it only works with
You
gravity.
make
So
claims
Rumpus,
all
prove
the
your
time,
claim.
so why don't you settle down and
Bro,
prove your claims first, Hank?
Bro,
How about
relax,
that,
bro.
bro?
Relax.
I am relaxed.
Relax.
I am.
Why are you sitting here all day without a job, bro? How come you sit
Yeah,
on your ass
cool
all
story,
day
bro.
long?
Yeah, you're dodging. You're dodging from the fact you never present evidence, Hank. But nice try.
I actually did present evidence. I posted
No, you
cited
didn't.
my source.
No, that's a blog post. Nobody cares about that.
You've posted
It's
something
a
that
blog
shows gravity
post.
doesn't work. Well, buoyancy doesn't work. Is that what you're saying?
No, that's not what I'm saying.
So you've changed the subject completely. You've just introduced a new subject.
Ed changed the subject. Ed changed the subject, not me.
Relax.
There was an old, this
Ed
is an
changed
old
the
topic.
subject.
You were complaining I've made a
Why
claim
are you so
about
mad?
buoyancy.
Hey, Ed, why are you talking now when I'm trying to talk to Rumpus? Because a flat earther forgot to interject this time?
Hank, chill out.
Every time I try to talk to Rumpus, a flat earther interjects, and when a flat earther fails to do
Drink
so,
a beer,
here comes Ed to save
kick your
Rumpus.
feet up,
Thank you
chill
for
out, dude.
saving Rumpus, Ed. Thank you for saving
sure.
Rumpus.
I'm happy to
Thank you for
ask me a
saving.
question.
Thank
Take a
you for
break, Ed,
saving
for a
Rumpus,
couple of
Ed.
minutes.
I'm happy for you to
So
ask me a
mad.
question, Hank. Don't know what you think you've been denied to ask me.
Yeah, the past 2 times I tried to talk to you, a flat earther
Well, ask the
interjected.
question then. I haven't heard it yet.
Okay, so you just made the claim that buoyancy only works with gravity. So why don't you remove gravity from the situation and see if it works?
Sorry, I missed that. Sorry, I interrupted you there. What was the last part of that? I missed the last part of your question.
Okay, so you made a claim that buoyancy and density, the what we call specific
just
gravity,
buoyancy.
it
Just
only
buoyancy.
works. Okay.
Only
Isn't
buoyancy.
there
A buoyancy
density
can only exist within a gravitational field. Yeah.
Okay, so remove the gravitational field, all of it, and prove yourself right. Or you're just talking out of your ass.
Yeah, like you.
Well, you can do that. You can go into space, and then you see that buoyancy doesn't have.
I
and you
can.
Oh, hold on. Can I just finish? You can do that. Go into
can,
space.
okay.
ISS. Hold on. Can I just finish your response?
Yeah, go ahead.
So you can go and be quiet. I'm responding to you. Jesus Christ. So you can go into space, as we've done with our astronauts in ISS, they can show that buoyancy doesn't work up there. Similarly, if you go on the vomit comet, you can see the buoyancy stops working there in free fall, which is effectively a zero gravitational environment. So there, I've proved it. There you go. Carry on.
Okay, so the vomit comet is not zero gravity. Why are they
It is
falling?
an effect. It is an effect.
Why
When something's in free fall, then
Why are you
I
falling?
thought gravity.
Why are you
If you
falling on
have
the
it in
Is
free-
gravity the
Jesus
cause?
Christ. In free fall, you effectively do not the objects that are subject to free fall do not have different gravitational forces. So you lose any buoyancy effects in that. Free fall effectively eliminates the gravitational effect and buoyancy in that process.
So when things are falling, they don't fall at 9.8 meters per second. That's
They
the claim?
do, but they do not have differential forces on them, and therefore, because of that, because when you are in you have a density tower on the ground, they're prevented from going downwards, and therefore you end up with the different things trying to displace one another. But if they're all falling at the same rate as they are when they're in the vomit comet, or in fact, if you just drop a bottle with bubbles in it, the bubbles no longer float to the top, and the water. So you cease to have buoyancy effects
genius.
when you
Something
have free fall, and that's
falls. They're
because
falling.
you cease to have the differential acceleration.
That's genius, Rumpus.
in the object.
Okay, so you said there's no gravity in the vomit comet
No, I
and in
didn't say there was
space.
no gravity.
If there's mass,
Effectively, there's a difference between no gravity and free fall when there's no difference between objects not being prevented from falling, and therefore it's not no gravity, but it's free fall, which in many ways emulates zero gravity. Go on.
First off, it's Friday night fights.
effectively.
Nobody has to
Okay,
settle.
so you can't actually do no gravity as long as there's mass.
Buoyancy disappears in free fall scenarios.
So being fully fully falling, which you would ascribe to gravity, being fully in the throes of gravity negates gravity.
That's
I know it's a
fucking
little bit
brilliant.
difficult to understand for thickies, but
No,
we'll
no,
try.
it's
we'll
not
try it.
difficult to
You're still-
understand. It's just a
Yeah, I
little
know it's
trick you're
difficult for you
trying to play on
understand.
yourself.
I know it's difficult for you to understand. It's a little bit tricky for
No,
thickies
it's
to
not.
understand.
It's no.
It is because you
I
don't
don't think
understand
you
it.
understand my point.
No, you don't
I don't think you
understand
understand my point.
Do you?
You don't
just
understand
admitted
my
you don't
point, do
understand
you?
it.
You can't understand
Yeah, I
it,
do
can you?
understand your point.
No, I don't think you understand my point.
I do understand your point.
No, you don't.
And I'll explain it if you give me a chance.
You've never understood
so,
it.
I do understand it. I understand you don't understand. So when you are still falling, but the difference, for instance, you do not feel weight. For instance, if I dropped you in the vomit comet, you would not feel weight. Just as in any free fall scenario, you do not have differential gravitational forces. So, for instance, in the density tower you have on the ground in your room, there's an attraction between all of the layers in the liquid in the density tower, and the one that has the greatest force, which is the greatest density because it's a per unit volume thing, will displace the things of less density.
Right.
If you remove the separation of that force, so that things are free to fall, so there's no differential forces, then the buoyancy effect disappears completely.
When things
And
are
as
all
we've seen
falling at the same rate, they don't displace anything? Wow, that proves nothing.
Well, it proves that gravity
does.
It proves that differential gravity is the
No,
cause of
it doesn't.
buoyancy.
No, it doesn't.
Wait, you understand? I mean, it's a little bit tricky. I mean, perhaps I'll
No,
just draw
you
some
think it
diagrams.
proves that. It doesn't prove that.
It does prove that.
All
Exactly
of them
what it
are
proves, because
falling
when
at
you
the
have
same
free
time.
fall,
What else would you
when
expect?
you have free fall,
What
then
else
you
would you
don't have the
expect?
buoyancy effect.
Hey, can I ask a question related to this, please?
In free fall, you do not have buoyancy effects. Do you deny that?
That's because everything is falling.
So you do accept that in free fall there are no buoyancy effects.
This is all irrelevant. My
Hey,
experiment is going to show. My
Oh, no,
experiment is going
Jeremy,
to show.
why did you interrupt that crucial point? Jeremy, why did you interrupt that crucial point there? Brandon,
Friday
do
Night
you
Fights.
accept
Go
in
ahead.
free fall there are no buoyancy effects?
Yes, everything is falling.
Right, so you do accept there's no buoyancy effects in free fall. Okay, good.
Everything's
That's a step
falling.
backwards.
Yeah.
Right,
He
so
said
you do
yes.
accept
What's your point?
Right, so
what else would
Can I
you
ask a
expect to
question,
happen?
Brandon, before you go on? Can I ask a question related to this before you go on?
Wait a minute. No, hold on. So what would it be? What would it look like if everything was falling and it wasn't gravity?
Well,
that
things
caused
wouldn't
buoyancy?
fall if there was no gravity. There has to be a force there,
Oh,
which is
for
the only
fuck's
force
sake.
it can be. There has to be a force, of course, falling. The same force you see on your bathroom scales. There has. What? How do you account for that
okay.
force?
So anything that causes things to fall, no matter what it is, if it's gravity, mass attracting mass, or if it's bending space time, or if it is green pixies, you'd expect the same thing. Is that right?
Well, there has to be something that all masses
There
are
has
pulled
to
down.
be
Who's got the
something.
bloody-
That's my point,
Who's
Rumpus.
got the TV in the background?
There
Somebody's
has to
got
be
an echo or
something.
something.
So this result of yours that you're claiming proves gravity isn't a unique result to gravity. It would happen no matter what was causing things to fall. Is that right?
No, because the things that cause gravity are mass dependent. The only thing that's mass dependent is gravity. The only thing we know of is a force that is proportional to mass is gravity. None of the other forces that we know of are mass dependent.
Are you really going to act like you don't see my point?
Well, no, you
This
don't understand the
result
point.
that you're trying to use as a reason
No, but
why
you don't understand my point.
there's gravity doesn't make
But
any
there's
sense.
no other force that's mass dependent. All the other forces are dependent on charge or magnetism or something else, and it has to be mass dependent to
Hold
get
on,
the effect of a different.
That doesn't prove mass attracts mass. It doesn't prove
does, it
bending
does.
space time.
Hey,
No, it
Rumpus.
doesn't. No.
Hey, Brandon, may I ask a question before you get off this
I'm about
topic?
to prove mass repels mass with mine.
Not your buoyancy, but could you explain to
Mass
me
repelling mass.
in the vomit comment when they go over the parabola how the relative density of objects changes?
Yeah, that's a good one.
How the relative density of an object changes.
Right, because when they go over the parabola in the vomit comment, relative density, if relative density is a thing, well, how does that change the relative density of stuff by going over the parabola?
It doesn't change the relative density of anything. Why would it change the relative density of something?
Exactly. Why? But yet it floats around, and you're saying that the
It
attraction
doesn't
of the Earth
float around.
It does.
It's
Yes,
falling.
it does.
It doesn't float around. You dumbass.
It is floating around. Have you
It's
not
not
seen the inside of the
floating
vomit comment?
around.
It's free
That's
falling.
not what's happening.
Who's
But if the relative density hasn't changed, nothing of the relative density has
So
changed. has it?
what? You think that things are floating around in the vomit comment? That's what you think's
Yeah.
happening? That they just start
You
floating?
haven't seen them like float around and stuff?
Are you
But
not
you
aware
claim
that
things
that's
are falling
happening
due to
because
relative
they're all
density, Brandon.
falling?
You're claiming things
Actually,
fall
no.
down.
On the first half, excuse me, on the first half of the parabola, they're still going up. You didn't know that?
Leaky, fix your mic, please.
Yeah,
The first
yeah.
half of the
Listen real
parabola,
quick, real quick.
They're still going up. They're not falling.
Listen
Yeah,
real
just
quick.
fix the echo, bro.
Yeah, the
Who is
first
that?
half of the
Know that?
parabola, are they floating during the first half of the parabola?
That's correct. They're floating on the first half of the parabola, and they're still going up.
Jeremy,
And
that's
then
your
all of a
AirPods, man.
sudden
You
they
always got
start
echo.
going
You gotta
down.
change those, bro.
Rubbish.
My
It's
AirPods
absolute load
never.
of
No.
rubbish. There is no way they could be floating inside the zero-G plane while it's going up.
Personal
Literally,
incredulity.
they start floating because they've gone
No,
into a
you're
steep
incorrect.
dive.
Evidence
No,
will display-
you're incorrect. They
This is
go
why
over
you
a
don't understand the
parabola.
difference between acceleration and velocity.
So
You
a
can have,
dive.
you
No,
can have acceleration. You can
parabola.
have
They go up for the first half and come down
and
for
then
the
they
second
go
half.
down.
They're
Yeah.
floating for
And
the
that's
entire
when it looks
time.
like they're floating.
No, the
they're not.
entire time they're floating. I can
So they're
also show you.
essentially-
You take off from
I can
the
also show you a drop.
ground. You take off from the ground. You are not going to float on your way up.
That's
That is
on the
ludicrous.
parabola. No, you're
essentially.
Look at this.
Dude, I
Look
take
at
off
this.
from the ground. I'm flying
Can I
up.
interrupt?
How am I going to be floating?
Because
bridge
you
the
can be
gap on this one.
accelerating downwards while still going up and towards the top of the
So
trajectory.
every person
Hold
who
on,
gets on
Paige,
a
let me
plane
finish
who
my sentence.
takes
Let me
off
finish
from
my
the
sentence,
ground
Paige.
starts
Please let me
floating
finish my
in the
sentence.
plane.
the
Please
parabola.
let me finish my
You're
sentence.
saying if we don't put the
Jesus.
seatbelt on the
Paige,
airplanes, we're gonna float.
Paige, near the
if you
top
do
of
a
the
parabola, that is
near the
correct.
top of the trajectory, you can be accelerating downwards while still going up. If you knew the difference between acceleration and velocity, you would know that, and you are going to weightlessness before they reach the top of their trajectory.
Dude, yeah, it's 9.8 meters down. I think solids fall in air due to disequilibrium.
Exactly. So how does the gravity disequilibrium change because they start doing the parabola maneuver in the vomit comet? I would really
No,
like
it ain't
to know
got nothing to do with gravity disequilibrium. It's density disequilibrium.
Okay,
I know the answer.
How does the density change? What changes on the? Okay, someone tell me
Let
the
me
answer.
ask you a
please.
question then. So if we take a beach ball
Pilot
and
match
we
the so-called attraction of whatever you guys
Let
call the
Brian,
force going
Matrix, let
down.
Brian explain. He was in the middle of explaining there.
Someone
if we take a beach ball and we let half the air out of it, right? And we take it down to the bottom of let's say a lake, a sandy bottom lake, and we
What's
pin
that
it
got
to
to
the
do with the
bottom.
vomit comet?
Yeah,
No,
Brian,
and
you're deflecting.
no, this
He's
has to
asking
do
about
with,
why
gravity
things
argument.
cease to be, why things buoyancy no longer works in the vomit comet, and the relative density of these things, the density tower hasn't changed.
Yeah,
Yet
if you
suddenly
shake a
everyone-
density
I don't care
tower
about
up,
that.
if you
But
shake
if you
a
claim
density
the only
tower up,
cause is relative density, and we
Rumpus.
haven't changed
Hold on,
the
I'm
relative
just asking you what your
the
model
effect
predicts here.
wouldn't change.
If I
If you
take a
shake
beach
your
ball
ring-
and I take it down to the bottom, it's half full of air. I'm asking what your model
This
predicts.
has nothing
We're
to
asking
do.
about the vomit comet,
Has nothing to do with
Brian.
relative density in the vomit comet. I'm sorry.
the vomit
Can you
comet
stick to
is
the
This has to do with your model of gravity, okay?
No, we're asking
no,
about
it
the
doesn't.
vomit comet. We're asking
No, they
a
don't want to
specific
answer this
question.
one, do they? You
Brian,
don't even
we're
want to hear
asking
the
a
question,
specific
do you?
You're
question
backing away from the
about
answer.
the vomit
Who
comet.
gives a shit, dude?
Why?
It's a whole
Yeah, you
topic.
don't want to
Exactly.
talk about
You
it.
don't want
Okay,
to talk
Brian.
about it because
Yeah,
you don't
just
have an
made
answer
clear
for
you
it.
don't want to answer that question. Okay, can someone else in the
Alright,
front
well, if you
answer
stop
the
talking,
question?
I
I
will
was
tell
attempting
you.
to answer it, and you told Brian to answer.
Yeah, well, I thought he was going to answer the question that Shillard asked, but obviously he didn't want to, and he said he didn't
And
want
then
to.
you wouldn't
so
stop
Just in case.
talking,
someone else
Rumpus.
answer
Hold on,
that
hold on.
question.
Just in
I
case,
got the
can
answer.
you guys make the question? Just make it concise, so it could be.
Go ahead, Shill.
So when the vomit comet or a Joji airplane starts the parabola, what changes with the relative density to cause everything to float?
Well,
Yeah, I got
to me, the only thing that changes is the where he decides to point the plane. There's supposed to
But
be an
what's that
attraction.
got to
Hold
do with
on,
relative
hold on. He said the parabola. That's when it goes up and down, right?
Yeah, but you claim
Yeah.
that gravity is caused by relative density change
Let him
or
fucking
difference.
answer.
There is
Shut
no
up.
difference in the relative
Rumpus,
density,
shut
is
up.
there?
Well,
Shut
in
up.
either position. Yet
Rumpus.
it changes.
Are you gonna let me answer, Rumpus? Yes or no?
He's not. He can't stay. It's one of these times where he can't
What
stop. fucking
causes
talking.
it will be the change in direction.
But that's not relative density, then, is it?
No,
You claim that
listen.
gravity is caused by
There's some
density. The
confusion
direction
here.
of the plane is irrelevant to that.
Here is the article on this vomit comet.
God.
It says operating principles. The aircraft gives its occupants the sensation of weightlessness by following a parabolic flight path, which is what you said. While following this path, the aircraft and its payload are in free fall in certain points in the flight.
That's it. That's the
Yeah.
whole story.
Yeah, but they're still going up too.
If you take the plane away, they're just going to hit the ground.
The aircraft is used in this way to demonstrate to the astronauts what it is like to orbit the Earth. During this
There you
time, the
go.
aircraft does not exert any ground reaction force on its contents, causing the sense of weightlessness. That's when they are in free fall.
Yes,
I got you. So what changes with the relative density? I mean,
Nothing
relative density
changes
causes
with
this.
the relative density.
Well, then
Everything's
why do they start
falling. Why
moving?
is this so
That's the
hard
cause
for
of
you to
gravity.
understand?
You
Wait,
claim that's
well,
the
wait a minute.
cause
Hold
of
on.
You
Relative
claim that's the
density.
cause of the
Everything's
fall.
falling.
Floating, you're
Why
If relative
would
density,
this
if relative density
impact
causes
anything?
if relative density causes the attraction Why? How does it change when they start doing the parabola?
Everything is falling.
Actually, they're still going up at the
No.
first half. But
Well, the following this path, the aircraft and its payload are in free fall at certain points of its flight
but they're
path.
not falling yet. They're still going down.
Guys, can I take care of this when you guys?
I can show you a drop tower
Get
that
the
does the
mic
same
out your
thing.
mouth, Brian.
During
Can I
this
take
time,
care
the
of this when you
aircraft
guys
does
are done?
not exert any ground reaction force on its content. Everything
That's
is
correct.
in free fall.
And there's nothing to do with relative
And
density, is
nothing to
it?
do with
No,
relative
then why are
density.
you guys using it as an example to
Because you claim that
disprove
relative density
This
is
has
the cause
nothing
of
to
things
do
to
with it.
fall.
The relative
We don't
density.
say anything about things falling
You
impacted by
claim
relative
that
density.
relative
When
density
everything's
is the
falling,
cause of things
what
to
do you
fall.
expect to
Hold on,
happen?
And the relative
Wait.
density doesn't
What
change.
do you expect to happen? What do you expect to happen? If it's relative
Hey, everyone's talking
density,
over everybody else.
what do
Someone
you
please tell me.
expect to happen when everything is falling? If it's relative density, what do you expect to happen when everything's
And the
falling?
people are falling at
Your
the same
relative
rate.
density
They're
has been
not falling, though. They're still
invalidated.
going up.
No. When
still going
everything
up.
is falling,
Yes.
what
No.
do you
Here's another
expect to
shot.
Why is it
happen
falling,
due to
Brandon?
relative
It's
density?
got
Why is it
nothing to
falling?
do
There's
with
no relative density. If relative density is gravity, why are they falling? You said the relative density doesn't
Okay,
change.
let me
What
take
the,
this
that
one,
doesn't make
Brandon.
any sense at all, what you're saying
Yes,
right
it
now.
does, actually.
You're getting more
No, it
stupid
If you
doesn't.
say
time,
it's
Brandon.
relative density, what changes when they start going over the problem?
I can tell you. I can tell them if you guys will let me.
What? Tell me, Jeremy. I bet this is going to be
They
good.
won't. They won't let me. Please.
Jeremy, no, go ahead, please.
Brian, you're
Soon
so
as it-
distorted, we can't hear a thing you're saying. Let Jeremy
These are your
speak.
fellow flirts talking over you, not me.
So when you take that
And can I
density
ask a question
tower,
after?
Oh,
take that density tower, and you start shaking it up, what happens? It gets mixed up, right? You're just
no one's
standing on the
shaking it
ground
up. It
shaking-
doesn't get shaken up.
You're essentially shaking it up by going
No, you're
up
not.
and down.
That's exactly
Yeah, it
what
does.
you're not
Every
doing.
video we've seen, it's getting shook up.
No,
Not
that's
only
just
that,
a loss
even
of
the up and
buoyancy
down-
effect. It's not shaken up.
The up and down motion of the plane is essentially shaking the density
No,
tower
it's
up.
not. It's very smooth.
Yes, it is.
No,
If I
it's
move
very
something up
smooth.
and
It's
down-
not shaking it.
Can I shake something by moving it up and down?
It's
It
not.
doesn't look like smooth when they hit the
In
ground.
opposite directions. That's not what happens in a plane.
If
It's
I-
very
if I move
gentle
something up
and
and down-
all in the same
But
direction.
it's still shaking,
It's
Rumpus.
so
It doesn't
No, it's
matter.
not.
It doesn't even
Oh,
matter.
so
It's
so
in
wait a minute.
disequilibrium when it's
So
falling,
we
y'all.
explain the density
It,
tower.
hold
What about
on,
the-
no.
what about the
Hold
astronauts
on.
floating?
It's in
Get the mic out your
disequilibrium.
mouth.
If you raise it up in the air and then drop it, you put it in disequilibrium. Okay.
There's no such thing as disequilibrium. It's an absolute
How does
drivel.
the disequilibrium change when they start going over the parabola? Someone please, no one's explained this yet.
When you took it off the ground, you took it out of equilibrium. When you forced it, when you used force to get it up in the air, you forced it out of equilibrium.
No such thing.
No, then how come it's not always weightless on the ground when you're in flight?
Do you
Most
guys
of the time
really
it's
don't
just-
understand
That's a simple explanation, bro. Now answer that
The
question.
deal here is, Brandon, is that you guys cannot explain this by relative density.
Explain what you
I just did.
You
The
still
bomber
I just
haven't
did.
said
If you want to hear the explanation, listen. In our model,
What do you mean? Of course it doesn't make sense because your model for what attracts you,
Hey,
with
can I
your
interrupt?
model to how gravity works with relative density doesn't work in the vomit comet. You have to
in our model on the
That's
ground
because
is zero. And our
It's 'cause you're
model
shaking
on the
the
ground
density
is
tower up.
equilibrium.
No,
Okay,
incorrect.
not.
Then
And your
how does that
model,
explain-
free
how does that
falling is
explain
zero.
The density tower. How does that explain the fact that everything else in the plane floats too?
It's because you're essentially the plane by going
Gentlemen,
up and
please.
down.
Can I interrupt?
There is no shaking, Jeremy.
All right, here.
Yeah, we're
hold
not
on,
going to
let me
discuss
say this.
shaking. Brandon, please. tell
Doesn't
us
matter,
how the
man.
density
It's in
tower works.
disequilibrium. It's
Hold
free
on.
falling.
No such thing. Yes, but Brian,
relax.
why does the
Hold
density
on.
tower cease to have all the buoyancy effects it has?
I'm trying
And
to
that- and
answer
it's
the
still got
question.
Let
the
Hank
same
answer.
relative
Because it's
density.
fucking free falling, Rumpus.
Hold on,
Exactly.
Brian. Hold on.
Why is it falling? I thought it was
Does not
relative
account for
density.
the behavior then, does it?
Guys,
There's something else
guys.
going on, isn't there, Brian?
Can we let
Something else going
Hank
on.
answer? Can we let Hank answer, please?
Right. So earlier, Rumpus said that specific gravity, also known as relative density, doesn't
I
work
didn't say
when
that.
there's no
I said
gravity.
buoyancy didn't work. I never said relative density and
Rumpus,
specific
stop
gravity
interrupting
doesn't work.
people, man.
I said
Okay,
buoyancy.
what causes
Frigging
the
quote
buoyant
me
force?
properly.
What causes the buoyant force? Relative density of the medium.
No, it's not. It's a
compared to the
combination of
buoyant
gravity
object.
and density. Without gravity, there is no buoyancy.
No, it ain't.
Well,
It's a
you can't move
acceleration of something falling 9.8 meters per second due to disequilibrium. You just said you just. due to gravity. That's all.
All
he does is
there's more
scream,
to it than
and
just
quite
relative
frankly-
density, isn't there? You've
So
just
there's
described
another
another
force. Thank you very
factor.
much.
So
No,
there's
no, 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 no.
accepted
Here's how buoyancy
there is
works.
more to this behavior than just relative density. You've just admitted it. Great.
No, I didn't. Yeah,
You
because
did.
we're
You said
starting.
it was another
Yeah,
factor.
okay. Yeah, because so 9.8 meters per second is caused due to relative disequilibrium.
But
Brian, what changed? What changed? All we did is start going over the parabola. What
No,
changed? with
you're the
relative
one who has
density?
to. You're the one who has to start measuring your force after exerting a force to get it up in the air.
Okay.
Okay.
What are you
So
talking
let's
about?
start at
What do you
let's
mean
start
by
at ground
gravity?
zero. Let's start at ground
Clarifying
zero.
question.
Nobody's used any forces
No, we're not talking about
whatsoever.
gravity. We're talking about relative density disequilibrium.
Yeah, no
Why
shit. That's what I'm
relative density
talking
changes
about.
When you go
That-
over the parabola in the vomit comet, no one can explain
That's the whole point, dude. If you want to understand it, then you have to listen for a second. Okay?
Brian, the
In your model,
Brian, stop
zero
answering
is
him.
free falling.
He's not going to get it. We've explained it like 10 times already.
No, you
These
haven't.
guys
You haven't
don't
explained
get
it.
it. They don't
You haven't
understand
not
it.
explained it.
Brandon,
They're
we
not
understand
capable of
it
understanding it.
perfectly.
They're too
No, you
stupid
just-
to
I mean, you just
understand
You have
it.
not explained it. You have
Brandon,
not
we
explained
Here's
it.
the
understand
simple,
it
concise
perfectly.
thing.
Why don't you
The
tell us how
relative
it works?
density in the tower and the density tower has not changed, yet its behavior changes. Therefore, there's something else besides relative density that has changed, that has caused the density tower.
disequilibrium.
But
Hey,
you
Paige,
claim
equilibrium,
it's
Rumpus.
just relative density, Brian, and there's something else
It's
going on, isn't there? Because it
falling.
changes its behavior.
I claim
it's not.
that
It's
it's
supposed to
relative
go up.
density disequilibrium,
So is this
Rumpus.
Out of your
Anytime you
fucking
put
mouth. Are you
bring something out of
Jesus
equilibrium,
Christ.
it's gonna
Getting more
be
stupid.
it's gonna be a
You see this tower?
disequilibrium
It's
seeking
still- it goes
equilibrium.
up. As
Can't
it's
get
going
around
up,
it.
It's weightless. Why is that?
It's not weightless.
Okay,
It
yeah,
is.
okay,
Look
here
at
it is.
it.
Here it is,
It's falling.
Rumpus.
No,
Tell
as
me
it goes
one
up,
way.
It's still weightless.
It's falling.
Tell me one way to
No, it
bring
goes
to
up.
get. Tell me one way to bring any mass out of equilibrium.
Brandon,
and
why
it
don't you
not
tell us how
and,
the
and
vomit
put
comet
put
works?
something in disequilibrium and show me it not trying to
There's
seek
no such thing as
equilibrium.
disequilibrium. There's no such thing as disequilibrium. You're talking
No bullshit.
gibberish.
Hold on. I can show you
made up
something
term.
not obeying your gravity.
So
Now
how
you
does
show me
the
something.
disequilibrium
You show me
change when you
something
go over
obeying
the
my
parabola?
disequilibrium.
But
You hear me,
Brian,
Rumpus?
you've just accepted that the density tower
Brian, why
changes its
did-
behavior depending on how it's
It went
formed.
the
Did you see the
opposite
video?
way.
Which
Why
means
did it
there's
go the
more
opposite
than
way,
one
the
thing
density
going on.
tower?
It's not just the relative
Paige, watch this
density
video. It goes
that's
up.
causing the density tower to be how it is. The density, relative density of all the objects there have not changed. Yet it is changing the behavior, which means there's something else that's causing the
They
density tower
ordered
to
themselves
have the shape
in
that
an
it does.
opposite direction.
When does it mess up, Rumpus? Exactly when does it mess up?
As soon as
When
they start
it's
going over the
free fall.
parabola. Amazing, isn't it?
Okay, so you're saying
Yeah,
when it's
Paige,
going
that's not
up.
how it
Okay,
works.
so
If you'd
you're
like
putting a
me to
force
explain
on
it
it,
to
right?
you, I will.
Yeah, but what
As
changes
soon
with
as
the
you
relative
start
density?
moving it, right? Hold on. As soon
It
as you
changes with
start
the relative density.
Go
Relative
somewhere with it,
density
right?
is what's causing this. How does this movement of the airplane affect the relative density? How come in this tower?
I just
thing
asked
showed
you.
as
As
it's
soon as
going
you
up,
start moving
it's
something,
weightless.
you're disequalizing it.
So,
But
Brian, there's
no,
something
so every
else
time I
going on in
move,
there.
I'm. So how come I'm not weightless in an airplane all the time? It's only when I start doing the parabola
Because you're
maneuver.
not falling in an airplane all
Well,
the time.
can y'all tell me
I wasn't
one
just falling. That's
single?
what it was relative density disequilibrium.
Let me finish
It's
one sentence
changed.
without screaming, y'all. Let me finish one sentence without screaming. Can you give me Rumpus? Rumpus, can you give me?
You know, Brandon.
Hold on.
every
Let me
time
finish
you say
one
because you're
sentence
falling, you're
without having to scream,
acknowledging that there's
Rumpus.
an external
Okay,
Rumpus.
go ahead. Go ahead.
in the.
I don't
in
think
the-
he sees that,
Can
Dr.
you
Bob. It
tell
really
me
does.
one? Hold on, man. Damn, Paid. Really?
I'm fine.
One sentence without having to scream here. Okay? Can y'all give me one demonstration
Every
of
time you
something
say
out
that
of
it's
equilibrium,
because it's
not
falling,
seeking
you're
equilibrium?
acknowledging
Can
that
you give
there's
me
an
even one
external
example?
force acting on it.
No, I'm
When you
not.
talk about an equilibrium, you have to talk about the equilibrium of what? Forces? You can't just say equilibrium. You've got to tell me what it is you think is not an equilibrium.
Okay, something of any
See, I can
mass,
answer your
any
question.
mass
I can answer your
whatsoever on
question,
Earth,
Brad,
any mass
because
on
Brian
Earth.
is just
Okay, just say you walk
continuously
outside and everything's just where it
Now,
is.
if you want me to
Okay,
answer the
everything's in
question,
harmony.
you
Now
gotta get
bring
Brian
one
to be
thing,
quiet
bring
first.
one
There's no
mass out of
question.
equilibrium.
The
That's my
question
point.
That doesn't make
that
any
every
sense.
time
Equilibrium. You want to talk talking about force. You better let Dr. Bob speak before he explodes. Go ahead, Bob, before you die, before you have a...
Before you start,
Well, what are we talking about? What are we talking about? What are we talking about when we're talking about relative disequilibrium? We're talking about masses, right?
Acknowledging
And fluid.
that there's an external force acting on it.
You're very quiet, Bob.
No one is acknowledging an external force.
Well, you are. Every
If
time you
you
say
say
that they're
it's
falling
falling,
without the relative
you're
density
acknowledging
changing,
an
you're
external
acknowledging a
force.
No,
force.
I'm not.
Exactly.
Yes,
you
you
are.
are.
You
No.
have to. Well, you don't realize it, but
And
you
why do
are.
they fall?
That's what
Why do
you
they
think.
You
fall?
don't
That's your
understand
model.
what's going
I'm
on.
not
Why do they
acknowledging an
fall?
external
But
force.
you
I
have
don't
to.
need an
Why are they
external
falling? Why are they
force.
falling and it's still going up
They
to the first half
fall
of the
because
parabola?
you brought them
I
up
can
there.
tell
in
you
the first
exactly
place.
what
times
the
it's in
cause of the effect
disequilibrium.
is.
Brian,
Yeah.
you claim that relative density is the only cause of the behavior of the density tower, and yet you've
No, I
just
asked
accepted.
you.
Hold on, Brian. Please let me
I
finish your
asked you to
sentence.
give me one
Brian,
example.
let me finish your sentence, Brian.
Well, you didn't answer
claim,
me. Go
along
ahead.
with Brandon, I'll answer your question. But let me. I just give me a moment. But Brandon and you and other people claim that relative density is somehow the cause of falling down. In the aeroplane, the relative density has not changed, yet the density tower changes its behavior. So there is another factor that you need to explain
Yeah,
as to
the
what
fact that you
causes
brought it up
the
there with
things
an
to
airplane.
occupy according to their density.
Seriously?
And at
Doesn't
the moment, you've
relative
only got the
density
relative
change
density
every
hasn't
time they
changed.
go up and down? Doesn't it change relative
It's
density?
falling.
No, it doesn't.
No, it
Rumpus,
hasn't
every
changed,
time you
Brandon.
Why is it
leave
falling,
out
Brian?
disequilibrium,
Why
you're
is it
not
falling,
being honest.
Brandon? Why?
It has to
Hey,
be the disequilibrium between
that's a
two
shill.
things.
Every
You
time,
can't just
and
say
Rumpus, every
relative
time
saying
you
there's
leave
another
out the
force
word
involved, Brandon,
disequilibrium,
what's not
you're
in
not being
equilibrium.
honest.
Brian, you have to say what it
You're
is
not
that's
being
not in
honest, Brian.
equilibrium. You
Brian,
can't
Brandon's
just
admitting
use the
there's
word
another force
equilibrium
involved.
without
He doesn't
defining
understand.
what it is that's not in equilibrium. What force is not in equilibrium?
Anything, any mass or
Oh,
matter on Earth that you bring out of equilibrium,
Brian,
you can change its medium and put it in
What does that
disequilibrium, or you can move it and do a
What
different
does that
medium,
mean?
or you can change its state.
What
No matter
equilibrium
any
are
of
you
the
talking
things
about?
you do, will put it in
Brian,
disequilibrium.
Brian,
What
you're, like,
equilibrium are you talking about? You have to be in equilibrium between two things, two
Do
forces.
you want me to answer
What
that
these
again?
forces
Okay.
So
are you talking about?
everything is good and stable until we start this maneuver and we go over the top of the parabola and suddenly everything starts floating up because we're falling, but the relative density of everything which causes this attraction is still the same, but everything's floating, right? Got it.
Because
Okay.
things are falling. They're not actually
Why are they falling,
floating.
So there's another factor,
Why are they
Brandon.
falling, Brandon?
They're not floating. They're falling.
Why are they?
So there's another
Why are they
They're
falling?
all
Brandon?
in disequilibrium
They're
together.
falling because you took it up in an
By
airplane.
admitting
Junior.
that they're falling, Brandon, you're admitting that
What
there's
is
an
an
external
antecedent
I'm
to
not.
something falling?
You can't get
There's
around
What is a
no
necessary
external
antecedent
force
to something
required.
They
falling?
were
picked it up.
why did the behavior of the objects
necessary
change once they started this maneuver?
Because they're
What changed with the
falling.
relative density?
You
What?
picked
No,
it
they're
up.
still going up actually,
You're
but
right,
that's another
because they're
issue.
No,
falling,
they're not.
Brandon.
Or
And
something
Yes, they are. They're
You're
going
right,
up.
Brandon.
Did you see the look at this video that I'm posting here with the this tower? The tower goes up and down and is weightless the entire time. Why is that?
Look at the hair too. The ISS hair versus.
Look at how much of a NASA fanboy you are.
Look,
Yeah,
man,
Brandon,
it's not
you know,
gravity.
I
We
mean,
could
just
spin the
simply
tower in a
because
circle
you
and get
don't
the same
understand the
effect.
relationship between
Brian,
falling and forces.
It's not gravity.
You still
Mike, out of your mouth.
You still are claiming that it's falling, so therefore you're acknowledging that it's changing the force acting on it.
No, all
Thank
I'm
you.
acknowledging is that
Maybe you guys
it's
should get together with
falling
QE
because it's out of equilibrium with the
What does
medium
that
that it
mean?
is in.
What
It
Yeah,
does that
but you
mean?
see,
means
out of equilibrium.
what does
is
it
a
mean? It
place
means
over
the
the
medium
floor.
that it
are
is
not in
that it's in.
But the
It's
medium
more
didn't
dense
change.
than
Maybe
the
Suddenly they
medium.
just start going over the
It's
parabola.
very simple.
Everything was fine and acting according to gravity, but everything was fine and
NASA,
acting
you gotta
according
let
to
him
Yes.
relative
answer.
No,
density
everything wasn't
disequilibrium.
fine.
And then
It
suddenly
was
they go
still
over
it
the
was in
parabola.
disequilibrium on the way up,
What
and then
is
it
in
started
disequilibrium?
falling,
Why is there
and it's
weight
in
then?
disequilibrium with everything
What is
because
in
everything's
disequilibrium?
falling.
Why are they? Why is it still? Why are you still attracted
You
to
see,
the ground then?
Brandon, that's
You're
your
in a
basic
plane. You put a
Because
plane
that's
in the
where you
sky,
started,
and then
dipshit.
Something
let the
falls,
plane
it's
fall.
in free fall, you change the force on it. Until you understand that, you'll never understand any of this,
Oh,
Brandon.
I understand your model just fine. You don't understand what I'm
No, you
saying,
don't.
Bob. Until you
We
understand
do.
what I'm saying, then you won't be able to have a conversation about
We're
it because you
understanding
keep
you're
saying the same
ignoring
If you
stupid
say
thing.
it's falling,
That's a
Nothing
nice
changed
dodge,
with the-
questioning our model.
Nothing. No relative density changed. No relative density change is what you're saying, but suddenly everything starts falling.
Because it's
And you can't explain
falling.
it.
Yeah, because you
Why?
just started
dropped
free
the plane
falling,
and it's
dumbass.
falling.
But the relative
How does
density
falling
hasn't
affect the
change?
What effect
Brandon?
does having
How
it
does
fall
falling
have
affect
on
the
it,
relative
Brandon?
density in the density tower? Please tell me.
Because now
Brandon, what
everything
is
is
the
out of
effect of it
equilibrium
falling?
and it's all
Oh,
falling
what?
to get
Why?
to its position of equilibrium
But you
or
claim it's
support.
only
Why is
relative
it falling?
density
You're
that
claiming
matters.
it's all relative density, but it
Because
was
you put it up in the
What's the other factor,
sky and
Brandon?
dropped it.
Well, no, we haven't dropped it. It's still going up for the first half.
When it is in free floating, then you're falling, right?
No, actually,
No,
he is
no.
correct.
Build a
Still
plane
going
out
up
of
the
water
first half.
and
Yeah,
Brandon,
The
build
same,
a
it's the
plane
same
with
with
a
the
make
tower.
a
I keep
submarine.
forcing you guys. Well, the tower. You misunderstood what the tower, what the article said.
No, I don't
Brandon,
think
they're
so.
essentially
did.
shaking. Brandon, they're essentially shaking this tower.
It
But
doesn't
if
have
you shake
anything
the
to
tower,
do
Moving
with
the plane
shaking.
up
if you
and then
shake
moving the plane down. If
Right.
I move
Shake the
something
top-
up and down, am I shaking it?
If you shake the tower,
If
you
I
shake
move
the,
something up and down, am I shaking it?
hello. If you
No,
if you
Yes,
shake
hello.
down.
If I'm
if you
asking
shake that
you a
if you
direct
shake that
question,
shaking it.
if you
that's the
shake that
show. I'm
tower,
asking you a direct
if you
question.
shake, hold on a second, I'm asking you too. If you shake the
No,
tower,
I
while
already
it's still,
asked you. Answer mine.
It's
what's
not
the-
being shaken. It's not going up and
If I
down.
move something up and down, am I shaking it?
Yes,
Okay,
you are, but that's not what
let-
happens in the plane.
Let's
It's not
put. Hey,
going
let's
up and
take
down.
men out of this
But if you
equation.
shake it while it's
Okay,
still
and let's
under
put the
before the
density
maneuver,
tower on the
it
floor.
reorients
Hold on,
itself.
hold
Why
on.
not?
Over, you lost.
Why does
Let's put
it
let's
behave
put the density
differently?
tower on the floor of the
Why does it
airplane.
behave
Let's put
differently
instead
before you
of
start
holding
the
somebody's
problem? I'm
hand.
gonna turn you down.
Let's
You're just
let me
you're
answer.
talking way
Okay,
over
okay.
everything.
So let me explain.
I just turned
Let me
them off.
explain.
But you know,
Okay,
I mean,
so
the
let's take
problem
that
is
density
they have
tower.
they have
Let's
no understanding of any of the forces acting on it.
Yeah, I know,
Because
they just-
as
The
the
problem
plane
is
is
let's take
going
the
these
up,
guys
density
can't
tower
understand
and
that
put it
things
on the
are
floor
falling,
of the
and
airplane.
that,
They're not
you know,
falling.
Okay.
No,
once
they're
they're
still going up.
falling,
Did you watch?
there
Did you
is
watch
no
the video
All
after
right,
this?
equalization
Brandon.
between the objects. Yeah.
Why are
Brandon,
they
I will
falling?
be happy
What
to
about gibberish,
explain it
Brandon?
if you will just not talk over me constantly.
Oh, just
As
put the
the
density
aircraft
tower
is
on the
going up,
floor
do
of
you
the
agree
plane.
that there's weight
Okay,
and
so
the
while the
density tower
is sitting on
separates
the
out
floor
as
of
it's
the
going up?
plane, it's going to be okay.
As it's going
As
up,
soon
do
as
you
you
agree
take the
that
floor
that's
out from
still
under it, it's going to
separated
be
out from the
That's
density
fine.
density
tower.
Let
tower?
Bob make his point.
Brian's
You've said
talking.
that, Brian. We understand. Go ahead, Bob.
All right, so as the plane's going up, the density tower will still separate out. As it gets towards the top of it and starts to nose over,
Yeah.
the momentum will continue to carry things up. But as the plane is nosing over and not climbing at the same rate anymore, you will be weightless. On the way up, you will still be gaining altitude. Then
Okay.
as you come down, you're coming down in the downslope of the parabola. You have no external force acting on any of the density tower or the things in the plane. Therefore, they all float and the density tower does not separate out until it gets to the bottom, and then it starts coming up again. Now you have a downward force acting on it, and the density tower will separate out, and people will fall back into their seats. It's as simple as that.
That's what happens. Nice story. And yeah,
by
yeah,
saying,
that's a nice story.
that it is
I don't know
falling,
why you
you
threw
are
all that stuff in
acknowledging
about
that there's an
forces
external
and all that
force
other
acting
extra
on it.
That's how it
gravity
works.
shit.
So, but you say it works by relative density, but you cannot explain how the relative density changes when the airplane does this maneuver.
I think
Exactly.
I explained it
See,
like
the
15
airplane is
times.
shooting
No, you
up
haven't.
with the density
I don't
tower
think you're going to
on
be
the
able
ground.
to
The
get
relative
anytime
density
soon.
hasn't changed, but yet you say they're falling, and you can't explain why they're falling if the relative density hasn't changed.
007
tower
wants us
on the ground.
shaken,
I mean,
not
put it
stirred.
Yeah, but you see, until you
why?
They're in the
understand
sky.
how the
You know why?
forces
Shake,
work,
shake it.
Brandon, you'll
They
never
stop showing
Shake it
up.
on the ground, it reorients itself.
Or
Why
the-
doesn't it reorient itself?
Okay,
Brandon,
then put it
until
on the
you
ground.
understand how
I
these
mean, put it on the
forces
floor.
act
Put it on the
and
bottom of the
how they
airplane.
act
Just let
on
it sit there.
liquids
Don't
and
hold
liquids,
it.
you're never going to
Let it sit
understand
at the
any
bottom
of
of the
I
this.
already
airplane.
understand it, Bob. A nice try though. I
It's,
get it.
it's quite
I
apparent
understand
that
your
you do not.
explanation. It's just full of heliocentric gibberish.
No, it's
No,
quite
it's
apparent
not.
you don't
Yeah,
understand
you
it.
anti-science.
No,
You're
I
just
get
a
it.
science
I'm
guy,
not.
Brandon.
Oh, now I'm a
It-
science denier. Now we're there.
Just a
Yes.
science denier.
Excuse
8
me,
o'clock,
excuse
right
me.
on
Yes,
time.
you have
What
been
up?
for
You
some
don't
time.
Changes.
understand science.
What changes
You,
with
you don't
what the-
understand science. You understand
Oh, I
stories.
do.
You
You don't
understand
The
science
relative
understand
fiction.
density.
acceleration of
You-
velocity.
Hey,
You don't
excuse me,
understand
Brandon.
there's going to be a
Is
force
it relative
present.
In
density or
Rumpus's
not?
defense, he understands pseudoscience excellent.
Yeah.
He has a
All right, so Brandon, you
master's
still haven't
grasp
is it
on
explained
relative density,
pseudoscience.
please?
specifically.
Is it relative density,
So, do
Brian?
you need an independent variable to do science? Yes
So,
or
All
no?
you got to
Brandon,
do is
The
put the density
absolute,
tower
what
on
is
the
the cause of
put
what
it
you
on your
see in the
tray in
bombing
an
comment,
airplane.
Brandon?
Okay,
You
as soon as you
explain
take the
what you
bottom
think
out
the
from
cause
underneath it,
is, and
and
we'll
it's
tell
then
you
it's going to start
what's going on
reacting.
with it. But you explain
Brandon,
it.
if you're in
What
relative
causes
density and the effect is the density
I've
tower,
already explained
and
it
that
like 10
doesn't
times.
change,
Do
therefore
it
you
again.
Keep saying it's
you're
falling.
ignoring
You
another
want to tell us
factor.
why it's falling. Why is it falling if the relative density hasn't changed?
Exactly.
What does falling have
What
to do
the
with
hell are you
relative
talking
density
about?
or
The
anything
whole
else?
plane is
What
going
does
down. The
falling
whole
have
plane
to
is
do with
falling.
Relative density
In
hasn't
free fall.
changed.
Yes, it has.
You put a
No.
plane up in the
He knows what
sky
I'm
and then you
saying.
let it fall. That's why it's fucking falling.
But
No,
the
actually, it's
relative
still going
density
up for the
change
first
has a
half, but
Brandon.
we
Yes,
telling
it
you it's
does.
going up.
No, I get
going
that,
up for
but
the
there's a
first half.
speed
Well,
First off,
differential,
you're
so it's
both
essentially
saying
falling.
you're
I got
and
you.
you're being obtuse. So,
Now,
oh
let's
my
just-
God.
I'm
Hold on,
not
they
being
just
obtuse,
accused us
Bob.
of
You're
being science
being
deniers.
manipulative.
Let's ask them a question.
Guys, we
Let's
wasted
ask them
half
a
the
question.
show
Do you
on
need
this.
an independent variable to do
I'm
science?
not going to talk about independent variables. This is about relative density.
Responses back.
We have an
What is
independent.
our
you guys
response?
accuse
Did
us
you
of
say
being
it's wrong?
science
What
deniers.
is my
I'm not accusing you of anything. I'm accusing you guys. I'm asking how the relative
Can
density
I
changes.
ask Dr. Bob something?
Maybe.
Go ahead, Paige.
Try though.
Maybe.
So who's the science denier? You guys denied the independent variable
Oh,
all the
so
time.
no,
That's
I
why you
can't.
guys don't want to
What's
talk
the
about it.
independent variable then for falling?
Okay, obviously I can't.
Hold
The
on, sorry,
density
sorry.
of the medium. The density of the medium.
Shut up. Hank just made us. So, Hank,
density of
in
the
the
medium.
case when the tower, the density
density
tower
of the
stops being separated, what's the independent variable that makes
density
it
of the medium.
separated normally and then changes when the aeroplane starts to go into free fall? What's changed about the independent variable that's causing the dependent variable, which is the separation of the
Because you picked it
liquid?
up to drop it. You picked it up and dropped
You
it on
took
the
the bottom
airplane.
out from under it, Rumpus.
Yeah.
So, is more going on than relative density then, isn't there?
Yeah, you're in a fucking plane going up and down. Yeah, there's more
So there's
going
more
on.
going on than relative density then, isn't there? Because if you
We've
claim
never denied that there's a
relative
plane
density only
involved.
You took the bottom out from under it.
Well, there's nothing shaking going. If you look at the video, there's no shaking
Scenario you
going
put
on.
us in, yeah, there's
It just
brought it up,
smoothly
and then
goes
you
from
dropped
big
it.
going upwards to going in
That's how
free
you
fall.
shake a
There's no
milkshake.
shaking
You
going on.
bring it up and you bring it down. You bring it up and you bring it down. That's how milkshakes are made.
Yeah,
You're
you're
shaking
being
it.
pedantic about
No
that,
shaking
Rumpus.
going on. Don't know where you're getting that from.
Hank, don't forget my
Okay,
milkshake
how do you
brings
make
all the boys
a
to the
milkshake?
yard.
Does anybody know?
But that's
Yes.
not what's going
I know,
on in
I
the
know.
comic comics.
You have to shake it.
You're making
because the
there's no
heavy
shaking
cream
going on,
won't
Hank.
mix.
There's no shaking
The
going on
heavy
in the
cream
vomit
won't
comic. You're
mix.
making
There's a
that
whole
up.
lot of shaking going on.
There's no shaking going on at all.
I lift something up drastically.
So are you
guess
saying
what?
that there's not
It's
an
not
up
being
and
lifted
down
up
effect of
drastically,
the
Jeremy,
vomit comet
and you can
the
see by the
parabolic
motion of the people.
maneuver?
The motion of the people is very smooth in there. There's no shaking.
If that density tower is
There's
sitting
a
on
whole
the
lot of
ground,
shaking going on.
hold on. If that density
No
tower is
shaking
sitting
at
on the
all.
floor of the airplane, and it's going to be fine until you take the floor out from under it and put it in disequilibrium.
No such thing as disequilibrium.
Of course there is. You saying that's not a
No, there
word?
isn't.
You never heard that word before?
It's not relevant. There's nothing in physics
Everyone
that
knows
just
that
talks
word.
about
You
that.
learned that word in like 5th or 6th grade. Did you not go to 5th or 6th
Hey,
grade?
No. What did you use it for in your 5th or 6th grade?
Disequilibrium?
Yeah.
Hormones.
The relative density experiment we all do in 5th or 6th
Right, so
grade. that
biology.
proves-
Okay,
no
great.
idea.
There we
Hey,
go.
hey, was
that
someone,
proves relative
Professor
density.
Professor Phil is a lot smarter than any of us combined. But he asked
Whoa,
why.
now you're saying
what does-
crazy shit.
What does free fall mean in
about to
terms of
mute?
relative density? By the way, so you
I
say
should
admit
mute
there's
you
free
for
fall.
that.
What does that change in terms? What does that mean in terms of relative density?
I don't want paid NASA shield speaking for me. Professor Phil, I don't know who he is, but
Yeah,
I think he's
that's
more than
freaky, dude.
I'll take that,
Disequilibrium is a
you
loss
need to
in
take that back,
stability.
paid NASA
Hello,
shield.
someone explain to me what free fall is in terms of relative density.
It's not
Okay,
free
It's
fall.
a loss
First, you take something
in
out of
stability.
equilibrium. You put force to it and get it out of equilibrium. Okay, to get any
So what force
item,
is-
any matter
what
out of
force is,
equilibrium, it takes a force.
What
Will you
forces
comprehend
are
that?
what forces
Will
are you
you
talking
comprehend
about
that
that are not
first?
in
Wait,
equilibrium?
well, one step at a time, Rumpus. Will
Yeah, but
you
what force are
admit?
you talking about?
Will you at least agree that to get something out of equilibrium, where it naturally
But you have
sits
to be
in
talking
nature,
about something,
any
a
matter.
property. But no, Brian, you can't just say disequilibrium. You have to talk about what is in disequilibrium, as you're
Any
calling
matter.
it.
Any matter.
What is
The
it's a
objects
force.
inside
What do
the
you mean?
plane.
Matter just doesn't have a there's
rock.
going to be a force, a property that you're talking about that is not, as you put it, in equilibrium. That's usually in these
You don't
discussions
want to discuss
about a
any
force.
matter, do you? You don't want to discuss matter?
I'm happy to talk about matter, but you've got to
Okay.
say what is
Now,
it that's
any matter as it lays on Earth, okay,
so
as
it's a
it lays without a force, okay, as it lays, just everything where it is, okay. That's what we call equilibrium, okay. Now,
Well, this
wouldn't it
equilibrium
take
what?
some kind of wait? Let me ask my question. Wouldn't it take some kind of force to get any matter moving out of its equilibrium, to raise something
Well, no
up,
such thing as equilibrium.
to take
Yes,
something
indeed.
underwater?
Fundamental
Wouldn't it take a
second
force,
law of
Rumpus?
Newton's second law for specifically states that for something to change its either stationary position or its velocity, there has to be a force.
Thank
So
you.
that's
so
why
when you walk outside your door to perform whatever experiment, you're going to have to put something in a plane and use force to get it up there.
Absolutely.
Okay? Or to get a beach ball underwater, you're going to have to use force to get it out of
Absolutely.
equilibrium.
A
That's
force.
what we mean by equilibrium. Is back to its original
Yeah, but
Equilibrium is
place.
a force.
Okay.
So how
Now
does
here's how you could do that. You could use heat or cold. You could use temperature. You could use pressure.
That's not a force.
You could use physical force. Any of them forces, but it will take a force to get something out of equilibrium. and then it will be in disequilibrium, and then it will
If you're
back
talking about
to its
temperature,
equilibrium. Can you tell me one thing in nature that won't do that?
One valid thing to talk about equilibrium is in terms of pressure or heat. Well, heat's actually wrong, but you could talk about two parts of a container not being in equilibrium in the sense of heat or pressure. But when we're talking about forces, which is
harmony,
Hold up.
It all works
In
in
that
harmony, bud.
example of entropy, what's causing it? What force is causing it to, like, from high
We're
pressure?
not talking about entropy. We're talking about things floating.
And what happens if you
that
open
movement? There
the
is
barrier
movement of
between
matter,
those two containers?
Right? What's causing?
Yeah, but that's
what's
not
the force
that's
that's
not
causing
caused
that
by
movement?
entropy. The thing that causes, for instance, a gas to expand is the kinetic energy of the molecules all going in different directions. So there's no force there. They've just got their kinetic energy, and they're going to just occupy the space simply because the velocity is going to, some gas molecule is going to be pointing to the right, and another one up, another one down, etc. And so they're going to just carry on until they hit something and then bounce back again. But there's no force being exerted there. It's just their kinetic energy. Their movement will cause them to occupy space. There's no need to be a force there. Just if I threw a load
So
of
they already
bouncy
have
balls,
the force, and the avenues
there's no
just
force.
opened
There's
up
no
to
force.
them.
No. Do you understand the difference between kinetic energy and force?
You're saying kinetic energy doesn't have a force?
Correct.
Why?
Because if you knew anything about science, you'd realize it was a really stupid question.
Yeah, if it's moving, yeah, that's what I was referring to, Rumpus.
Do you understand
Rumpus,
Newton's second
that's
law?
what I
which
meant by.
Hold on. Let me just answer, Brian. Newton's second law states that to change the velocity of something, you need to apply a force. If you don't apply a force, the velocity will remain constant. And that's what happens when a gas molecule or brick or whatever it is that's moving along, it will carry on in a straight line at the same velocity unless there's a force acting on it.
Okay, so you're
We know
saying
that.
it's
You
moving
obfuscated my
without a
question, though,
force.
man. They're helping you obfuscate my question. Wouldn't you have to put potential energy
Rumpus, you're
in
saying
any
it's
matter
moving
to
without
get it
a
out of
force.
equilibrium?
Well, hold on, Brian. Let me just finish with percent. I'll get back to you. Just hang on to your question, Brian. Don't forget it. I'll answer it. Let's let percent.
You
finish
never
his point.
answered it
You're
yet.
saying these gas
I'm
molecules
sorry, Brian, if I
are
haven't. I'll get
moving
back to you.
without a force, correct?
Say again. Sorry, percent. I missed that.
Jesus Christ. These gas molecules are moving without a force, correct?
Correct. Once they start moving, they do have the first force of gravity exerted on them, or if they collide with anything, obviously there's a force exerted. But if you just had one molecule, say, that wasn't hitting other molecules or anything else like a container, then it would carry on, and it's obviously being subject to the force of gravity. So imagine it was in space.
Yeah, save
Hold
yourself,
on,
Okay. Well, hold on. We're talking about the whole system here, man.
Let's take it one step at a time, Rumpus.
So there's
So
no
these
force
molecules,
involved.
One
hold
second.
On. A constant velocity has no force associated with it. Go ahead.
All right.
So
let's say
can you get a
have
density
these two
tower up in an
containers.
airplane without force?
Hold up, bro.
Can you get a
No, you
Bro,
can't.
come on.
No,
Hold on, you hijack my conversation,
No,
bro.
this is a
He
good
won't.
kind of
He won't
like
answer the question, man.
line
He
of
won't even
thought.
answer, bro.
Let's
I
continue.
will answer, Brian.
So basically, let's say you have this chamber, right, and has a wall in between, and there's
In
gas
between.
molecules on one side, right? They're not able to evacuate into the other half of this chamber because of this wall.
All right.
All right.
Yeah.
So these gas molecules, they're always moving, but they don't have a force, just like you said. But
Correct.
they're physically impeded from, equalizing. So now you move away that physical
by this
impedance.
barrier. By this
Yeah,
barrier.
that barrier. You move it
Right,
away,
okay. Yeah.
and they return to equilibrium, right?
Well, no, they don't return to equilibrium. There's no.
Well,
this
they
equilibrium thing-
achieve, their
Well, this
maximum value of equilibrium. Correct?
No, this equilibrium. There's no equilibrium here.
Dude,
they just simply
the
go.
point
and
is
they
they evacuate to the other half,
achieve
right?
the
Right.
equilibrium that they can.
There's no,
yes.
there's no,
Hold
no,
up.
there's no
So
equilibrium.
they
here.
evacuate to the other half,
Yeah.
and no force has been applied, right?
Correct.
Okay, so how is that different from objects that are returning to their equilibrium? They're moving.
No such
They're
thing.
always moving. They have, this energy. No
Kinetic
force is
energy.
applied, and they return to the equilibrium.
And there's no such thing. I don't know what you mean by return to equilibrium.
Well, they attempt, this entropy or what have you. The physical impedance is taken away, like an apple falling. It's
So, hold on,
initially physically impeded, then the stem gets
about
weak,
gas
and it
molecules in the
falls.
barrier. And we're now talking about apples. Have we changed the scenario?
I'm
suddenly?
showing you how it's exactly the same situation.
Analogies.
You can't say
Sometimes
that you
using
have
an
movement
analogy.
without force for gas molecules, but you can't have it for other things of matter.
You can't have what without. Sorry, can you make your point again? Without
Okay, so
other
the
things?
gas molecules were physically impeded in this chamber, right?
Right.
And when we
They
lifted
hit
the
they hit
barrier,
the chamber,
they were
right,
able
then
to move.
Then they right. Okay, so they're not having a force exerted upon them. They're moving, and then they hit the wall, the barrier.
Yeah, they're
okay.
abiding by entropy, second law. right?
Well, no, well they're not. No, that's not. They're just following their
is
velocity.
exactly that.
No,
Second
you
law of
don't understand
thermodynamics.
entropy.
Rumpus doesn't believe in the
value.
second law.
Use as few words as
Anyways, the
possible.
point
Just
is-
make
No,
it as
Jeremy,
simple so he
I
can't argue
understand
about
the
the
difference
words.
between entropy and the second law of thermodynamics, and stupid moron QE doesn't. I've had to explain this to him about
See,
10,
now he's
20
gone.
times,
Got a hard on
and he
for
doesn't
QE
know
too.
the
You
difference
triggered him,
between.
Rumpus.
Go ahead.
You triggered him,
Sam.
percent.
Okay, so they're abiding by entropy. You lift the barrier.
nothing about
The gas
abiding by
molecules
entropy.
go. The chamber equalizes in pressure, right, in both halves.
Entropy is not a. Entropy just simply tells you how disordered something is. The second law of
Right, leave the word
thermodynamics tells
entropy
you
out.
what will
Just-
happen.
It equalizes
denying
as
that
best
entropy
it can in the
is-
double-sized container.
Are you denying
Entropy
that
is a
entropy
state
is like at work
variable.
there?
Entropy is a. This is the thing that QE doesn't understand. Entropy is just a state variable of a system. It doesn't tell you what's going to happen, what did happen, or what should happen. Entropy just simply tells you the state of a variable.
Dude, y'all are doing
at a
him a
particular
favor
time.
by narrowing it down to gases, dude. We're talking about.
Well, look, I'm
the
happy to
entire
talk about apples. If you want to talk about apples now, I'm happy
Let
to
me
talk about
ask you
apples.
another
Yeah,
question.
Hold on,
Okay.
Brian.
Can you get a
Sorry,
density
Brian.
tower? Can you get a density tower up in the airplane without force? Without
No, you
some
can't.
kind of force?
No, you can't, Brian. I agree with you
Okay.
there. Okay,
Okay, so you're putting potential energy
he's
into
trying
it
to talk
then,
about Apple.
correct?
Hold on, Brian. I just got to finish this Apple thing he's trying to get out of me.
All right. So in terms of this, any system, thermodynamic system, or what have you, the entropy is the amount of energy not available for work, right?
Correct.
Okay. So when there's no variables that are containing it, entropy is going to be what?
No variables contained. I understand what you meant by that.
Yeah. So when there's nothing acting on it, so as to prevent, the molecules from seeking their equilibrium, right? From
I don't understand what that means. Equilibrium. I don't understand what that means.
Okay. So in any
No
system,
variables
in any
containing
system,
it,
hold up.
Rumpus. My goodness.
Right, that's different. When we see variables contained, you mean a barrier. You're talking about a physical barrier containing.
Listen,
That's
just
what he
one
said
step at a
in the
time. Hold
first
up,
place.
Kate.
No,
And
he's
you
not referring
said
to
that
variables.
you're not making
and
any
then a
sense.
barrier, and he's not consistent. If you mean a barrier,
okay,
don't talk
listen.
about a barrier. Don't talk about it as a variable.
Rumpus. Second law of thermodynamics, right?
Yes.
Any system, they're attempting to achieve their maximum state of thermal equilibrium, right? They're trying
No,
to
that's not what the
reduce
second law
all
says.
inhomogenities.
No, that's
right?
not what the second law says. You can have
Really?
it's. Yes, the second law simply says that the end. This is the thing that QE doesn't understand, of course. The second law of entropy says for any isolated system, the entropy will either remain the same or go up.
Why do you keep
That's
bringing up
what it
QE?
means.
He's not even here. I don't.
He's on
Well,
his
some more.
nuts, man.
Well, he's got the same problem as QE, I suppose.
Because all of you
he's
copy
just
his
parroting-
arguments.
remain the same.
He's parroting QE.
why-
and he's
why
Here's
do you have them
equilibrium
remain the
mentioned in
same?
the first
We don't
paragraph
care,
about the
Rumpus.
second law of
We don't even
thermodynamics.
listen to
What's up
QE.
with that? The second law may be formulated by the observation that the entropy of isolated systems left to spontaneous evolution cannot decrease as they always arrive
Which
at a
is
state of
exactly what I said.
thermodynamic equilibrium.
Which is exactly what I said.
That's what I said, bro.
I said that the entropy does not go down; it can only go up or remain the same. Which is exactly
it
what that sentence
increases
is saying.
as these constraints, these variables that limit it, are moved.
What variables? What variables are you talking about?
And how come they're using the word
You
equilibrium,
keep on talking about
Rumpus? You
variables, not
acted
telling
like
me
that
what they
word
are.
isn't.
Okay, so for
Jesus
instance,
Christ.
let's say,
Hold on, let me do one
I'll
more
give
thing.
you an example
Also,
of a variable
Archimedes
that
also
would.
used the word equilibrium. So what are you not? I don't know why you're acting like you're not familiar with this word. Okay,
Well, this
go
is
ahead. Percentage. Here's
well, you're
equilibrium,
misusing it.
discussing Archimedes' principle. Here it is,
really not,
discussing
but
second law of
let's say
So now
thermodynamics.
the
That's
word
fucking
does
weird, huh?
exist
Go
and
ahead.
was
Not
used.
using it
We're
in-
just misusing
Yes,
it.
something has to be
Right?
in.
So
You have to
just
be talking about something
change
specific.
your argument.
You have to be talking about
Far
something
out.
like thermodynamic equilibrium, a force equilibrium, or
No, we're applying it to the whole system,
or
Rumpus.
a bouncy.
Rumpus, we say
can't-
that heat, temperature,
I'm pretty
pressure.
sure I was clear in mentioning
hold on.
second law of thermodynamics, thermodynamic equilibrium. I said it multiple
You did
times.
mention
So,
that, and I
you
didn't
can't be
dispute
confused
thermodynamic
about
equilibrium.
that.
I was
You're just
prepared to accept
grasping at
I was prepared
straws.
to accept thermodynamic equilibrium, but you
He's
keep on talking about
triggered.
this variable, and you haven't mentioned what these variables are. You keep on talking about.
Okay, so an example of a constraint that could limit entropy would be, if it were true, mass attracting mass, for instance. Okay? But that's neither here nor there. The point is, in any of these systems, they're going to try to reduce inhomogeneities. You with me? They're going to try to attain a maximum value of equilibrium.
Well, usually the equilibrium you're referring to is either thermodynamic or position.
That's fine. I've already specified thermodynamic for this.
Okay, we'll go with thermodynamic, which is the heat. In other words, the amount of heat, that is a valid use of the word equilibrium.
Thermo and dynamic.
Right, so you can. So in other words, a gas will reach a thermodynamic equilibrium if left into one container. That is a valid use of the word equilibrium.
Fantastic. Now that you're, we're on the same page. So again, you move this physical impedance, right? And the gas, obeying the second law of thermodynamics, will equalize, right? The matter will equalize in that
What do you
chamber.
mean by equalize in what regard?
It will, attain its maximum value of thermodynamic equilibrium. Come on, man.
What thermodynamic?
We're talking about gas, so of course,
right. So you move the
equilibrium
barrier,
is going to be equalized.
but then you're assuming that's changing the temperature. Is that what you're saying is happening by moving the barrier?
No,
or changing
I'm
the
not
temperature?
saying it's changing the temperature.
So what thermodynamic equilibrium are you talking about?
Listen, the second law of thermodynamics applies to systems of matter and radiation, temperature, pressure, chemical, a bunch of stuff. Okay?
No,
it doesn't only apply to temperature.
Position and energy.
Do you think it only applies to temperature?
Rumpus, it means the gas is bouncing around evenly with equilibrium inside the whole container now. It's not just grouped up in one.
Refers to energy and position. Those are the two things entropy talks about.
I think you're talking about maybe the classical wording of the second law of thermodynamics when it just says heat going from hot to cold.
Heat, I mentioned that. Yeah, heat's fine.
But again, the second law refers to much more than that. You need to brush up on second law of thermodynamics, buddy.
No.
Talk to him. Yeah.
Traditional, the basically old method wording.
Entropy refers to heat and position.
No,
and matter.
Happening.
Well, that's what do you mean by matter?
Yeah,
that's
right.
the position of it. What do you mean by matter?
Okay.
Yeah, but science is
Yeah.
settled for
I'm
these
talking about
guys.
matter. I'm talking about
Science is
matter
settled.
and pressure. We're talking about gas right now.
Well, that's to do with position.
Okay, that's fine. The point is the second law of thermodynamics applies to it.
No, it applies to position and energy.
Lord have mercy.
You just don't know
You
what
ain't
the term.
got
I mean,
purposely
you
trying to
misused these
obstruct
terms.
because
You didn't
you
even know
know-
what kinetic energy was. I mean, you do not know what you're talking about. But anyway,
No,
get on with this. So just
Rumpus,
get on with this
why are
point
you
you're trying to
scared?
make. No, I'm not. Well, it's
Scared.
frustrating.
You're scared
to
of
someone
following this conversation to its natural
No, I'm
conclusion.
happy to follow, but you
Doesn't
keep
he
on
sound
the
like
road to
Philip
mistake.
and
The
Terrence?
point is you agreed that these gas molecules will attempt to achieve their maximum value of equilibrium once the physical
Not
impedance is
equilibrium of
removed,
what?
right?
Thermodynamic equilibrium and positional equilibrium. That's what they do.
Yes, okay, fine. So it's going to
Right.
equalize. The gas is going to equalize, right?
In terms of position and energy, yes.
All right,
thermodynamically.
fantastic. So you move away the physical impedance, the gas is going to equalize, right?
Equalize.
Now,
What,
how is that
thermodynamically in
different?
position?
How's that
It's
different?
position of the gas. Holy shit, man! Are
Right,
you
so
fucking?
stop using the word equilibrium. It doesn't make much sense if you define
It does.
what sort
If
of
you,
equilibrium.
again, read up on the second law of
I
thermodynamics,
know
which
don't have to
governs
define
matter
it every single time.
and pressure,
Rumpus.
you will see that
Yeah,
they
it's more
use
than
the
just heat,
terminology thermodynamic equilibrium.
Yes, that's fine.
Fantastic. So how is that different from an apple, which is physically impeded by its stem, and then once that weakens, falls?
The elastic
right?
collisions.
How is that different from these gas molecules, which are physically impeded and then move without a force? How can you say that the apple requires
It's
a
not.
force
Well-
when the gas didn't?
Well, there's a force being exerted on the apple,
Is
and there
there?
are no. Yes, gravitational force. That's why it falls.
Why would there need to be? There wasn't
Ooh.
need for one before.
So
There
is there
is. There's a
gravitational
there's a
force on the gas
The
that's
apple
moving them?
doesn't move because there's a net force of zero. And the gravity
Oh,
pulls on it
God.
down, and the stem pulls it up. Those two things are equal. Therefore, the net
You
force
can't
is
teach an
zero.
old dog new tricks.
Hold up. So you said
Yeah.
that the gas was moving without a force,
I
right?
did say gravity was acting on it, if
Oh,
you
so-
remember, several
So the
times.
gas is moving without a force except for gravity. That's the only force acting on it.
Unless it hits
Which is
something,
weird because
yes.
the gas goes up. So
It goes in all directions.
yeah. Also, up is one of them.
Why? It's a
That's
gas
one of them.
because
Yes, it bounces.
it has
just like
energy,
a
though,
bouncy
right?
ball. When a bouncy ball hits the ground, it then bounces up again. Yep, exactly like that.
Okay, so here's my question then, Rumpus. You're saying that these gas molecules are moving without a force
Except for gravity, unless they hit
gravity,
something. There are
which is the
so there are
only
two
force
things
that's applying to them.
hold on, let me just make clear. There are two forces that can act on the molecule: hitting another molecule, or a barrier. Hitting another gas molecule, or will contain a barrier, and gravity. Those are the two things. There are other tiny forces, but those are the two main forces acting on a gas molecule. When it hits another molecule, whether that's the container or another gas molecule, and gravity. Those are the two main forces acting on gas molecules.
Okay, well, I'm just gonna, forgetting the fact that gravity is much weaker than electromagnetism, and you'd think that would be acting on it more. That's fine. We'll leave it. How can you discern between the movement not caused by a force and the movement caused by gravity?
Well, the gas is already moving. If you want a station, if you're talking about a station, imagine I had a station.
No, I'm talking about the gas. You're saying it's moving without a force and also moving because of the force of gravity. How do you discern between the two? Where's the line of demarcation?
Why do I have to discern between the two?
Well, we have to be able to qualify it, right?
Hold on.
Prove your cause.
Right, hold on. Newton's first law states that if the thing has just got a velocity and its velocity is not changing, there's no force acting on it. But on a gas molecule, let's just imagine there's only one, and it's not colliding with a container, it's not colliding with another molecule. There is no other force, except very tiny forces, acting on it except gravity. So what's the problem? And just like the apple, that has gravity acting on it.
How have you quantified what movement is gravity force?
Gravity isn't a movement,
and what
it's a
movement
force.
is non-forced?
Because Newton's first law states that velocity, if something's going on at a constant velocity, there's no force acting on it. To change its velocity, there has to be a force acting on it. If there's no change of velocity, there's no force acting. But of course, there is a gas molecule will change in direction because it's being pulled down by gravity.
Okay, so you have measured a change in velocity downwards to quantify gravity?
Yes, that's its weight. So you can measure the gas's weight, and that's the force of gravity acting on it.
Spring. Correct.
Exactly, like little springs acting on it. Yeah.
Okay.
I mean, I say that because you understand the concept of an abstract
No.
force. So I add the thing spring to give you something mechanical to fix to fixate on.
Help fuse it together.
I understand. Yeah. Okay, so how are you qualified to claim that this downwards velocity is gravity as opposed to just movement
Hold on.
without
It's
a
not
force?
a downwards velocity. It's a downwards acceleration. There's a difference.
How do you know that?
There's a difference between acceleration and velocity because I know there's a difference.
No, how do you know it's downward acceleration when it's these gas molecules?
Because they have weight. If they didn't have, if they weren't being accelerated downwards, they wouldn't have weight.
So Robert, we have to force it up, and then
in constant motion.
So we have to force it up in the air, and then it forces back down. That's what you're saying, right?
Yeah, that's right. Gas molecules, they go up and then they're accelerated downwards. They bounce like bouncy balls. Yeah, and the act of bouncing
what we're saying is that here's what we're claiming, and you can not like it or not, but this is what we're claiming: is that you have to use your force to get something up in the air to begin with, and you're taking it out of equilibrium. And when you let go of it or something gets out of the way, it's going to go back to equilibrium.
Yeah, but Brian, there has to be a force acting on it to make it go down.
Disequilibrium is the force, Rumpus. It's always a force.
Disequilibrium does not mean anything.
Temperature disequilibrium is a force. Compression disequilibrium is a force.
For things to change their direction of movement, Brian, there has to be a force.
You're forcing it out of equilibrium, Rumpus.
There has to be a force to make something change direction.
I agree. You are forcing it. I repeat.
Force is acting on gas molecules.
Whatever force you use to get it out of equilibrium.
Please then have to describe the force as making them come down again. Otherwise, they just carry on.
Okay, so Rumpus,
Okay,
these gas molecules in air or in vacuum.
Hold on, dude. So if I heat something up,
Brian,
it's just going to continue heating up forever.
Quiet.
Or is it going to go back to equilibrium? If I add pressure to a system, is it just going to keep on pumping up, or is it going to go back to? Is it going to shoot for equilibrium?
Can you mute him, please, Brandon?
Hold on, Brian. I'll come back to you. Sorry, I know I'm keeping you, Brian. You've been trying to ask a question. Let me just deal with percent first.
But yeah, Brian, your mic. Maybe you could.
I'll come back to you, Brian. Honestly, I don't want to dodge any question.
Yeah.
Ed, you're nothing but a Karen, dude. Crybaby Karen.
Quiet boy.
Yeah, you're a little crybaby.
Quiet boy.
It's Friday night for crying.
In a vacuum chamber.
Yeah, for crying.
Finish his point, for God's sake.
In a vacuum chamber, these gas molecules you claim are going to be accelerating downwards and thus causing a measurable force downwards, right?
Correct.
Which you're saying is gravity.
Correct.
Now, let's put this vacuum chamber, let's say it's like a balloon in water. And we're going to be able to measure.
You've introduced buoyancy now. Okay, you want to introduce buoyancy now, do you?
So, the point is, at that point, hold on, let's look at the effect only. At that point, we're measuring an upwards acceleration with an upwards force.
Right.
Right.
Do you know why that is? Because
I know
all
what your
the other
explanation of it
Well, I'll
is,
give you an
but the point
explanation
is, you know,
right, that's
the
because
same
you've got
effect is
you've got
observed
denser things.
in. Hold up, let me finish. The same effect is observed in opposite manners, just depending on the medium that it's in.
Right. Do you
So I know
understand?
go
For
ahead.
instance, if I were to put a balloon underneath a load of mercury, then the mercury is being pulled down to the earth with a greater force than the balloon that's underneath it, and hence the mercury will pull down and displace the balloon. That's what buoyancy is. It's the displacement of something being pulled down with a greater force, and that causes the things being pulled down with a lesser force to be pushed up. So there are two things
Okay,
going
so
on
once
with
we get it to
buoyancy.
the bottom, then that shouldn't happen no more then, right? Once we get it all
will,
the way to the bottom?
But it is because there's a greater force. So if you imagine a ball, a balloon, sorry, and you imagine it putting it at the bottom of a pool of mercury. The mercury is being pulled down towards the center of the earth with more force than the balloon is. And so it displaces the balloon. And that's what caused the balloon to go upwards, because the mercury has more force going downwards. And that's the fundamental concept of buoyancy.
Yeah, it
Hey,
is.
what about
and
when it's all the way at the
buoyancy
bottom, Rumpus?
So why
adheres
did you ask
perfectly
me then?
to relative density. See, it seems like you
But there has to be a
completely
force involved.
agree.
Do you not understand? If there was no force pulling the mercury down, there would be no buoyancy effect, and the balloon would stay where it was.
No,
there
but
has to be a
unless
force pulling the mercury down.
unless there's this system of equilibrium, just like the second law of thermodynamics, that's governing these things to go achieve their
Density is
density
not a
equilibrium.
force, and it has no
So the
direction.
water is achieving its density
No, it's
equilibrium.
more of a description
The
of
air in the
such thing.
balloon
than a-
is
than an
going
explanation,
upwards,
dude.
and you have a measurable
Density is not a
amount
force,
that they're moving.
and it has no direction. It cannot be possibly the cause of this behavior.
I'm not saying it's the cause, but it's the
You'd be right
system
if
in
we
which
put
it's
that
acting, it's
balloon
governed.
under
The
there
cause
and
is
it would just
unknown.
move
You're
in
claiming
any
it's mass
direction.
tracking mass. We don't know that.
Which we know it is from
we agree
Cavendish.
on buoyancy. We agree
We
on
know it
downward
does that.
acceleration, upward
Correct.
acceleration, depending on what it is, right? But the point is, you're saying it's caused by mass tracking mass, which has never
Yes.
been proven. And
It has been proven all the time. It's
yeah,
proved
and
every day. in
one last
physics
thing,
lab.
Rumpus. Your proof for it being mass tracking mass is the gas molecules going downwards because it could only be caused by gravity. But again,
correct.
That's the
What else
effect.
could cause it?
Gravity
There has to be a
is
force
down.
to do that.
Well, there's
Hold on.
multiple
For
theories
gas
of gravity.
molecules to
In that
have
context,
weight,
Perpetual motion.
hold on,
Rumpus,
for
in that
gas
context,
molecules to have
gravity
weight,
is simply
there has to be
downward
a force
acceleration.
pulling them down.
No, there doesn't.
Yes, there
all right, I'm
does.
done.
Otherwise, they wouldn't go down. They wouldn't
No, there
to have
doesn't.
weight.
Okay, Rumpus, let me ask you a question. Okay,
Can
I
you
get
actually
him to
even
answer one
hear
of these
me?
questions? Rumpus, if I go
Yeah.
outside in the
I
middle
can
of
hear
the
you,
winter,
bro.
and if I go outside in the
Thank
middle of
God.
winter and I take a
I
torch
started
and I
to
had a
feel
spot of
crazy
heat,
for a minute.
man, hold on a second, dude.
Really?
I'm trying to quit yelling.
Yeah, that's
I'm
rich
not-
coming
I've been
from
trying
you,
to talk
buddy.
for a long time,
He has
dude.
been quite. Brian
And then
has
you
been
took
quite
my
well
turn,
behaved.
and then
Please
you took my
encourage him. His
second
better
turn, and now
behaviour.
you're taking my third turn.
Hold on.
Brian's
Listen, if I
Brian's
go
behaving
outside in the
himself quite
winter,
well.
Rumpus,
God,
and I
Or
got
he
a
can
torch,
just shut up for like 5
Rumpus,
minutes.
if I got a
We heard
torch,
him yelling for like
and
an
I
hour, so
hit that torch one
Brian,
time,
can you shut
and
up?
I add some heat.
Hold up, man. Brian's been trying to talk for the past like 3 minutes, and I kind of was dominating
He
it.
did
So
make the
go ahead,
original
Brian,
point.
and then right
Yeah,
after
thank
Graham.
you, man. Thank you.
Go
Okay,
ahead, Brian.
if I go outside and it's cold as shit outside, okay, and I take a torch and I add a spot of heat to outside, I just hit the torch one time. Is the heat just gonna keep on just heating up outside, and something's got to stop it? Does a force need to stop that heat from just expanding everywhere? And one more thing, okay? Wait, it's a 3-part question. I'm making it all quick. Now, if I go into
I could quickly have asked to answer
if I
the
go
first
into
one.
a pressure chamber, whatever, and I take a straw and I suck out a little bit of pressure and then block it or whatever. If I go outside and suck in some of the pressure from outside, is the pressure just going to keep on going down? Or I should have added going up with pressure.
I didn't understand your second point. Can I quickly answer your first one? Can I just quickly answer your first one? So, okay. Sorry to interrupt. Be really quick, Brian, so you can come with your third point, which you haven't made yet.
I already know the answer. It was a rhetorical question. My whole point is,
you asked me one question at the start, and you asked me about
well,
what happens if you do you understand that the heat from your torch. When you say a torch, you mean a flame sort of thing.
Yeah,
Right. The heat is directly related to the velocity of the gas molecules. So when the gas comes out of there's an exothermic reaction when you light it, and so the gas molecules get more energy when they come out of your torch. They're going faster. They're also less dense than the air around them, so they'll go up. If that's so, there's nothing infinite about
what
this.
What you'll have is a hot patch that'll go back to equilibrium. Okay, and my point is,
well, it'll be
when you're
cooled
gonna-
down by
when you're gonna take.
they'll hit other molecules and spread the energy, and that is
I'm
a
not.
second law of
I'm not
thermodynamics.
confining this to gas. That was just an example. Any kind of disequilibrium is
Any
kind of
object you heat
disequilibrium
will,
is a
will
force.
spread the heat around so that
My
other things
point
will get
is,
as warm,
Rumpus,
warm
can
up.
I
Yes.
Can I say my point, please?
Okay. I'm sorry.
My
Okay.
point in all this is that any temperature change is disequalizing and is a force. Okay, if you
It's not a
heat
force.
something up, you are adding a force.
No, it's not a force.
It's a false
If you're
equivalence.
adding pressure, you're adding force. If you're adding heat, you're
not adding
force.
pressure.
If you
Heat
get
is not
something,
force.
well, will you answer
Heat-
me this then?
All
Will
heat
you
is
answer me this?
just
Will
the
you
velocity.
shut the fuck up and let me
It's
finish,
just the
dude?
velocity of the
Damn.
gas molecules, Brian.
God, you're hard to talk to. Look,
But
if you
it-
get something
it's-
out of equilibrium,
That's rich
anything in
coming from
nature,
you,
can you get it
Brian.
out of equilibrium without
Seriously.
using force? Period.
Equilibrium of what?
Anything. Don't ask
Right,
me
if you're
what.
talking about-
Any fucking thing, Rumpus.
No, you've got to
Any
be
fucking
specific
thing.
about these things. If you're
Any
talking about
fucking thing.
temperature, you've got two things at
Anything.
different temperatures. Okay, we're talking about temperature. You've got two
No,
things at different
No,
temperatures.
any matter. Any
Oh
matter.
shit,
The
Brian, be
temperature is a
quiet.
force.
It
The
doesn't make
temperature
any
is
sense.
the fucking force, Rumpus.
It's not a force. Force is something that causes things to move. Temperature is just the velocity of the gas molecules or the molecules that are making up the solid
So
object.
how they're moving.
That's all
Rumpus.
temperature is. It's just the velocity of the gas or
Yeah,
the
how
substance,
fast
the
they're
molecules.
moving.
That's
So I can't
all
move something with
temperature is.
heat. Can I move something with heat, Rumpus?
Yes, you can.
Yes, you
Then
can.
it's a fucking force.
No, it's
Can
not.
I move
It can
something
exert-
with pressure, Rumpus?
No, here we go. Right, here we go. Right.
Can I move
If-
something with
hold
pressure?
on, Brunt. When, for instance, the heat, when you heat up something, it will exert a force on the container. But that's because the velocity, the temperature in the gas, means that it's got a certain velocity. When those gas molecules hit something, they do then exert a force.
Here's
They do
Brian's law.
exert a force. But that
Brian's law
has
is an object in rest will stay in rest unless acted on by force. That's Brian's law.
that is Newton's first law.
What a
That's
coincidence.
Brian's law. An
Wow.
object
Newton's
at rest.
first law says
An
that things
object-
remain
listen, Rumpus,
stationary
Rumpus,
unless an
this
force
is not
exerted upon
Newton's
them.
law,
But
this is
heat,
Brian's law.
temperature, heat is not a force.
An
But it-
object at
So,
rest
Rumpus,
will stay at
imagine
rest
trying
unless
to
acted on
explain
by
the
force. That's Brian's law. You're
That's
you heard it
Newton's
here
first
So
law.
if
That's
heat
Newton's
wasn't a
first law.
force, it wouldn't cause that to move, would it, Brian? Because then it would break the law. Something at rest won't move unless you put a force on it. So if you put heat to it, then heat is the force that's making it
Heat is
move.
not a force. Heat.
Well, no,
You
it has
just
to
said
be if
he-
that's
you
his
just said I
law.
could move something
If
with
that's,
heat.
Right, here we
if
go.
that's
That
his
doesn't mean to
law,
say
then if that's his law, if
the
that's
gas
you guys got to be able to understand
gas
separate
molecules
what he's
Disprove
trying
have
to
a
that
say.
law,
velocity.
Rumpus. Disprove
Right.
Brian's
Hey.
law. Disprove Brian's law.
just as we say that when something is moving in space.
Don't
Hold on,
obfuscate.
I'm
Disprove
agreeing with you,
Brian's law.
Brian. I'm agreeing with you. But if you imagine something moving in space in which there are no forces acting on it, it's moving, say,
I'm
a
not
million miles.
imagining shit.
Well,
We're in reality.
try
We're in
stretching your
reality,
brain.
buddy.
Yes, and this is reality.
yeah,
Imagine
we're
something
talking
moving.
about
Brian's
heat.
law.
No, so we
Imagine
don't want to
something
imagine.
moving at a
We
million
don't
miles an
wanna
hour
imagine.
in space,
Oh
a
my
straight
God.
line. There is
Just listen
no
to
force
him,
acting
damn
You
on
guys
it.
want to let
But if
Grim
it
get
was
in?
to
You guys want to
But
let
if
Grim
it was
get
to
in?
hit something, okay, I'll finish in I'll finish in 10 seconds. But if something that's moving along with a fixed velocity, there's no force acting on it. But when it hits something, it does have momentum, and then that change of momentum will cause a force. But there's no force acting on an object. Finished.
Can you break Brian's law, Rumpus? Brian's law is an object at rest will stay at rest unless acted on by force. That's Brian's
I'm
law.
agreeing with
You
you.
heard
I
it here
keep on
first.
telling you that's Newton's
2021.
first law,
Brandon's
Brian.
letter.
I keep on agreeing with you, and you keep on questioning whether I'm agreeing with you.
No, you put us out in space
Rumpus,
with
and
motion.
that
I'm
would
putting us
stay
here on
still.
Earth with things
Damn.
at
The
rest.
force has moved it, so it's saying
Somebody
it will stay
changed
at
my name
rest
to
unless
Rodney
you put a
Dangerfield.
force on it. You put heat on
Exactly.
it, that's a force.
No, but
All
the
right.
force,
So
You
that's
guys-
the
you guys
force
disagree.
you're
Let's
putting
hear
on
what
it
Grim has
everybody
to
to
say.
stop it being at rest.
Right.
You see their trick page? They
When
do everything backwards.
You guys want to hear what
When-
Grim has to
Instead
say?
of
Yeah,
starting.
it's not that
can I just-
hard. I don't understand what his problem is.
Anybody
It's
wanna hear
really
Grim?
not that hard.
5 seconds. If you've got something moving along at a constant velocity, there's no force, it's
Oh.
not exerting any force, but when it hits
Love you,
something,
Brandon.
its momentum changes,
I
and that
tried, man.
change of momentum exerts a
did.
force. Finished.
I understand that. I was just trying to before we got too much further away, and then we kind of came right back into it, so it's good timing. The difference between the apple and the gas molecule, I thought Rumpus, maybe you should explain it more clearly to him, because he's using a false equivalence in my imagination as to, adding energy to the system, and then it makes the apple move, right? Like, it's not a gas molecule, and it's a different state of matter, and it behaves differently than a gas molecule.
Well, no, you can make an analogy of you could imagine the gas molecule and an apple being the same thing. Obviously, gas molecules are moving around at 500 meters per second.
Bro,
so
you're doing a favor talking about molecules, dude.
Except when I do it, I get applesauce. Hold on a second, Rumpus.
Doesn't mean to say they're not moving.
Excuse me.
About gas,
God damn it.
dude.
Hey,
ahead,
guys, hey, 1 second. I don't want to be rude and weird here, but when I imagine that, I imagine applesauce, because gas molecules have elastic collisions and apples don't.
Correct. The molecules inside them have elastic collisions. So the molecules that make up an atom, make up an apple, will have elastic collisions. But the apple itself, on a macro scale,
right,
does not
I
have
imagine atomizing the apple. That's the problem they're having, though. They're trying to decipher the.
No, you can't.
Separating it.
Hold on, let Grim V make his point, please.
Yeah, Grim, don't use air, dude, because he's going to say that invisible molecules are moving 500 meters per second. Okay,
I'm not disagreeing.
I
can show you air stationary.
Brian, this might surprise you, but I'm not the one disagreeing with him.
He can't show me still air moving 500 meters per second. He can
theorize
it. No, I could show you air sitting still, stagnant.
No, you can't. You can't see. You can't see the atoms. You can't see the molecules, Brian. They're all moving around at 500 meters per second or more.
Can you show me them molecules moving?
Can I show you an individual molecule? Well, obviously your eyesight can't see that.
Can you show me the bulk of molecules, air molecules moving? The answer is no, you can't. You're in la la land.
We're in reality, man. Bulk is not the question. The individual components inside look at Brownian motion, for instance. If you were to put a little bit of pollen inside that still air.
I'm not talking about your
Brian,
model.
Let me finish, Brian. Nearly there.
Reality,
Brian, nearly there, Brian. If you were to look inside your balloon or whatever it is of still air, and you under a microscope looked at a piece of pollen inside your still air, it would be jiggling around like crazy due to the movement, the high speed of gas molecules.
Pollen is organic, dude. I'm not.
No,
why are
it's
you
not.
talking about pollen?
Because
Can
it's
you
a
show
small...
me air in motion under a microscope?
It makes sense.
A tiny little bit of smoke particle. Then you would be able to see a smoke particle under a microscope being
Once
moved
again,
around.
folks, flat Earth model can demonstrate air stagnant in a tank, just sitting there. Any kind of gas we could show stagnant. And in their model, they cannot show molecules moving 500 meters per second. They can create the math for it, but they can't demonstrate it. Once again, they can't demonstrate shit.
Does this rag smell like chloroform?
Brian, there are experiments you can do to determine the speed of the molecules in a gas. So, for instance, there is a thing that's got a rotating disc-like thing, and you can show that the molecules are moving at 500 meters per second in what you would regard as still air.
Rumpus, without heat, they couldn't move, could they?
Correct, and they're there at 25 degrees C.
Hang on, so the air molecules are moving inside still air.
Correct.
Are the air molecules the air, or is the air? How can air molecules that are making up the air be moving around at 500 whatever inside still air?
That's what they do.
That's what makes them hot. The air.
That's their model has to have that. You know, all the bullshit is backwards.
Earth are you
Paige, everything about their model is backwards to reality.
You just don't.
He's literally saying the air molecules move around inside a medium made up of air molecules.
The molecules.
It's not moving.
Right, Paige, just try and get this right. Air is made up of...
No, Rumpus, I don't... No.
Yes. Right, the air molecules...
I don't want to hear it. Go on with somebody else.
Don't bother then. Okay, I won't ignore you. Right, carry
Tell
on,
me again,
Mr. Grimsby.
No, tell me again. Tell me.
Okay, so inside any air you're looking at, so let's talk about nitrogen. Let's be specific. The nitrogen molecules that are in the air, even if you were to put them in a container...
nitrogen gas? And you're talking about invisible nitrogen gas, correct?
Yes, I am.
Okay,
they
go
are
ahead.
moving around. Oh, Jesus. They are moving around at about 500 meters per second. Some of them moving more quickly, some of them moving less quickly, but about 500 meters per second.
How do we measure
Did they
that?
break Brian's law?
I just want to ask the questions, please.
So once they've got that velocity, Brian, they don't lose it.
Yeah,
Go ahead,
did they break Brian's law though? A force had to be put on them before they could move, right?
Brian, that's what temperatures I was explaining to you earlier. Temperature.
Did they break Brian's law, Rumpus? Did they break Brian's law?
No, they didn't. They are moving around at 500
Thank
meters
you.
per second
So
inside.
anything at rest, an object or a
Let me know in the chat if you want me to keep this open. I'm happy to do so. These guys are, I'm just letting them go. So you guys want to listen to more? I'll keep it open. If you've had enough, just wave the white flag and I'll shut her down. There was a super chat like 3 hours ago that I forgot. My apologies, Ranty. He asked a question. 2 pounds from Ranty. Shout out. Thanks, Ranty. How much is Rumpus paid per episode? Actually, to tell you the truth, I am paid by the state to do a psychological assessment. So a lot of money. So just so you know, he's not paid anything, although not by me at least. But that's a good question. Thanks, Ranty. All right, we'll get back to it. I'll look for the thumbs up, and we'll see if we keep going. Thanks, guys.
Move.
To initially move, I mean, imagine there's a stationary molecule. Imagine
So there's your force.
No, listen.
The
listen.
heat that made him move. No.
Listen.
Enough,
Okay,
enough of your
I
nonsense.
won't talk to you. Okay, shut up
point
then. Shut up then.
Rumpus.
Let Grim V carry on if she doesn't want to listen.
Okay, so they have a little bit of a point in my point about the gas molecule being able to hold the energy to continuously move at all times, right? But the easy explanation to that would be anything over absolute zero will add the energy necessary to a gas molecule to keep it moving in some way or another. Right?
exactly Brian's law.
Right.
Well, that's the definition of temperature. The definition of temperature for something is how fast it's moving.
Correct. Also, pressure, right? How much of a thing is in it and how fast it's moving.
Yep.
Well, the pressure
They're
a gas
relative to each
exerts.
other.
The gas, the pressure the gas,
another one of Brian's laws.
The pressure the gas exerts is dependent on the density of the molecules inside it. And
okay, so you
hold on,
see
let
how
me finish.
they're getting
Nearly there.
Oh,
Let me just
okay.
make the two
No,
more
all right, go
points.
ahead, buddy.
The pressure that a gas exerts is dependent on three things: the mass of the individual molecules, the density of the individual the mass of each individual molecule, and the velocity of each individual molecule. Go ahead. Three things.
Agreed. Yeah. Yep. So that we're agreed on that. So I'm in my what I'm seeing there is the two ways to skin a cat, right? Like we have one explanation to skin the cat, and then now there's this other explanation that isn't a solid explanation either, right? But neither are an actual solid explanation because at some point you have to. It's faith based. But one of you is
I haven't heard
sure
what these
that
two
it's right.
explanations are.
Well, I was listening to both of you, so I've heard him.
No, you said there were two explanations. I didn't hear what are you talking about? What explanations are you talking about? Mine
I was
explanation is one of
listening
them.
about. Well, no, his
In my new model,
disequilibrium and
there's also
equilibrium.
no.
Sorry, could you explain to me what your two explanations you're talking about are, please?
So his not mine because I agree with your model absolutely.
Right.
But what I'm saying is it's a different approach.
What's
the
the
different? Kind of understand what they're
Okay,
saying.
well,
because-
if you're agreeing with him, dude, then hold on. We need some contention here. Hold on.
well,
Then
no,
you go
I am
against
the
me.
contention. I mean, I'm obviously
No,
because
you're
I'm trying
not.
to
You
show.
just said you agree with him, dude. I'm the contention. Okay,
Well, I
Rumpus,
also
let me tell you some more
I
about
might
my
agree
model.
with him, but I also
Okay, my
I
model
agree with
doesn't
him,
say
but I also
energy,
admit that
cannot be
it's
created or
faith-based.
destroyed.
Faith-based,
My model
right?
refines the
At
energy.
the end of the day,
So you can't call energy motion 1 second.
this guy doesn't know
You
when
can't
his
call
hand
motion
is.
energy and then heat energy
I'm
and then
literally trying to
temperature
help
energy,
you out.
electricity energy. My model it breaks it down more exclusive, man.
Brandon, is this
so it ain't-
cool? Is this guy
energy can't
supposed
be
to do
created
this?
or destroyed.
Like I'm
Brian, you're
literally talking right
interrupting
now,
him.
man.
Brian, you're interrupting. He was making a point, and you've
He's
interrupted
fucking
him.
agreeing with you, dude. He's
So
agreeing
what?
with you.
He's
Just
allowed
Just
to
because
agree
I'm
with me, but
agreeing
it's
with him
his
doesn't mean
turn
I'm not
to
allowed to
speak.
talk,
You let him have a
motherfucker.
go. You
I
had
don't
quite
get
a
who
long
the
go.
fuck you think you are right now, dude.
Go ahead, let Grim get his piece in. Go ahead,
Son
Grim.
of a bitch. So what God damn, if you only knew you get more flies with honey.
Hey,
than
Grim.
using-
This is Friday
Yeah.
night fight, so we just kind of keep limited moderation. I know it can be frustrating sometimes, but that's
Yeah,
why
Friday
it's
night.
so loosey goosey.
Please get to your
Right.
point, Grim, before we all die.
Right. Okay. So all I'm saying is I'm seeing that they have, they see an actual argument involved in this, which I actually see their point in, except for
Which
the direction,
point?
the vector.
Which point?
Right. what they're talking. Dude, try to pretend like you've been listening to their fucking argument for a minute.
Well, I want to know
you
what
gotta
you
make
think
me
their
repeat
point.
their
I
whole
don't think they've
entire
got a
argument
point.
is.
I don't think they've got a
Grim,
point.
agree with Brian's law? Grim, do you agree with
What
Brian's
point
law?
are
that's
you
what I'm
agreeing
saying.
with
That's
them
why I'm
about? You
saying
keep
you have-
on using ambiguous terms. Be specific.
Let him
Bobby, your mic's
finish,
open again.
Rumpus, and you'll get to it.
Yeah, stop being so fucking impatient and weird
Oh,
about it.
God.
I'm trying to formulate what I want to
Oh,
say.
Jesus Christ. You've
Oh,
spent
look at
5
that. I don't
minutes
think you're
not
cut out for
actually
this,
saying
bro.
what your point is.
Seriously, I really don't think you're cut out for discussing things with
No,
people.
you're
the
not
way you
cut
act
out
and
for
behave
making a
like an only
point.
child. But the
Get
point
on
is,
with
I'm
making
trying
your point, for
because
Christ's
I'm
sake.
trying to do it delicately,
Don't
man.
be
You're being a
delicate.
fucking.
Tell us what your point
Oh,
is.
Rumpus,
my
just
Jesus
stop so he
Christ.
Man, you're
can.
such an utter.
Why can't you let him do it his way, Rumpus? What the fuck,
milkmaid.
Because
man?
we've got about
Yeah, 'cause
5
he has
minutes.
to
Not everybody acts
We've
like
got
you.
5 minutes of
everything.
him not making a point.
Then leave,
Because
dude.
you won't
I don't give a
stop.
shit.
No, he's just not making a point.
Yes, it's you, Rumpus. You take up all this time. You are the
Right.
one
Well,
that
I'm
wastes
trying to
this
use the
Very
time.
time
distracting
efficiently.
Just
We've
right
had
stop
5
talking. Put
minutes of
yourself on mute.
Listen, he's just paid. He's just
Put yourself
distracting.
on mute,
It's
and he
on
would have been
purpose.
done by now.
No, he wouldn't.
Yeah.
He'd be telling
Yeah,
us how he was
obviously.
agreeing or not agreeing, or agreeing slightly or not agreeing quite so much,
So you have
or
to keep
possibly
going
agreeing in
and
the
waste
future
more
about
time.
something.
Good on you,
He's
Rumpus.
not
Well,
actually made a point yet.
All right, Rumpus, come
But
on.
actually,
You
I have.
monopolized
You're just being a fucking
monopolized
pedantic
enough
little
time, man.
shithead.
Just shut the fuck up for a while, will you?
Yeah. Thank
Please.
you. So here's the point, and I'll try to wrap it up in less than a minute. So I agree that they can they have some good points initially, except for the vector issue about their
No, I don't
equilibrium
know.
disequilibrium argument. You shut the fuck up. Nobody asked you anymore. All right. And of course I obviously understand it a little differently, but I could still be wrong too. And both I have to admit, like I was saying, that even at the end of the day, even what I believe is faith-based, and I don't stand here like Rumpus and say I'm right. So there's a difference between me asking questions, right, coming from the place just because I believe that it's mass attracting mass. It's not the same reason. It's not because of space-time curvature, in my opinion. Blah 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 blah. So there's a whole different explanation. But the thing is from your, I can see what I'm trying to show is compassion to the other side, because I can see where you're coming from and how you see that there's
that's
two ways
awesome.
to
Thank
skin
you.
that cat. Yeah, and he's
Yeah,
being such
because
a
it is.
fucking
There are two
ridiculous
ways
asshole.
to look at it.
Yeah.
It's
Take
like
your
all the
compassion
other
and
things that
shove it
we
up your
have,
ass.
things that we found out about the
no shit.
moon and stuff like that.
Shove your-
They don't want to
shove your
accept
compassion.
anything is changing. It's like, the old guard's still standing there, the new guard's coming along, and we're trying to push them out of the way, and they just will not budge. Like, fuck.
My first law is motion can be created or destroyed, and the heat, electricity, and pressure can only be transferred.
Oh, now no one wants to talk, huh?
That's Brian's first law. But yeah, my other law, once again, if nobody heard it, was
I think everybody
anything at
agrees
rest
with
will
that.
stay at rest unless acted on by force. Okay.
They better.
And of course. So my model's going to narrow things down a little bit. I'm not going to go crazy with it, but I'm going to narrow things down.
That makes sense.
I'm not just going to call energy any kind of energy. I'm going to narrow it down. And basically, motion is what creates all energy that we know. So motion can be created or destroyed. We can create motion or we can terminate motion. But all the energy that comes from the motion, okay, but I'm not going to call it energy. I'm going to narrow it down because it's only a few things, can be only transferred. But
right.
motion can be created or terminated.
Nice, Brian. Nice. Yep.
But those are the actual, those are laws of, that's what do you call Brian's law?
That's the second law of Brian Leakey.
Yeah, my second law is basically that anything brought out of disequilibrium will find its way back to equilibrium.
So how do you know where its equilibrium is?
It's either going to be at equilibrium or it's going to be going or trying to achieve equilibrium.
I think it's when it
So
stops
how do you
moving.
know where it is?
That's what
What if something
happens
gets in
when you
its
die.
way, though? What if something just gets in its way? It still wants to
Then
move,
you'd have
though,
to
but
apply
that
back to
something's
the
in its
Brian's
way.
first law, because Brian's first law says that motion can be terminated.
When it's when something in its way, it's not in equilibrium, in my opinion.
Right. Me
Yeah,
neither.
but
It's
its
then now
progress
squishing
towards
up against
true
something.
equilibrium is impeded. It can't be achieved because something's blocking it.
So the question still remains, right? Where is equilibrium then? Because we need a control to understand that we're right. So we need to grab
Complete
something and put it
rest.
in
That's
equilibrium.
that counter space. You can't.
And to be sure that something's not in the
The
way.
creator. You can't get
It's
there.
all relative, right, Paige?
I would say
Well,
it's
now
motionless.
we're back to hogwash, right,
and
guys?
it's not, I
Even
would
by
say,
our own definition.
Hold on, I got a
It seems
definition.
to be that
I got a
things are in
definition.
equilibrium when things are in the ground.
It's motionless and it's not it's not producing a force in any direction.
Second you put motion in, you create that torus field immediately.
Huh?
Yeah, if
That's
something's not
motion.
cooling
That's,
down, if
that's
it's not
light.
heating
That's
up,
matter. That's
you know,
light.
And Brandon's right. It applies to everything, though, Paige. If something's not heating up or moving up or pressurizing down, moving down or getting cooler, so up, it applies to everything, not just temperature or physicality, height, and shit. So if something is not trying to get hotter or cooler,
I'm going to tell you
See,
what.
that
If
tells
I'm
me
going to keep
something
telling
had to have
people,
created this
if
place
I'm going to
because
keep
something had to
telling
put it in
people that
motion.
something's trying to get somewhere, right? And I'm going to keep saying it's trying to get to this particular place. This thing's trying to get to a particular place. I better know where the particular place is for all these things or any of these things, right? But I don't. So why am I saying it's trying to get to this particular place that I've never been to and I have no idea about? And you're so sure about it. That's what's weird.
Walk outside.
That's what's freaking me out right now. And you said you're a skeptic and you're just making up your own stuff.
Well, who said it's getting to some place? Maybe I missed that. Well, who said it's getting to a particular
that's what
place?
equilibrium is, right? A specific where is zero equilibrium? Where is that?
There's no motion and there's no force being exerted by the object in any direction.
Well, no. If the ground was equilibrium, if the ground was equilibrium, I would.
The ground isn't equilibrium. No, the ground
was
not
equilibrium. Why would I be squished up against it?
No, I think it would be. It would have to be complete stillness.
The ground isn't equilibrium because it's
what I'm trying to say.
creating a
Something's
force.
me to it. That's right.
Right. So Grim,
Pushing me
Grim,
down
that's
to
where
it.
we start.
Exactly.
We start when we wake up. When we
No,
wake
the
up,
object is the one that is exerting the force downwards.
So this is where I'm at with it, right? So I'm like, there's.
Let me say this real quick, y'all. Let me say this.
How do I
When
keep saying
we first wake up and we open our eyes, okay, we whatever's room temperature, room pressure, and ground level, that's your equilibrium right there.
No, because I still weigh something.
So our whole model starts on Earth and not in space.
No, I think if something on the ground is still exerting a force downward, so it's not in equilibrium unless it's suspended.
Agreed. I'm
Brad,
trying to
can I
figure
explain
out where
myself when I say
equilibrium
on
is.
the ground?
You're suspended.
Equilibrium
if I keep
can be
digging
anywhere.
down
It's
and
just
down and down. Do I?
So it seems to me that when things are not touching the ground somehow, it seems to me that they're out of equilibrium. Even the fruits, when they're not off the thing, they're still touching the ground because the tree is on the ground, right? It's only when it lets go of the tree that it starts going towards the ground. So when things touch the ground, they seem to be in equilibrium somehow.
No, because then they actually.
Well, what if they land on top of a hill and then you magically make that hill disappear?
No. If it's exerting like an apple hanging from a tree.
It's on a scale. It weighs something. It's not.
But it's exerting a force downward still.
It's trying to go that direction.
Brandon,
gas is still on.
Apple, wait. You're trying to break my third law. Hold on. That apple grew from the ground. It took force. It took sunshine. It took water and all kinds of minerals and shit to get out of equilibrium. And that was the ground to begin with, dude.
No.
You're trying to break Brian's third law, bro. If the whole valley, if the whole apple orchard
how
flooded
deep
with
into
water,
the ground does it need to go to come back to
if
from
the whole
where it
apple
started?
valley flooded
Because
with
it seems to
water,
me like the apple
then it
would
would
keep
want to go
falling and
up.
falling and falling all the way down to the deepest
Yeah,
hole you
the
can dig.
apples would fall off
we're
that
in reality
stem
here.
and,
It's
and
weird
float
because
up.
none of those materials came from that
The
deep.
water goes down further than that. I mean, let's just say this. There's more air and water on this Earth. We've only been 8 miles down on continents
It just
that only
doesn't seem
cover
like a sound
30% of the
theory or
Earth's
idea
surface
to
that
me,
we
bro.
know of, okay? So there's more water and air than there is land. So we're not just going to go by what solids do. We're applying it all together. So we're starting off
but we're
on
not.
the ground when we wake up. A seed is planted in the ground. The seed is planted in the ground. The roots, the roots grow down.
Nobody's
the
even
fucking apples
interrupting
grow
you.
up. Okay, hold on. The roots grow down and the apples grow up, guys.
Whoa.
Oh, Brian, you're out
Holy
of control
shit.
tonight, buddy.
He's on fire.
Yeah, or something. He's on something.
Acts normal as when it's connected to the tree, right? As soon as it collects all the molecules or whatever it needs to grow real, and it breaks off the branch. As soon as it when it breaks off, that initial thing is no longer touching the ground because it's off the tree. So it rushes towards the ground. It seems that everything out of this equilibrium wants to go to the ground somehow.
No, it's already trying to get to the
y'all. My
ground.
law
That's
is,
why the branches are bending towards the ground because of the
my
heaviness of the
my
apple.
other law is
Stop
if
it.
y'all want to hear the rest of my law is if you bring a solid, if you force a solid out of disequilibrium in a medium of air, it will fall at 9.8 meters per second due to disequilibrium. Same thing with buoyancy. Buoyancy would be the buoyancy equals the density of the object times the volume and the amount.
Effie, your mic's open. You're making scratching noises.
So that's
all I have
what
to
they
say.
was
I
using
really
for
don't
gravity.
like rumpus.
Is now due to it's not due to gravity. It's due to disequilibrium.
So the apple hanging on the tree, in my opinion, is not in equilibrium because it's exerting a
definitely
downward
not
force.
in equilibrium. Yeah, no. It started off at the ground
For
as a
another
seed,
reason altogether, though. I'm Grim. That's Brandon.
Yeah, thanks for that. Anyway, it started at the ground as a seed, and then it was forced up in. I've seen trees raise driveways. I mean, all the time actually, sidewalks. Okay, it's a force. Them trees growing upwards is a force. Them roots are going down, and the trees and the apples are going up out of equilibrium. Okay, they are most certainly up off the ground and out of equilibrium, wanting to go back down. That's what gives weight, is the 9.8 meters per second due to disequilibrium. That's what causes weight.
You're agreeing with me. I don't
There's
understand
no force.
what the problem
There's no force. The force was getting something out of equilibrium. So the apple grew up in the air. The trees and the roots that broke the driveway forced the driveway up in the air. When it cracked it, it forced the apple off the ground. Okay, the sun caused that. It's all intertwined. So if you lift something up, that's the force. There's no
but you
force.
can measure a force on the apple. That's like ancient history. I'm talking about a snapshot in time. We look at it at this instant.
Right. You can measure the force.
Is exerting a force downwards.
Okay. I broke off.
You can measure the kinetic energy.
It wasn't the roots.
But
It was
you
pressure.
can't get there without the potential energy to begin with.
It was
It
pressure
can't get there without putting the potential energy in to start with, right?
It was the pressure that it applied to the sidewalk. That's what moved the sidewalk, not the root. It was the pressure.
Yeah, the pressure. That's fair enough. I'm good with that. But look, the point is you're not going to get nothing out of equilibrium without a force. That was the force, Brandon. The force was getting it up there to begin with, whatever you want to call it, pressure, force, temperature, all that shit.
And isn't a tree constantly growing, therefore constantly exerting some sort of force?
Expanding. It's expanding. The concrete doesn't flex; it just breaks.
We're talking about trees. Don't trees constantly grow? Do they
Yeah,
ever
that's what
stop
I'm talking
growing?
about.
Yeah. And what is that? If you
just-
put a
It's just wood growing.
Is it that
getting
not a
bigger
force
and
growing?
bigger.
Not a force?
No.
Oh, so if you put a little seed inside concrete,
No,
it
it's
wouldn't
not
do
force,
nothing?
dude.
What would happen?
It's the forces in the tree.
Oh,
growing
the
are
thing that you
electric.
just said, it doesn't happen, right?
No, the forces in the tree that make the tree grow are electric. That's basically an end chemical, right? But they're in the root, right? It's
still the tree though.
Coulomb's law, and a whole bunch of cool stuff. But it's not like a particular rate. It's like
There's no force.
there's no constant growth rate to that. There's no you can alter that by pH or, you know, the wrong minerals or not enough sunlight, or, you know, that's a completely separate entity together. Then you're trying to equate it to the acceleration we measure. Right? That doesn't, you don't want to do that. I mean, we already look pretty silly trying to be alternative cosmologists, but we don't want to go so that there's no connection to that. And
I just want to keep it here on Earth, okay? And all these laws apply to vacuums and fucking Brian's laws start here. They start when you open your eyes.
I feel like
anything that
friends
comes
like
off
that,
the ground,
right?
it takes a process to get it off the ground. Nothing just comes off the ground. It takes heat, it takes pressure, or it takes a process. It takes something. It takes some kind of force. Or in my model, temperature is definitely a force. Anything that you can use to disequalize something is absolutely a force. Okay.
All right,
And,
let me read something real quick because it's been a while. Ilabaka, CLP 2500. If air molecules are not in motion, how do you guys explain gas pressure in all directions in a balloon? Molecules move when there is heat. There always is.
Heat.
I don't know who that was directed to, but maybe you guys know.
Yeah, I'd say it's heat. You know, you can have stagnant air, stagnant water. As soon as you start applying forces in Brian's laws, heat, pressure, you know, or a physical force, as soon as you start adding forces, then they're moving. And if you can show me under a microscope invisible air molecules moving around, I understand y'all need it for y'all's model, but we don't have outer space with a damn near perfect vacuum. We have a container up there, and that's why shit gradiates down and settles back down to the bottom. Everything settles back down to the bottom, just how we see it here on Earth. So everything applies to here and now in reality. So and we can demonstrate every facet of this model, every facet.
Okay, well, there's a lull.
There's only one thing you can't demonstrate, whether or not there's a 24 Antarctic sun.
Real quick, shouts out. Real quick, shouts out to my Doge holders and to all my Doge holders. Keep your head up.
Hell yeah.
I think if you go to the flat Earth model, he models all the planets and the sun and on the Earth. I think he has a 24-hour Antarctic sun in our model. I think.
The only way that it's demonstrated is with a field of view with a personal dome. That would be the only way to possibly demonstrate the concept of it. Right?
Yeah, but remember, our model is just applying just to Earth. So our model applies to Earth, and then it stops to as far as we can physically demonstrate. So the sun, we're not that. Yeah, we need to
nothing to see here, folks.
But I did show that the angle of view over 8,000 miles. If you're looking across a plane of 8,000 miles, 3,000 miles of vision would be compressed down to a field goal post. You'd see 3,000 miles inside of a field goal post at the 50-yard line.
Nobody believes you.
It's trigonometry, man. I mean, go to the triangle calculator and put in 8,000 miles for your size, and then put in 3,000 miles for your right for the the vertices, whatever you want to for the other angle, and then pretty much check the angle for your 50-yard line. They're pretty equal. 3,000 miles compresses down to a field goal from the 50-yard line over 8,000 miles.
Hey, real quick, illegal and actually, I think FE. I don't know what's going on, but I'm getting reports that people think their mic is muted, but their microphone is actually open, and we're getting a lot of people with open microphones and noise coming through, and I'm having to mute them. So just double check and make sure your microphone is muted if you're not talking.
Blue got me with the first debate I ever did. It was about 4 years ago, man. And I had confused gravity with, I thought they were calling the 9.8 meters per second squared. I thought they were calling that an inverse square law. And I wish they'd have told me and saved me some humiliation, because it's not an inverse square law. They like to say 9.8 meters per second squared, but then when you get them technical, it's 9.8 meters per second because the meters aren't squared or the seconds aren't squared. But technically it is 9.8 meters per second squared. But like I said, that was a long time ago, so they done have me brush up on all my math since then, man. So we're, I'm trying to create some shit, trying to create a model. I'm trying to create the simple math for the buoyancy, but we don't really need any separate math, because all we need to do is the 9.8.
Technically, it's not 9.8 meters per second.
Right.
Per second squared or
Yeah,
whatever.
can you
It
do some
depends on the
simple math
item.
for a vortex?
It depends on the
and like
object's density and the medium it's in.
Hold on, Brian. Is the 9.8 meters per second squared, is that big G or little G?
It's little G.
All right, good work. Pop quiz.
Basically, you just take out your
Pop
stop
quiz.
That's why they're always real
long it
careful
takes
to
to
add
fall
in
down.
due to gravity. They always say the force due to gravity. Okay, there is no force.
But the thing
force
is, it's
getting
not
the shit up there
necessary
to
that
begin
it goes
with, right,
to the
guys?
center of mass. It's just an average that you get when you pull out your stopwatch or whatever. There's no part of it that's necessary. Mr. Grimm, were you trying to say something?
No, but hello, what's happening? It's always a pleasure to hear from you.
Thank you, good sir.
Listen, I just want to say one thing. Lemonade was a popular drink, and it still is.
Delicious.
Yep, lemonade's fine around here.
Thank you. It is quite good. But I think basically they just pulled out a stopwatch. So just pull out a stopwatch and see how long it takes to fall through the medium. And just reapply it to another way of thinking about the problem.
And then if you want to debunk that it's a force, just drop a ping pong ball and a golf ball, and they tell you it's only air resistance. Then they have to say, no, it's the density. The golf ball's denser, even though they're the same size with the same air resistance. And then you try and bring something at the bottom of a lake. They want to say buoyancy is a force. Bring a beach ball half pumped up, where you could lay it flat on the bottom, where it's not displacing it's only displacing half the water. It's not pushing it downward. Or you could even take a piece of plastic and cover up the beach ball at the bottom where it's not touching the water. And it's still going to come up, man. And a vacuum chamber.
The only assumption that changes is that it's pulling to the center mass.
Why would a vacuum chamber float in their model? Okay, a vacuum chamber, there's nothing there to displace the freaking.
I would say that there is a background medium in the vacuum.
I'm opposite on that. I'm actually opposite on that one. But there's a lot of.
I'm going to have to say that there's an etheric medium within the vacuum. So I'd say that there's always a medium present.
Yeah, it would still displace the water.
Or ether mixed with something else.
But check this out, though. So I got to thinking about it, and I was like,
so
dude, do we
why
really
does it
need...
go up, though? Why does the bubble go up? Why doesn't it just go to the left?
Because it had to get taken out of equilibrium. Something had to heat up down there underneath the water, or some force had to, according to Brian's law, some kind of disequilibrium had to be put on it to even force
It
to
doesn't
create
go
the
to the
gases to
left
begin
because
with.
the bubble, not Beyonce.
Let me say one more thing, y'all.
These
One more
bubbles
thing
are
before I
coming
gotta
from
go.
the.
This would be my
What
closing
if
statement,
these
y'all.
bubbles are coming naturally out
Hold
of
on,
the?
Grim. These are my closing statements, buddy. As they talk about the oxygen. Fuck. Sorry about that. They say the oxygen is created from plankton and shit along all the coastlines and all that, especially during the heated areas. I think that they could be mistaken where that oxygen and gas is just created from evaporation, and they show coastlines up to like 100 miles off where the plankton are, because they never really, because it's not warm out deeper in the oceans. It's where the water's warm and where it's evaporating.
The
it's
bubble
not the
rises
animals.
trying to find
It's
the
not
air.
photosynthetic animals, right? It's
My
just,
bad.
It's the salt water. It reacts different than the fresh water. Okay,
The bubble rises
it's like an
trying to get to
electrolyte.
the rest of the air, probably. And it's
So
probably
that's where the oxygen's coming from, man.
Maybe
That's where the air's coming
Brian,
from, is all the
Brian,
coastlines and all the shallow salt waters of the
yeah,
earth.
Brian,
the
maybe
plankton.
also it does it, but not the plankton, because we know that the plankton does it also, right? Because we know, but you could put them in the laboratory and study them, and a lot of people in college and stuff, we did that.
Why don't the
What I'm
air
trying to
cause
say
the
is that-
plankton?
No, the plankton creates oxygen.
Yeah, but the way
It
they prove
turns
that it's the plankton, okay,
sugars
plankton
and shit.
is classified as animals, bro.
Okay, so they're saying they're photosynthetic animals, but they say that they say because it only happens on the coast. Yeah, well, that's where the water's heated up. Okay, in the deep oceans, it mixes together, and you don't get as much. Okay, so they still, so they say most oxygen is produced the first 50 miles or 100 miles of the coast.
Yeah, I mean,
that's where it's shallowest.
But what about us humans? We kind of migrate popular around the equatorial regions. Does that mean?
Not considered animals. You have two kind of plankton.
Whoa, we're not. Okay, because I thought, well, they got fauna and flora, right? And bacteria and microorganisms. I can barely hear you. Hello?
Well, there was a really far out theory from an Italian flat earther. He said that there might be basically organisms in the waters above, and that their, bioluminescence might give us our nebulae and our stars and our nebulae and what we see as space phenomena in the waters above. That's pretty far out there, but maybe he's on to a little something.
You never know. For sure.
Lots of water in space. But I guess I'd have to see something darting over the firmament for me to really glom onto it totally.
What if they were really passing down some like scientific shit, like, hydrogen ions from the sun interacting with oxygen,
Thanks, buddy.
causing water to come to Earth from, star water, basically, in a way.
I think
Plasma
science, in a way, tries to
recombination.
keep it scientific without saying that too many far out weird things are alive and, changing the, scientific scenario.
Paradigms.
I think the only thing that's allowed to be alive is something at our level of biotic life. We're like the highest life form or some sort of alien that has similar biological needs to us, but nothing like a deity or a god or anything beyond humanity.
Well, here we are, thought we knew just about everything there was to know, and then about, what kind of, what consists of a good medium for life, and then we find these little damn shrimp that eat cyanide like, I don't know, a decade ago or something, and it's just like, all right, that changes things. Now there could be life.
Cyanide's a mineral, dude. Cyanide is a mineral. If you don't take too much, it's not poisonous if you only take tiny little bits of it.
These little guys turn them into sugars and stuff or something and just eat it. It's crazy.
And also with amygdalin,
strange. Go ahead.
With amygdalin and bitter apricot seeds, which is highly vilified by the synthetic medical industry, it becomes a form of cyanide that is specific for the cancer cell. It's eaten up by the cancer cell almost exclusively, and the reaction in which it's eaten and kills the cancer cell nourishes the surrounding cells with amygdalin. It's basically a package of cyanide with two sugars, and cancer loves that stuff. So that's why they say bitter apricot seeds and laetrile and amygdalin is effective. So I guess it just depends on nature's packaging, not just the stuff itself.
With horses, that's why they say horses love apples, because they get high by eating the apple because of the cyanide in the seeds.
Cyanide is.
You could live off I don't know for how long, but off steam, breathing just steam.
Yeah, cyanide is a mixture of carbon and nitrogen with a triple bond between the carbon and nitrogen. They're called nitriles. They're from unripe fruits, pits, other places, nature. Some gas, hydrogen cyanide gas. But no, it's not a mineral.
A mineral has to come from the earth, doesn't it, or whatever?
Sorry about that. I mean, it's
Well,
natural.
it can include minerals like sodium cyanide, potassium cyanide.
Well, we're changing all the laws tonight anyway, Jimbo. So Brian's law, cyanide's a mineral, man. No, I meant that it's natural,
Yeah, it is natural.
Even things like mistletoe have anti-cancer compounds because the poisonous stuff within the mistletoe is specially formulated by careful chemists to make an anti-cancer compound, but it has to be carefully regulated. But there's different things that if they're in the right package or the amount from nature appear to be even beneficial.
Arsenic? Lemon, don't mistletoe have like
I don't know.
arsenic? Or it's got, I think it's arsenic or some poison.
Probably does, but I don't know what the poison is specifically.
But it's hard to call something a poison just because it's poisonous to us, so we should refer it
Well,
to poison. You know, it's like it might be a shrimp's delicacy, like the cyanide he's talking about. If it's natural, then something eats the shit.
Well, if you're talking about something that's harmful when you consume it, it depends on the amount, how it's mixed. Even water can cause, they say, water poisoning. When there's so much water in your body, it's leaching stuff from the body. And like what happened to the woman who held her wee for a week, she got a headache and died, probably because all of her, minerals were starting to leach into the water or whatever.
That's a good point. So I think what they meant by relative, I think they were onto something. So everything in nature is relative, basically, and it's a harmony. It's God's way, and it's they put relativity and put it to outer space and brought extra dimensions and of bullshit and new geometries, and it's just like that's where and look, what have they made since then, dude? Like I said, the airspeed record ain't even been broke since like 70 freaking years ago. We're still driving around combustion engines. It's still flushing toilets with a fucking knob. Nothing's changed, dude.
Well, that's the fallacy with knowledge. We have.
That's because you don't have to.
Hold
on, Lemon. That's because you don't know how to use the 3 seashells, bro.
Yeah.
I'm working on it, man. I'm working on it.
But that's the fallacy that occurs with knowledge. To have knowledge, we put limits on what is acceptable in the discourse of what is or is not, part of the knowledge. And so paradoxically, that allows us to have discovery, science, and stuff like that with those parameters, but it can lock us in from further revelation. And that's why sometimes we have to break out of those bounds to make new discoveries, get a new paradigm, and be set on a new track. So there's a bit of a play between the knowledge that we set up as barriers to make stuff knowable and the need to break those boxes and have additional revelation.
Hey, now that I'm not arguing and trying to get a counter argument in, dude, I really was tripping out when I went to the triangle calculator and I put in the 8,000 miles for the two sides, and then put in 3,000 miles for the width. I couldn't believe it, dude. Can y'all even think about that? Like where the sun is actually at, 3,000 miles to the whole North America, top to bottom, would be compressed in less than like almost actually half the size of a field goal post from the fucking 50-yard line. The math is equal. I couldn't believe it, dude. So that gave me a big shift on.
All right. I am going to shut it down. I got to go do some stuff and walk away from the computer. But I appreciate you guys sticking in there. Still got about 77 viewers, so I hope you enjoyed the stream. Oh, wow. Crazy night. Oh, Friday Night Fights is the right word. It was half fight and half just insanity. But it's all good. We'll be back Monday. Hope you guys have a good weekend. And take it easy. We'll see you on Monday night.